covered a bit of PMP introduction. We also covered the project management framework. We discussed about environment, project environment like organization process assets, enterprise and environmental factors, and also the role of project manager. We discussed in detail about the talent triangle. I hope you remember that leadership, the technical skills, and the business acumen. We discussed about it. We also discussed about the project management process groups, 5 process groups like initiating, planning, execution, and monitoring and control and closing. The 5 process groups we discussed at length. Then we also cover the integration management. The key responsibility of a project manager is to integrate the project, integrating the processes, knowledge areas. That's what we discussed, and tying up all the loose ends in the project. That's the major responsibility of a project manager. And we also covered the scope management. What is it in for scope? What should be covered? What is outside the scope? Then we discussed about the collecting the requirements, the various techniques, tools and techniques regarding that. We discussed all those things yesterday. I hope it was pretty useful. And you have any question on those things, Steve, at this moment?
No, not right now.
Not really, no? Okay, great. Okay. So today we'll start the session 2-day session with the project schedule management. That is the first knowledge area we're going to discuss about that today. As I explained, the schedule management has got 6 processes. If you look at it here, the project, the third digit of the number, 766, I hope you remember that number. So there are 6 processes in the schedule management. The first process is being plan schedule management. Once you plan it, you define the activities because any project will have various activities. So you need to define those activities very clearly. After defining it, you need to sequence those activities. Let's say, for example, a construction project. What are the major activities or phases you can think about? One is the laying the foundation, could be one activity. Erecting the pillars could be another activity. Then putting up the walls could be another activity. Then putting a roof, another activity. So once you define these activities, you need to sequence those activities. For example, again, in the construction, in this similar example, first you lay down the foundation. After laying down the foundation, you erect the pillars, then you put up the walls, then you put up the roofing. In fact, am I right? That is the sequence that you do have in. For example, in the software thing, it can be you design it, then you start doing that, then you test it. These are the various these sequencing the activities in a software development. So once you sequence it, you need to estimate the activity duration. Each of these activity, how long it will take. How long it will take to put up a foundation, how long it will take to put up the pillars, how long it will take to put up the walls and the roof, like that. You estimate the activity durations. Once you estimate those durations, then you will develop a schedule for the project. In fact, that's how many days. Let's say it has taken, let's say, 4 weeks to put up the foundation. Another 5 weeks it has taken to put up the pillars, another 4 weeks it has taken to put up the walls, like that. Then you estimate and add up all those things, so it will become your project schedule, in fact. Once you do that, the next important thing is you need to control the schedule also. In fact, if something is going wrong, if there is a variation in the schedule, you need to control that. This is all about the project schedule management. Very interesting, am I right? Schedule management, the develop schedule and you control the schedule. These are the 6 processes in the schedule management. Now let's go a bit of understanding the agile and adaptive environments that the present project work is going on. The adaptive approaches use short cycle to undertake work, and review the results and adopt as necessary. Yesterday we discussed about it, and you told me that you're quite familiar with some of these agile concepts which you're already doing in your projects. So I think you'll be able to understand much better. These cycles provide rapid feedback on the approaches and suitability of deliverables. What is very important is this thing is particularly in the large organization where they do undertake multiple projects. Let's say the companies like L&T, Larsen and Toubro, which I was giving an example, that they have large initiatives. Sometimes it is spread across the various countries also. The geographical distribution and in those situations, in fact, they need to meet the regulatory compliance of the various countries also, particularly, for example, if it is happening between Gulf countries and India or US and Gulf countries, both the countries will have some different set of regulatory compliance. Am I right? So the organization has to meet those regulatory compliance. That's also very important. And they will also have the mix of small projects and large projects. So you need to tailor it, your approach, in fact, whether what applies to, for example, small projects, not necessarily you can apply those things into the bigger projects. So you need to really make adaptive approaches, in fact, to address this full delivery of life cycle in the large enterprise-wide system, and adaptive approach or a hybrid approach, because sometimes it can be a combination of both adaptive as well as the predictive cycle that you may have to do it. I can give another example now. There is a lot of talking is going on to connecting the Mumbai city of India from Dubai. It's an underwater project. They have been talking about it, in fact. So if that happens, can you imagine that between Mumbai and Dubai, the distance is going to be covered in about four hours time. That is what they are looking at, a tube railway under the water project. If such things happens, the geographical area has been spread across, then there will be a lot of challenges. I need to really adopt to the requirement, in fact. That is what the consideration of agile and adaptive environments. But what is important to remember is whether it's a predictive approach or an adaptive approach, the role of the project manager does not change. He needs to apply probably the set of the management skills or the tools and techniques, but only thing is probably he need to make the suitable changes based on the cycle of, based on the approach or the methodology of the project you are going to undertake, in fact. You have any inputs on this, Steve? You want any feedback on this, or have you in your projects have you come across such things?
No, not to that extent. No.
Not to that extent, but I think you are getting a hang of these concepts. I'm sure about it. I'm right. This particularly the complex projects and the simple projects. What should be your approach? That's what basically we are talking about. That we are discussing about that.
Sure.
Yeah, that's great. So once you plan this schedule management, the first and foremost is the plan schedule management. Basically, like any other knowledge area, it's a planning is the establishing the policies, procedures, and the documentation for planning and developing the managing and executing and controlling the project schedule. The key benefit of this process is that it provides a guidance and direction how the project schedule will be managed throughout the project. This is the first and foremost, and this planning schedule management comes under planning process group. The importance of planning. There's a saying, Steve, that plan may fail, but you should never fail to plan. You've heard about that, I'm sure, with your vast experience. I'm right. You should never start a project without planning. Sometimes the plan may go wrong, but you should never fail to plan. So there's so much of importance for planning in the project environment. So the inputs, tools, and techniques and outputs of the process are here given below. The key inputs of the plan schedule management is your project charter. Yesterday, we discussed at length a couple of times the importance of project charter. That's the one which authorizes the project manager to go ahead. It will also give the authority to get the required resources, both physical resources, human resources, those things, financial resources. Then it is signed by your project sponsor. The project management plan, two important plans here is scope management plan, because based on the scope requirement that you are developing this schedule. So scope management is one of the important input here. Then the development approach, what approach you are going to take, whether it's a predictive approach or an adaptive approach, or it is incremental approach. So what's the approach based on the complexity of the project? Based on those things, you'll be taking it up. Let me make it slideshow so that. So scope management plan and development approach are the two important inputs here. Then we discussed yesterday at length about the enterprise environmental factors and the organization process assets, which are the other two important inputs for this plan schedule management. Now, the tools and techniques here, we talk about the expert judgment. As I told you that they are the subject matter experts. The project manager may not have all the required knowledge in all the subjects that he'll be doing in the project. So sometimes you need to take the expert judgment advice or the inputs or the help to carry on the work. Then you analyze the various data available. What is the plan? In fact, you look at those data. Then of course you have the regular meetings to discuss with your team members and key stakeholders, and what you get is an output of schedule management plan. Once you develop the schedule management plan, you need to define the activities. What are the various activities we have? So as I explained, that in a construction project, for example, the phases or the activities like foundation, erecting the pillars, and putting up the walls and putting up the roof, various activities, you define it very clearly. So defining the activity is a process of identifying and documenting the specific actions to be performed to produce the project deliverables. What is the key benefit here? It decomposes work packages into schedule activities that provide a basis for estimating, scheduling, executing, and monitoring. As I told you that, for example, the foundation, how long it will take to complete the foundation, you schedule it accordingly, then you execute it, and while executing, you also do the monitoring and control of the project. What are the key inputs here we talk about? One is the schedule management plan, which is the output of the previous process. Then the scope baseline. One of the three important baselines we keep talking about: scope baseline, schedule baseline, and the cost baseline. So here we take the scope baseline in the previous knowledge area which we discussed as an input. Then you have enterprise environmental factors and organization process assets. These are the other two important inputs. Now, the tools and techniques are two important tools and techniques here. We talk about the decomposition and rolling wave planning. Yesterday we discussed about the rolling wave planning. I hope you do remember about that. This is, let me just show this. You're able to see the screen, Misty? I hope you're able to see it. Hello? Hello?
I'm here.
Yeah, can you see the screen? You're able to see the screen? Okay, great.
Yeah, so, I do now. You've got foundation, okay, pillars and walls. Yeah.
Yeah. This is the rolling wave planning that yesterday we discussed. So I thought, let me once again repeat that. It's also called as a progressive elaboration. This is a very important tools and technique in schedule management or even the cost management. So here, what we talk about is the work to be accomplished now, planned in detail, and work to be accomplished later, planned at a higher level. Let's say, in fact, you're doing the foundation work, and doing the foundation work, you plan in detail, in fact, what all you require to lay the foundation. For example, how much cement you require, how much concrete you require, how much sand you require, how many people you require, how long it will take, what is the duration to complete the foundation. Everything you are planning in detail when you are doing this activity. But and similarly, for the roofing, which you are going to do after, let's say, about 3 months, in fact, after 90 days, you plan at a higher level now. When you are going to have the roofing, in fact, at a broad planning you'll be doing at this stage, in fact. And when you come near to this activity, while you are doing the roofing, then you plan in detail, in fact. This is called progressive elaboration or rolling wave planning, in fact. I'm sure in your projects also you must be doing this, Steve, in your projects.
Yeah, generally the larger projects, sure.
Uh-huh. How do you plan in your projects?
Well, on a larger, like a design build project, we would have the, we would start off with, would estimate the time it would take for contract negotiation, and then design, design and approval with the owner, and then have a rough idea how long it takes for the actual build outs. We would just carry those as a block of time, or a parent level work breakdown structure.
Okay. Great. In fact, I think you're already doing that. Probably this terminology probably is probably sometimes it's new, am I right? That's what it is. But you're doing that. Absolutely, you're absolutely right. That's right. So it's called progressive elaboration or rolling wave planning. That's right. Okay. So, yeah, I hope you understood this concept clearly. That's right.
Yes. Oh yeah.
Okay. Great. So that one is the second tools and technique is the decomposition. Here, the first thing to do when decomposing a project is to identify the project deliverables or milestones. So here, for example, in the project, here we discussed, these are all the, let's say, the key milestone for foundation, pillars, walls, and roofing is, let's say, these are all the important milestone in a home project. So first you identify this milestone or the phases, then you look at the deliverables that you need to deliver. For example, you need to deliver the foundation, the pillars, the roofing, like that. Then you decompose this work into work packages. In the scope management, it's called work packages, whereas in the schedule management, it turns into activities, various activity you undertake to complete these work packages, in fact. This is called decomposition. It's a very important technique. And from the examination perspective, also, Steve, there could be some questions on decomposition, on work packages, on the WPS. Yesterday we discussed at length work breakdown structure. So I request you to just get a hang on these concepts and these terminologies so that you'll be able to answer the questions easily. So these deliverables will be the products that you decompose and break down into tasks in order to produce those work packages. This is called decomposition. Decomposition is, once again, to put it very simply, that you are breaking it down to smaller deliverable work packages. That's a decomposition. Okay. There's one more very important thing to understand in the demand for schedule planning, the theory of constraints. Have you heard about this anytime, theory of constraints, Steve? Theory of constraints? The theory of constraints is every process has a constraint and a bottleneck. Basically, it's a focusing on improving the efforts on that constraints is the fastest and most effective part to improve the efficiency. So what are the, for example, the possible constraints? One, it could be the equipment constraints. It can also some material shortages could be another. Lack of people. Sometimes the required qualified people may not be available, or lack of space. Sometimes the infrastructure could be another constraint. I remember in Bangalore some time back, there was a lot of shortage for sand availability, and many of these builders had to really, their schedule got affected, and they had to really plan their schedule accordingly once the availability improves, in fact, and they had to revise those schedules. This happened about 7 to 8 years back. So these are all some of the important things that you need to keep in mind while developing the schedule. In fact, you should look at the market condition, certain times the availability of material, availability of the resources. It could be physical resources, or it could be the required manpower resources. This is called theory of constraints or on-demand schedule planning. Are you with me, Steve, on this? Hello, are you with me? Yeah. Steve?
Hello.
Yeah, are you with me? Hope you are getting that.
Can you hear me?
Yeah, I can hear you. Any issues? Any issues on your network?
Yeah. Actually, I've lost the.
Oh, okay.
Lost the screen, and I'm trying to just look at it on the browser. I've just got a.
Should I repeat?
Thing that's sitting there saying joining the meeting.
Oh,
no, I can hear you fine. I haven't. I've never lost audio.
Okay.
What I am losing is the pictures, the video.
Now, can you see that?
Or
you're not able to see?
No, I'm following along with what you're saying. Sure.
Okay, great. Okay. Because theory of constraints is another very important factor you need to keep in mind while developing the schedule. I'm sure even in your projects, you must be facing such issues, am I right? Sometimes the availability of manpower, availability of the equipment sometimes, am I right, which will be under high demand. You may not get it at the time which you require. And accordingly, you reschedule your schedules, am I right?
Oh, yeah. Yeah, we get constraints in a lot of different forms. Usually when we have an RFI, I'll put it on the schedule.
Yeah,
and it will automatically constrain the successor activities.
Absolutely right. Correct. Yeah.
And we will, we'll use that as an argument for additional general conditions.
General conditions, absolutely.
Additional time.
Yeah, that's right. In fact, you're right. So you need to keep that factor. You're absolutely right. So accordingly, you reschedule or work out or schedules or extending the number of days and all that. In fact, that's right. So actually, this, we need to keep these factors in mind when you develop the project charter itself. That, when you talk about the assumptions and constraints, you need to keep those factors in fact while developing the project charter and also while planning your schedule. Okay, great.
Yes. Yeah, absolutely.
Yeah, that's right. Yeah. Okay, let me go back. Okay, few important techniques that we need to understand in schedule management. 1 second, I'll just get. Yeah. Let me go back to this. So we discussed about this decomposition, and are you able to see the screen now? You got back, or you still have problem? Yeah. Okay. Great.
Hopefully it lasts for a while.
Oh, I see. Okay. Why is it, just to understand, is it network issues or you have your other issues you're having?
I've signed yesterday. I signed on the browser.
Okay.
And I didn't have a problem. And today I'm trying to sign in with the browser. Okay. And it's limiting me on how much I can. Yeah.
Okay. Just tell me whenever you need so that I can stop it, and so I can explain you more, or if you want to reconnect, and we'll do that. Okay, that's right.
Sure, no problem.
I want you to be comfortable in all aspects. That's important. Okay.
Thank you. Thank you.
That's right. So these are the two important tools and technique, rolling wave planning and decomposition, which we discussed. And what outputs you get the activity list and activity attributes. I'm sure I must be having, let me show what is the activity list. Yeah, this is an example of activity list. You can see that the activity list, basically you mentioned the project, the date you prepare, and the project manager, the last updated, and WBS ID. Here is what you mentioned, the work breakdown structure ID, the activity name, what you're doing, a brief description of that activity, and assigned resources, who is working on that, the roles and responsibilities, so that he'll be accountable and responsible for this. I think you must be also preparing such list in your projects, activity list.
We do that on the fly when we're building the schedule. And it becomes a computer generated activity list.
Okay.
But yes, we do create an activity list. But
okay.
it's within the confines of the computer program.
Okay. That's right. This will help you to plan your schedule well and plan your resources, so that and also to inform all the concerned person that will be doing that activity. So it will really help to prepare such things in your projects. And this is the activity attributes. In the activity attributes, what's the difference is that, of course, here you're only mentioning about the few details, but activity attributes also involve the description of work, the predecessor and the lead or lag. I will explain to you the predecessor activity and the successor activity after a few slides. And what is the relationship with the lead or lag? And these things are clearly mentioned, and the number of type of resources required, qualified people, for example, what engineering or technical background you require, or in terms of physical resources, what capacity of the equipments you require. All those things are really skill requirements are mentioned here. The type of effort, that means how many days that it requires, how many hours, you mentioned those things. Location, performance, and imposed dates or any other constraints and assumptions. This gives you an activity attributes. This is also very important along with the activity list. So the milestone list, of course, I'm sure you are very familiar. One important thing about the milestone thing is it's a significant event that normally has no duration. Milestones does not have durations. Not every deliverable or output created for a project is a milestone. Only that, the few important things, for example, in the construction project, it could be your foundation could be a milestone. Putting up a roof could be a milestone. These are all the important things that you prepare. It often takes several activity and lot of works to complete a milestone. I'm sure, after toiling only that's why it's called as a milestone. They're useful tools for setting up schedule goals and monitoring the progress, particularly when you want to monitor the phases progress. The milestones are the very important things in the project. The examples include obtaining a customer sign off on a key documents or a completion of a specific product, such as software modules, or the installation of new hardware could be a milestone. It is a form of, again, coming back to that progressive elaboration applicable to work packages and planning packages. So these three are very important in this process to remember. Two tools and techniques: the decomposition, rolling wave planning, and activity list and activity attributes and milestone, in fact. There might be a few questions on from the examination perspective also. to remember these tools and techniques and the outputs, so that you'll be able to answer those questions clearly. Are you with me on this? Any doubts or any clarifications?
No. Actually, I'm very comfortable with this.
Oh, excellent. Great. That's nice. So once you the next activity, once you define the activity, you need to sequence those activities. So sequence of activity is the process of identifying the documenting the relationships among the project activities. So the key benefit of this process is that it defines the logical sequence. Like we discussed, for example, after putting up the foundation, you put up the pillars. After pillars, you put up the walls, then you put up the roof, like that. So that is how you need to sequence those activity for the project. So the key benefits of this process is that it defines a logical sequence to work obtain the greatest efficiency on the project constraints. So this process is conducted throughout or performed throughout the project. And the basic tools and techniques here we talk about, the inputs are, of course, the activity attributes and activity list from the previous process outputs will become the inputs for this activity. Then you have your assumption log. What are the key assumptions that you would? And the milestone list is also very important. Then only you can sequence this activity. Then your enterprise environmental factors and OPA are the other two common inputs. Now, the tools and technique here, we talk about the precedence diagramming method and dependency determination and integration, leads and lags. You are familiar with this term, leads and lags, Steve? I'm sure you must be.
Yes. Oh, yeah.
Leads and lags. Yeah. You must be very pretty, familiar with those things. The PMIs, of course, we discussed. We'll look at it, this precedence diagramming method and the dependency determination and integration in the following slides. I will explain to you in detail. Then what you get an output is the project schedule network diagram. Then you will also get updated of the activity attributes, your activity list, your assumption log, and the milestone list. Now let's look at the tools and technique of precedence diagramming method and dependency determination. You see, in any projects, you have a network like this. You start an activity. Let's say, in fact, the home project, again, very similar to that I want to give, you start. The first activity, you need to put up the foundation. Am I right? This is one activity. Then after putting up the foundation, then you will put up the pillars. That's another activity. After putting up the pillars, probably you will put up your walls. In fact, am I right? Then parallelly, you'll be doing a few other activities also. Then when you complete all this activity, then only you will be finishing the project. In fact, probably here you'll be doing your painting, you will be putting up your electrical work and all this activity. So combining all this activity, you'll be able to finish your project. In fact, this is called a network diagram. We'll go a little more in detail about that. The precedence diagram method is, so this, let's say, in fact, you have an activity A, there's the foundation, let's say. It takes about 7 days to complete that activity. Then let's say, in fact, the next activity is the putting up the pillars. It will take 10 days to complete that activity. After putting up the pillars, you will be putting up the wall. Then it will take another 12 days. Then the roofing will take another 6 days. So these are all this is called the precedence diagram. That means your C activity is depending upon the A activity. Only after completing this, you will be able to do this activity. So similar way, putting up the pillars, you can do only after your putting up the walls, you can do it only after completing the pillars activity. Roofing can be done only after, for example, your pillar, your walls are ready. In fact, the final thing, parallelly, you'll be doing your painting, you will be doing the electrical work, then you will be doing the compound and all other activities put together, then your project will be completed. In fact, this is called precedence diagram method, where for each of the activity, you have put a schedule that this will take 7 days, this will take 10 days, this will take 12 weeks, or this will take another 6 weeks, like that. then you arrive at the total activity period you require to complete the project. In fact, you got some idea, Sadam?
Yeah,
Steve?
yeah, no,
Yeah.
that's a pretty standard finish to
Yeah.
start process
Absolutely
diagram.
Right. Yeah, absolutely right.
Yep.
They're pretty standard. You must be using it in a project also, this type of diagrams.
Oh,
Right.
yeah. I'm very familiar with it.
Very familiar. Glad. Very nice. That's great. Okay. Now, there's a few more. This is the Gantt chart which I was talking to you yesterday about that. I'm sure you're also that. There are 4 types of relationships that we need to remember. Even from the examination perspective, these are all very, very important. Definitely, you can expect 1 or 2 questions. There are 4 types of relations. One is the finish to start, then start to start, then start to finish, and finish to finish. These are the 4 types of relationships usually in the project network diagrams. What is finish to start? Just to give an example, let's say that an event is your award function for an event. You can only start after the main event is over. Correct? Am I right? So that is called finish to start. That means even in the construction, I can give an example. Only after finishing the foundation, you can start erecting the pillar. Correct? This is called finish to start relationship. In fact, only the previous predecessor activity after finishing it, you can start the successor activity. In fact, so here foundation work is, let's say, is A activity. B is the pillar activity. You can only after finishing this foundation, you can start erecting the pillar. It's called finish to start relationship. What is the start to start relationship? Let's say in fact a car can start only after starting your key. Am I right? Only after starting the engine, you can start moving the car. In fact, it's called start to start relationship. The successor activity can only start after the predecessor activity started already. In fact, what is a finish to finish? A task B can finish until the task A has finished. In the sense, let's say in fact, you can only finish the pillar activity only after finishing the foundation activity. In fact, another example, for example, writing of the book, you can only editing the book can complete only after finishing the writing of the book. In fact, correct? So this is the finish to finish relationship. Start to finish relationship, another example I can give is that you have a security guard in your office. The previous batch to go off only unless the next batch starts the work, the previous batch cannot finish their work. In fact, correct? It is called start to finish. In fact, so unless they start, the next batch starts their work, the previous batch cannot finish their work. In fact, so they have to wait till the next batch comes and takes over. These are all some of the examples of finish to start, start to start, start to finish, and finish to finish example. So these are the 4 relationships, but mostly in the project management, most of the time, the finish to start relationship is the most common one. In fact, I'm sure you will agree with your experience, Steve.
I do agree. And actually, when we work for the government, they don't allow start to start, finish to finish, or start to finish.
Yeah, correct.
They only allow start.
Finish to start. In fact, correct. Yeah.
Right.
Yeah, that's right.
But I do use them when I need to illustrate some particular activity relationship that has some difficult kind of constraints. I will put them in my schedule. And
oh, okay, great. You mentioned those in your schedule. In fact, yes, right. Oh, okay.
Oh yeah, yeah,
okay. Yeah. That's a great thing to do. In fact, absolutely right. That's very important, actually. So from the project management, finish to start is the most common, as you also agree, and least is the start to start. I think that is the least which the relationship they use, in fact. But most of the time, it is always finish to start relationship. So since you're already familiar, because you can expect at least 1 or 2 questions from this. So that's I'm glad that you're already aware of it, so that it will be easy for you to answer those questions. In fact, that's
okay.
Yeah, great. Then this is another few more example. For example, finish to start is your PC hardware needs to be assembled before you installing the operating system on the PC. In fact, this is another relationship. Finish to start. Finish to finish is writing a document. Unless you finish this, you cannot edit the document. You cannot finish this. Then start to start is unless the port building foundation is completed, when you start, you can do the leveling the concrete. In fact, this is another example. Then start to finish is shut down the old account payable system before you start the new accounting payable system. Finishing start to finish it. Unless you start this, you cannot finish this like that. So these are all some of the few more examples just to understand have the clarity on these things. A few other things. One is the dependency determination. Dependency, there are 2 types of dependencies. One is the external, another the internal, and also the mandatory dependency and the discretionary dependency. Mandatory is called hard logic, in fact, where you have no control on these things. This has to be met at any cost. These are all legally or contractually required to inherent in the nature of work being done. For example, you want to start a project, since you are very familiar with the government projects, unless you get the regulatory clearance or the government clearance, you cannot start that project. Am I right? So it's called mandatory. It's also called a hard logic, in fact. Discretionary is sometimes, the project management team can take a decision or the preferred dependencies based on the best practices of work done in the past as defined by the subject matter experts. Discretionary, probably, for example, in a home project, painting of the wall and the electrical work. Usually what they do, after completing the electrical work, they start the painting. But sometimes, depending upon the project managers, depending upon that, they do it overlapping. In fact, while doing the painting, they'll be also doing the electrical work or the plumbing work. It's a discretionary thing. So the external dependencies are where you have no control on that. Unless you get the clearance or the approval or the signal from the government authorities or the regulatory authorities, you cannot start that work. Internal dependencies are is very much under your control, in fact. So there are 4 dependencies: mandatory external, mandatory internal, discretionary external, and discretionary internal dependencies. Steve, you're familiar with these dependencies in your projects, I think. Day in, day out, you must be using these things, am I right?
Yes.
Uh-huh.
Yeah.
Okay. So any particular dependency where you find a lot of issues, a lot of problems in this? You would getting the clearance, for example, external dependency is a problem? Sometimes the approval or the regulatory authorities giving clearance can delay your schedule, am I right?
Sometimes
it can affect you.
The dependencies are an issue.
Yeah. Okay. That's good. Because these are all some important things while developing the schedule that you need to keep in mind. This can be also become constraints in your schedule development, dependency determination.
Yeah, right. Sure. I'm seeing that.
Yeah.
We use these. We understand them.
Yeah.
I don't know that I've ever. I'm not saying ever. I just it's not terminology that we use all the time, so it's something I'm going to have to.
Correct. Yeah, you're absolutely right. Yeah, you need to get used to these terminologies. That's absolutely right. That's one of the reasons yesterday I was telling you that from tomorrow onwards, when you interact with your team members, start using some of these terminologies. In fact, that will help. Initially, I know they may find it, what is this? But once you start explaining to them, then, whole environment, they will start using this terminology sometimes. Correct?
Mm-hmm.
Yeah. Particularly, you can start with your team members about this dependency determination or the start to finish, finish to start, and they will also get used to it in that. That's right. And you will become very familiar with those terminologies. Leads and lags, of course, since you're already familiar with that, as a lead is an amount of that a successor activity can be advanced with respect to the predecessor activity. So complete the punch list, then, you start the landscape or the right draft, that's another example. Lag is that, the successor activity delayed because of some reasons, in fact, that is the lag. Another example I can give for lag is, let's say, in part you want to do the furnishing work, furniture, you buy the wood, but unless the wood is seasoned, you cannot start doing the furnishing work or the wooden work, am I right? So you'll be wasting, or you'll be that activity getting delayed until the wood gets seasoned. In fact, that's another example that you can give. Even the foundation, for example, before erecting the pillars, the foundation has to settle down, am I right? So that's the reason, they will give in the construction project at least about a week to 10 days for the foundation to get settled. Then only they will start erecting the pillars. So that's also, you can call it as a lag there, in fact. So you immediately after erecting the foundation, you cannot erecting the pillars because that foundation has to settle down. That means, you are erecting the pillar activity gets delayed by a week or 7 days or 10 days. Unless the foundation settle down, you cannot start. That is an example of lag, in fact. So these four relationship, definitely there will be some questions. So just try to practice it. Of course, you're already familiar with these things. They might ask you with some twist and turn, so that you should be able to grasp it well and answer those questions. Are you with me on this? Yeah. Hope there is no confusion or anything.
We just generally use lag. And a lead for us is a negative lag.
Oh, okay. Can you give one example in your area, the lag example? Can you give why it gets lagged?
Well, if you pour concrete, you have to have 28 days for it to cure before you can put structural steel on it. So you would potentially account for that 28 days with a lag with your
lag, in fact, absolutely correct
relationship.
Yeah, that's right, absolutely right. That's a very common issue, I think, particularly in the construction industry, or it happens many times.
Yeah. Oh yeah. Yeah. There when it comes to concrete, there's certain stipulations that you have to have.
Correct. Absolutely right. Yeah.
Right.
That's right. Even while painting the walls also, I'm sure, you put for example, you put a concrete and all those things, but unless it dries up, immediately you cannot start painting, right? That could be another
sure.
Yeah,
sure.
It's like that. It's like that.
Yeah, if we bring material into a building, sometimes it needs up to a week for it to acclimate.
Acclimate, absolutely right. That's right.
It needs to, it needs to be adjusted to the building's temperature and humidity levels.
Correct. Yeah. Furniture is a very common thing. Furnishing work, I have seen we buy the wood, and unless it gets seasoned immediately, you cannot start the work also. That's another example of the lag. That's right. Of course, in US, you have a ready-made concept of buying the furniture, am I right? Everything you just bring it and fix it, in fact, correct? Even the kitchen cabinets, everything is like that, correct?
Sure.
But in India, many places they buy the wood and getting it done also in many places. So those in that type of situations, this lag is an important thing that you need to keep in mind. Okay.
Sure. I mean, I mean, we have to make allowances for shop fabrications.
Yeah, correct. Absolutely right.
And when we get into an instance like that, generally we identify that as its own separate activity.
Correct. Absolutely.
So instead of putting a lag in there, we put an additional activity for the shop fabrication.
Absolutely right. Yeah, that's right. Yeah. So this is also a part of we talking about the management knowledge and skills. These are many things are actually the skills part of it. The project manager, with his skill. Okay, everybody has got knowledge, but at the same time, applying that knowledge in properly. In fact, it's become a skill part of it. So he should know exactly that how much lag or how much lead that we need to keep in consideration while developing the schedules. This is another example of project schedule network diagram. Schedule network diagram is a graphical representation of the logical relationships, which we just explained in the previous slide also. So that means you begin, you will have, for example, start to start, finish to start, all these relationships, that while developing the diagram, since you're already very familiar with these diagrams, I'm sure you'll be marking those things, which activity will have lead, which activity will have log, which one is to start, which one is to finish to start. So all these things will be clearly mentioned in your project schedule network diagrams. I think this is an excellent tool, am I right, to develop your schedule, correct? Yeah.
Oh yeah, sure.
Yeah. You use Microsoft or you use Gantt charts? What do you use? You said Microsoft tools.
Yeah, we use Primavera.
Primavera.
Oracle.
Okay. Yes.
Okay. 6.
Okay.
And it will. We could do Gantt charts. Gantt charts.
Okay.
Network diagrams.
Oh, that's great. Yeah. You can customize according to your requirement. For your requirement, you can customize it.
Yeah, usually when we submit a preliminary schedule or the first baseline schedule, what we'll need to do is submit a network schedule along with a Gantt chart for the government to review, because on the network schedule they'll be able to look at the logic and see if they agree with the our logic assumptions. And that's probably the most visual place to illustrate the logic on the schedule.
Schedule, in fact. Okay. That's good. Okay, great. That's nice. So I think now what you are already doing and what you're looking this picture, I think you're getting a better understanding. I'm right that you're already doing all these things.
Yep.
Yeah, that's right. It's only probably, as you said, some terminologies or the concepts, only that's the only difference. Otherwise, you are doing all these activities in your projects. That's great.
Yes, we are. Yep.
Yeah. Yes. Okay. So once you develop the schedule, you need to estimate the activity duration. This is another very important process. Here, the key benefits of the process that it provides the amount of time each activity will take to complete. In fact, that means your foundation activity, how many days it will take, your pillars, how many days it will take. And so what are the inputs you require? You need a schedule management plan. You need your scope baseline. And important documents like your activity attributes as I clearly explained, the successor activity, predecessor activity, what is the relationship, leads and lags, all those things will be part of this activity attributes. Then you have a list of various activities which we discussed. Then you will have the assumption log, then the lessons learned register from the previous charter. Then you have the milestone list, which we discussed. Then your project team assignments, who will be doing what, the roles and responsibilities of the project team. In fact, you need to have who will be doing the pillar work, who will be doing these, for example, your foundation work. All those things are clearly mentioned here. Then your resource breakdown structure, how many people that you are having, the physical equipments that you are going to utilize, All those things will be part of your resource breakdown structure. Then your resource calendar, the availability of your human resources, the physical resources for the entire project, you will be having another key input. Then your resource requirements, then your risk register, then enterprise environmental factors and organization process. So you can see the long list of inputs here, which are very, very important to estimate the activity duration. Now coming to the tools and techniques, we'll spend a couple of minutes because it's very important to understand. These estimating techniques, same thing will be applicable even for in the cost knowledge area, cost management. Have you heard about this technique names anytime, Steve? Analogous, parametric, 3-point estimating, and bottom-up estimating. Little bit
not.
or not?
Yeah,
okay.
I'm really familiar with those terms.
You are familiar or no? You are not familiar.
No, let's go over.
Okay. And let me. I will explain to you that. Okay. The first one is your analogous estimating. Analogous estimating is. Let me take this current slide. This is the first technique. One of the technique that uses a similar past project estimation. For example, in the previous project, that it has taken about 100 days to develop a website a few months ago, and if you are doing that, the same developing the new similar website, you estimate it will take 100 days. In fact, this is called analogous estimation. That means from the previous project, the similar the data, you just repeat that, it may take this similar 100 days, in fact, to complete the project. So it is called analogous estimation. The next estimation is the parametric estimation. Here, in the parametric estimation, you use the mathematical calculation for this, in fact, for estimating the cost and duration. Let's say here, it has taken 100 days like analogous, but 10 people have worked for 8 hours a day for 100 days to develop the schedule, in fact. So you have some rationale here. You have some mathematical or algorithmic calculation here, in fact. Same 100 days, but 10 resources worked for 8 hours a day for 100 days and develop the website, in fact. This is the difference between analogous and parametric estimation. So what is the difference here? Analogous is considered top-down and is less accurate than parametric because you are just assuming the previous project schedule. But here you have some rationale of arriving at that number, in fact. So analogous estimating is an analogy comparing to past similar project, whereas parametric is more accurate, specifically when the underlying data is scalable. So the parametric uses a relationship between the variables. In fact, you use the time duration and also the number of units. Is it clear now, Steve? Analogous and parametric. That's right. Okay. Again, from the examination perspective, you can definitely expect 1 or 2 questions on these estimation techniques. So that's one of the reasons, if you want, I can repeat at the end also again if there is any confusion on that. Normally, these estimations, who does in your projects? You take the help of your planner, or how do you do that?
Usually we get input from the resource.
Okay.
And our resources are subcontractors to help us with the item durations.
Okay, great. Okay, that's right.
If we do it in-house, then it is it's more parametric of time.
Okay, that's right. So they must, I'm sure they must be using the same techniques. Probably only this terminologies for you probably new. That's the only thing, I think. Correct?
Yes.
Yeah, that's right. Okay. So the next technique is the 3-point estimating technique. Here in 3-point estimate, It's a technique that uses 3 estimates to better understand the duration. So here, the 3 estimates, one is the pessimistic estimate, optimistic estimation, and most likely estimation, in fact. So it's also called the triangular distribution. So here, this is the optimistic plus pessimistic plus most likely divided by 3. It will give you the 3-point estimate. Just to give an example, let's say, Mr. Steve, that from home to reach office, let's say, in fact, how long it will take for you. I'm just assuming, let's say it takes about 30 minutes most of the days. If there is no traffic, it may take about 20 days. Then if it is too much of traffic, it may take about 45 days. Let's say these are the 3 scenarios. So if you add up 20 plus 30 plus 45 divided by 3, that means it should take around 31.7 minutes to reach his office. In fact, this is another estimating technique. So here you are working on 3 variables: optimistic, pessimistic, plus most likely scenario divided by 3, in fact. This is another estimation technique. Do they use in your projects this technique by any chance?
Yes, yeah, to some degree we do, sure.
They do use it, in fact, yes, right. They look at the worst scenario, they look at the best scenario, and they work it out on that, correct?
Yes, right.
This is called 3-point estimating techniques. There is one more, PERT. The 4th one is another one, the PERT formula. So the PERT formula here, this most likely, since if you take only one value, sometimes it may have, it may be right, it may not be right. So you take the average of that most likely. So what you do here is you multiply that most likely by 4 times. So optimistic plus pessimistic plus 4 times most likely divided by 6. Here, instead of 3, it's divided by 6. This is called PERT formula. PERT stands for Program Evaluation Review Technique. Yeah, you can make a note if you want. Program Evaluation Review Technique. It's called PERT formula. So here, you see the difference. So optimistic is 20, pessimistic is 45, most likely your 30 multiplied by 4, it becomes 120. So if you divide it by 6, it will become 30.8. So compared to the previous here, let's say 31.7 is the duration in the 3-point estimating. The estimation of, we talk about the triangular distribution, whereas in PERT, it has come down from 31.7 to 30.8 days. That means it is much more accurate compared to the triangular distribution. So you need to get a better or a most accurate estimation. You can use the PERT formula, Program Evaluation and Review Technique. So this will give you the more clarity or the much more accurate numbers for scheduling effect. So a 3-point estimation can be done using either simple average or a PERT formula. It improves the estimation accuracy and reduces the project risk. So it provides a better result than just a single point estimate, like, for example, your analogous or a parametric. So these are the 4 important techniques, Steve, in fact: analogous, parametric, 3-point, and PERT estimation. The same, in fact, in the techniques are also used in the cost management. Any questions on this, Steve? These 4 techniques?
No.
No, it's quite clear. That's right. Okay, great. Even from the examination perspective, these are very important because if you know this, you can easily answer those questions. It's a matter of about 5 seconds, 10 seconds. They will give you 4 options. They'll give you one situation. Is it analogous? Is it a parametric estimation? Depending upon the answer questions they've asked, it is easy for you to click it, in fact. So these are, just get familiarized with these techniques. Analogous, parametric, 3-point triangular distribution and PERT. Okay, great. These are all some of the list of project documents. Of course, yesterday we went through in detail about these things. Okay. So we looked at the analogous estimation, parametric, 3-point estimation, bottom-up estimating. Then yesterday we discussed about, let me try. The alternative analysis and the reserve analysis. Reserve analysis is in every project you have, for example, the contingency plan and the management reserves under the contingency reserves. Contingency reserve is for the known unknown factors. Unknown factors is called management reserves. So known unknown and unknown factors. In any project, you will have some contingency, am I right? You keep about 1 or 2% or 5%, depending upon the complexity of the project. You always have some contingency reserve. Correct? Am I right, Steve? Both in our cost and schedule. If something goes wrong, probably you can stretch it to another 5 days. Or if something goes wrong, I can spend a little extra money to complete it. Am I right? You have the contingency reserves, correct?
Oh yeah, sure.
Yeah.
Sure.
So those contingency reserve are called known unknown factor. That means something is going to happen, but you don't know what is that. But you keep some money for that, correct? So it is called known unknowns or known unknown uncertainties. The management reserve is called unknown unknowns. Management will also keep some reserve, in fact, for without knowing what's going to happen. But still, if something may go wrong, so that's the reason they will also keep some reserve. It's called unknown things. In fact, it's called reserve analysis. The same thing in cost management also will be using that. So at that time, probably we can explain once again on those things. Then the decision-making techniques, which we discussed, it could be unanimous decision, it could be your majority decision, or it could be direct or 1% taking a decision, all those decision-making techniques we discussed. And by doing this, you will get the duration of estimation, right? And also the basis of estimation. What is the rationale for this impact? Both you will get the duration of estimates and the basis of estimates. Then you will have the project documents gets updated and activity attributes gets updated, assumption log and your lessons learned register gets updated. So estimation of activity duration is very important in the schedule management. And basically you'll be using one of these techniques. It could be analogous, it could be parametric, it could be 3-point or the bottom-up estimating. And you will also look at the alternative analysis, whether you can do the manual or automatic or whatever decision depending upon the project. Then you'll be looking at. You will also have the reserve analysis. Just to repeat once again, reserve analysis, there are 2 types. One is the known unknown factor. It is called contingency reserve. And unknown factor is called management reserve. You need to keep that these 2 points in mind. And what you get an output is your duration of estimate. That means each activity, how long it will take. Foundation, how long it will take. Pillars, how long it will take. Your painting, how long it will take. And what is the basis of estimation? You will also have a rationale for that. So these are the 4 estimating techniques we are discussing. So analogous, use the historic data. The parametric also, for example, use the parametric while doing the planning, use the parametric estimation. You use the previous data, plus you will have some mathematical calculation to that. Then in the 3-point, you will go to the final planning, and in the execution, you will also do the rolling wave planning. In fact, the accuracy, the more you get advanced during execution process, you will get the accuracy of our estimation will be very good. Initially, for example, it will be very low, but during planning, it keeps progressing. In fact, and final planning, it will be 3-point estimation. Then execution, you will have the rolling wave. So these are the I just explained about analogous 3-point estimation. This part, this is another thing. So the standard deviation, if you look at it, in fact, the square root of the sigma, the standard deviation, the variance you calculate, pessimistic minus optimistic square root divided by 6. That's how you, are you by any chance in a Sigma, a black belt or a green belt? Steve? Six Sigma you're done?
I'm sorry.
Any program? Six Sigma? Sigma certification, or are you familiar with those concepts?
No, I'm not. I don't.
Okay. No, not. Okay. Six Sigma is again another one quality tool. In fact, they're also used in this type of stuff. The duration estimates, this is another important. Let's say, in fact, in the duration estimates are quantitative assessments of the likely number of TM periods that are required. Here, the duration estimates indication of the range of possible results. For example, a range of 2 weeks plus or minus 2 is either 8 days or 12 days. Correct? Am I right? Because 2 weeks, you take 5 days working per week. Am I right? That's how we calculate. So a range of 2 weeks plus or minus means either 10 days, 10 plus 2, 12 days, or 10 minus 2, it will become 8 days. In fact, this is the duration estimate. So in the another one is if you calculate by percentage, a 15% probability of exceeding 3 weeks, which indicates a high probability of 85% the activity will take 3 weeks or less. This is another way of putting it, in fact. 15% probability of exceeding 3 weeks means 85% probability that activity will take either 3 weeks or less, in fact. These are all certain assumptions that you keep while doing the estimation. Do such assumptions, you document those things in your project, Steve? I'm sure you must be doing it, correct?
Yeah. Yes, we do.
So that all stakeholders are aware of it. In fact, when you document those things. So far, any questions on schedule management?
No, not right now.
Not really. Okay, great. So once you estimate the activity duration, you develop the schedule, in fact. Here are few important inputs here, the activity attributes, activity list, your assumption log, and your basis of estimates and duration estimates. These are all some of the outputs from the previous process. Then you will have the lessons learned register, your milestone list, your project schedule network diagram, which we just discussed, and your various team assignments, resource calendars. You need to have resource requirements. Then you will have the agreements, then enterprise environmental factors and OPR, some of the long list of inputs, because these are all very important while developing the schedule. You need to keep all these factors in mind. And few important tools and technique. One is the critical path method. Another is the resource optimization. These are the two we'll discuss. Then what if scenario analysis? Scenario analysis, in fact, you put the multiple combinations, in fact, and try to work out the various scenarios. If so many people are available, then what will be the outcome? If there is any shortage of material, then what will be the outcome? If the equipments are not available, you look at the various scenarios and make that what if scenario. Sorry. Then you also look at the simulation. You simulate, again, it's a software program that you simulate the various permutation combination and try to arrive at the schedule. Then the leads and lags, which you discuss. The schedule compression, we'll discuss this technique. Agile release planning also we'll discuss. Now, the most important tools and technique, this schedule network analysis, the critical path method. We'll spend some couple of minutes on this because this is a very important tools and technique. We need to understand that. Now, what is the critical path? Critical path is the longest path through a project with the shortest possible project duration. It's the longest path. This is the, I request you to remember, if possible, memorize this. What's the critical path? It's a sequence of activity that represents the longest path but the shortest possible project duration. Now, let's say when you calculate the total number of days that you require or the weeks you require, you see for any project, you start the starting, here there are two options, Steve. One, either you can start with 0 or you can start with 1, in fact. This is the day of the starting that activity. In order to avoid any confusion, you can always start with 0 because your starting date is 0. So let us say the activity 5, activity A, let's say the foundation work, let's say 5 days it takes to come, is the duration you require. So here you call it as an early start, early finish. Early start for this early finish, early start, early finish. And this is the final days for the project. Another one is the late start, late finish, late start, late finish, late start, late finish, late start, late finish, in fact. That means this activity can be delayed, the late start. Now, this is the sequence that you need to understand to calculate the critical path. So I am not taking, if you're taking it as 1, then it's early start plus duration minus 1 will become the early finish. Yeah, you got it, Steve? Or if you are starting 0, here you start with 0. So early start plus duration is equal to the early finish. So both way you can do it. In order to avoid confusion, probably you need not take 1 here, in fact. So let's say here, both remain same actually. You have your early start is 0. 0 plus duration is 5. So early finish is 5 days. Correct? Am I right? You got it?
Yeah, I do, actually.
Okay, great. Now this activity, now after creating the foundation, suppose let's say you are erecting the pillars here, in fact. Okay. Now this activity, so this early finish is 5 days. So here it will come 5 plus doing this activity takes 10 days. So 5 plus 10, it will become 15 days. Now this 15 days, this is the early start. 15, it will come here. 15 plus this activity takes another 50s, it will become 30 days, in fact. So the total to complete, it will take 30 days. Now, let's say this another activity you are doing parallelly. This activity, let's say, in fact, it will take 5 days here. So 5, it will come here. 5 plus 5, it will become 10 days. And another activity, 10 days plus 15, it will become 25 days. Now, what is the definition for the critical path? It is the longest path in the project, in fact, because unless you complete this activity, you cannot complete the project. Am I right? So it is the longest path. So here, ACD is your critical path. So ACD is your critical path, in fact, whereas ABD is not your critical path. So it is the longest path with the shortest possible duration, in fact. You got it, Mr. Steve, on this?
Yeah, actually, this is my life. This is what I argue all day long. Every argument. Every argument.
Okay.
Early start, late start, total float. Right now the project is showing over 200 days of negative float. So
negative. Okay, that's right.
It's an interesting concept to try to portray to the government.
Yeah, that's right.
Until we change our CCD, we're still gonna be running a negative float.
Yeah, okay. The change control board you're talking about, CCB. Yeah.
Right.
Okay. So you are quite familiar with this network diagram, in fact, critical path. That's
right. I am.
Yeah. So where exactly you are putting your problem in your why it's going from 270 days to 500 days? Which part it is taking more?
Oh, I told you, because they've taken our concurrent. We were running concurrent activities when we were working in concurrent buildings. And we've had to adjust the schedule so it is a finish to start relationship from building to building.
Okay.
So we were running very similar to the work to the diagram that you're showing here with parallel activities. And now it's all start to finish, or finish to start, finish to start, finish to start.
Yeah. Okay.
On our buildings. So we've extended our construction schedule accordingly.
Accordingly, but okay.
Yep.
Okay. You didn't have any financial resource constraints and all those things, right? You didn't have such problems. Yeah. The funds not coming.
As a companion to that, we've got financial issues that go along with extending the schedule out.
Oh, is it? Oh, okay. That must further complicating the issues also, right? That's right.
Yep. That's what complicates things.
That's right. That's a very dicey scenario to be in, actually. Because if you look,
it's more common with the government than
correct.
Than you'd realize.
Yeah, correct. Because of course they can sustain this if so much of delay, but if it's a private projects, let's say in fact doubling their schedule, they may even call it off, right? They may even terminate the project.
They could do that, yeah. Sure.
They could do that, yeah.
If they can't find funding, they could decide to stop the project. But then that becomes a contractual issue. It becomes a termination for convenience instead of a termination default. And it ends up costing them more money.
Yeah,
because we're allowed to charge certain. We're allowed to seek. We're not allowed to charge. We're allowed to request an equitable adjustment.
Okay.
For certain business losses, because we've set aside our business for a certain amount of time to do their work, and now if we're not going to do their work, we're still entitled to what we would have made in other places. And then it starts to become more legal matters, and then we got to go to the subject experts, which are lawyers.
Okay.
I don't think we're very close to that right now, but it could happen. You never know.
Yeah, you can never know. Absolutely right. That's right. We don't know. That's right. That is the unknown factor. It's like that.
Sure, absolutely.
Yeah.
Absolutely.
Yeah, that's right. Yeah. These are all the challenges in the project environment, of course. So you need to have a lot of sometimes patience. You need to have a lot more things to manage such projects, I think. Correct.
Yes, we do. We do.
Yeah, it is. That's right. That's great. So one important point, of course, I'm clear that the longest path has always the least total float. I'm sure you know how to calculate the float also, right? In the float formula, here, you see, for example, the late start minus early start, or the late finish minus early state. That's how you calculate the float, in fact. And always on the critical path, the float is always 0, in fact. So identify the critical path of the network, follow the forward path, and find the early start, early finish, and calculate the finish and late start using the backward path. So just go back to this. Here, for example, this is the early start and early finish. Early start, early finish, early start, early finish. If you put all these things here, this is the critical path. So when in the backward path, you take the late finish minus late, for example, late finish minus here the late start. That's how you take it. In fact, here the late finish minus late start, or early finish minus early start. If you minus that, it will be always 0. So here in the critical path, if you look at it here, this is the critical path. So 30, this is your late finish, late start, late finish minus your early finish is always 0, in fact. So here, of course, in this activity, you got a float of 5 days. That means this activity, even if you delay by 5 days, for example, it will not affect your final schedule of the project. Because here, of course, if you delay by even single day, it can affect your schedule of the project. So this is the formula you need to remember. Late finish, minus early finish or late start minus early start. It will be always 0 in the critical path. You got it, Steve, on this?
Yes. Yeah, I do.
Yeah.
Yep.
Yeah, good. In fact, that's right. Because again, there might be some questions. If you're not familiar, then probably you can practice, make 2-3 diagrams and practice it. But since you're already doing it, I'm sure it's easy for you to answer these questions. And these are the total float and the free float and the independent float. I'm sure you're already familiar with these slacks and the floats as well. So the two more techniques that we have is the fast tracking and the crashing. Right? These are the other two important schedule compression techniques. These two are called compression techniques. In fast tracking, you do the activity parallelly. In fact, suppose while doing the painting, you'll also do the electrical work. It is called fast tracking, so that you can make up the schedule all right, doing the fast tracking. In crashing, what you do is you put more resources. Instead of 3 people are working, you increase the people by 5, in fact. That is called crashing, in fact. There are certain advantages and there are some disadvantages, which we'll discuss. So probably in the examination, what is fast tracking, what is crashing, there might be questions on this schedule impression. So the fast tracking is always, you're doing the activities parallelly, whereas in crashing, you are putting more resources, in fact. To complete the work, let's say, in fact, there are some painters and there are some doing the electrical work. Now, here in crashing, what you do, you take some people who are doing the electrical work and ask them to do painting. That can happen in crashing. So the quality, is always a lot of risk because that skill, they're not familiar with the skill of required job. So then you can get into some sort of issues there. Whereas in fast tracking, what happens, the quality may suffer, in fact, because too many people are working too fast, then probably to complete the schedule, then you will have issues of the quality of the work, in fact. So these are all some of the advantages. There are some disadvantages of these techniques. Now here is one. I'll spend a couple of minutes on this. The table summarizes the project activity details. Which activity would you crash to reduce the project per day? That's the question. So let's say activity A takes original duration of 10 days. The crash duration takes 8 days. That means you are reducing by 2 days. The original cost in dollar, it has costed $10,000. By doing the crashing, it is costing you another extra 2,000. That is 12,000 it's going to cost. So the extra cost is 2,000 per day. If you break it, it's $1,000. Now, activity B, it takes 14 days and 10 days is the crash duration. Saving times is 4 days. So total cost is 14,000 and crash cost is 24,000. So extra cost is 10,000. So per day it costs you around 2,500. Activity C, similar way, it's going to cost you 2,000 per day. So activity D, it will take the similar way, it will cost you $3,000 per day. So which is the activity would you crash to reduce the project time by 1 day? So this is an example. What is your take on this, Steve?
It's an interesting analysis.
Yeah.
We don't generally get to that level when we've got to make up schedules.
Mm-hmm. Okay.
But no, I like it. I like it. It's a very illustrative way to look at it.
Mm-hmm. Purely on the cost perspective, there are this question.
Okay.
Yeah. Because yesterday, you remember in the performance measurement plan, you remember that when you do the performance measurement, you involve both cost and schedule also. I hope you remember that, which I was trying to explain. Whereas in the schedule, you'll only take the schedule data, but when you take the cost data for analysis, cost baseline, you will also keep the schedule also into factor actually. Then only you will arrive at the cost baseline, am I right? So this is another example of, because you take the duration of it's required to achieve that, then only you will arrive at the cost. So this is reduce the per cost. You can just give a few moments and understand and try to answer it.
Okay. Yeah. No, I've got it.
You got it.
Sure.
Okay, great.
Yeah.
So here, we're talking about, since the activity A has the minimum crash cost per day. That's how, you select that which you crash to reduce the project. If there is an option available, then you will crash the activity A, because that's what, you are spending only $1,000 per day to crash that activity. Whereas the remaining other activities, it costs much more than that. In fact. So the actual activity A has the minimum crash cost per day. I think it makes sense. Am I right? Yeah, it makes sense.
Oh yeah, sure.
Yeah, that's right. Probably your finance guy, probably he may get involved in taking such decisions. Am I right? When you discuss with them and in a project environment, probably you also involve them, to take such decisions. I think.
Yes. Yeah, absolutely.
Yeah, that's right.
Right.
Yeah, that's right. That's right. Great. So these are some of the advantages and disadvantages. If you look at it, in the fast track schedule compression technique, it adds risk. It increases the management time on the project manager because it adds risk because you're doing parallel activities. Sometimes the quality could be always under threat when you do this activity. Am I right? So you need to really, a project manager has to spend a lot of time to ensure this activity, when you do the parallel activity, is correct. Then crashing, it will add cost, and it also increases the management time for the project manager. As I told you that sometimes you put the resources who are not familiar with that particular task. That's how you are crashing it. That's how you are adding the resources, in fact. All those resources that you are adding may not have the required experience sometimes. So then what you do is that it will add cost, and your supervisory time also increases. If you reduce the scope, what happens? It will save time and cost, but your customer may not agree for that, correct? You cannot deliver an under quality product, or you cannot deliver the scope which is not completed. You cannot deliver such product. So you cannot, it will increase your customer dissatisfaction. Cut quality, it can save cost and resources, but it will increase risk. Your product may not be accepted by the cost by your customer, so you cannot cut quality. In fact, resource reallocation does not add cost or increase risk. In fact, resource reallocation, if some experienced people already available, and if you make use of them, then probably it will not add cost, or it will not increase the risk. In fact. So these are all some of the schedule compression techniques and advantages, and there are some disadvantages in it. Do you use any of these techniques in your projects, Steve?
Oh, sure.
Uh-huh.
Sure.
Which is the most common one you use?
Probably resource reallocation.
Resource reallocation. Okay. Uh-huh.
Yeah.
Okay. Uh-huh. That's the most common one.
I mean, usually fast tracking. There's concurrent activities where we've already taken the logic as far as we can. Crashing sometimes.
Sometimes. But these two are ruled out, am I right? Your reduced quality or scope is ruled out. In fact, we'll never do such things.
Yeah, cutting quality and reduced scope. Those are definitely, for working for the government, those are definitely
not there. In fact, absolutely right. So
right.
Either it could be fast tracking or crashing, or it could be resource reallocation is the most common one in many places. They do use. They have some reserve people, that always the contingency plan they will have if something goes wrong. So they use the resource reallocation. I think the most common one they use it.
Yeah.
Pretty interesting, am I right? When you apply these things to our own projects, it will make much more interesting for us to understand these things. That's right. I remember. Yeah, in our projects, I remember that, we used to use many times this crashing, in fact. So, that, we used to bring some, suppose if 10 guys are there, not sufficient, we used to hire some extra people from outside. And we used to get into a lot of problems because of that. One is the quality. Many of them are inexperienced. In fact, you need to teach them, and there is a lot of ego issues within the team and outside the team. A lot of conflicts and problems I used to face in that schedule compression. Actually, now I realize, since I had not done the PMP certification at that time, but now when I try to recollect those days, all these things make so much sense. If I had known the other alternatives, like for example resource allocation or the fast tracking, probably I would have chosen those options rather than crashing that activity. Actually, I'm right. This is the knowledge that helps many times.
Yeah, yeah, exactly. I mean, there are a lot of quality issues that happen when you crash a project to get it caught back up.
Yeah, that's right.
It puts a big burden on
the project manager. Yeah.
Project manager, quality control.
Yeah, that's right. Because quality also comes under, since project manager is overall responsible, including the quality, ultimately it will be on the head of the project manager, actually. That's right.
Sure. Yeah, you're absolutely right.
Yeah, that's right. You cannot show the finger at quality manager, it happened. We cannot do that, am I right? You have to take that onus or the responsibility of that. That's right. So the project manager, that's why sometimes, it's like sandwiched among the various forces, in fact, correct? Many times it happens, actually. No.
Sure does. Sure does.
Internal pressure, external pressure, like that. It's like, that's right. This is the agile release planning. I'm sure you must be doing in your projects also. Basically, in agile release planning, it's a high-level summary of timeline and release schedule. Typically 3 to 6 weeks, because they work on the short terms always, based on the product roadmap or the product vision and the product evolution. Agile release planning, since features represent value to the customer, the timeline provides a more easily understood project schedule. It defines which feature will be available at the end of each iteration, because they work on small sprints or this shorter period. The customer, you're looking at the frequent delivery of those things, it's very clearly mentioned, in fact, in agile release planning. I think I have another slide on this. This is one thing, on the estimation of duration of estimation and how you do it. For example, the foundation takes about 2 weeks. Your erecting pillars take 2 weeks, and putting up a wall takes 4 weeks. So add up all these things, it will become 8 weeks. That's how you develop the schedule. And basis of estimation, foundation 10 weeks, number of resources you use 10 people. So they work 8 hours per day, 5 days a week, and 400 hours. 400 hours for 800 hours is for 2 weeks. In fact, that's how you use the basis of estimation, the rationale behind those things. One more estimation technique I just wanted to cover, that is your bottom-up estimating. Here, bottom-up estimating, you do from the work packages. From the work packages, you start, estimating the info. So bottom-up estimating is the 100% correct one. It's a guarantee one, in fact. But only disadvantage could be is that it will take a lot of time to complete the estimation. Am I right? You agree with me on that, Steve? Bottom-up estimating consumes a lot of time, in fact. But it's a very accurate estimation thing. So here is an example of bottom-up estimating. Here is, so for example, it is a multi-purpose examination, a hospital project. So you have got the examination room and you have got a consultation room. You have got examination zone, dotting zone, and consultation zones. We have various things. Under these things, you have the work packages. You'll have the exam table. You have the chairs and all these are work packages. So you calculate the estimation for each of these things. Then you add up here, add up here. That will become your controlling accounts, in fact. Then the total you come and your total project cost here, multi-purpose examination suite project you will get. This is another bottom-up estimate. So there are 5 types of estimation techniques. One is analogous, parametric, 3-point, that's a triangular distribution, and PERT, program evaluation review technique. And the 5th one is the bottom-up estimating. Just kindly do remember of these things. So this agile release planning, which I was just talking to you a few minutes back, it is a prerequisites for release planning, a product backlog managed by the product owner. Generally, 5 to 10 features are taken which product owner feels that can be included in a release. So the team's input about capability, known velocity, or about any technical challenge, you will have a very high level vision of that. And you also acknowledge whether new product backlog items are needed. This is a concept in agile release planning, because you'll be releasing it in as per the customer requirement in a short cycle, 3 to 6 months or 3 to 4 months, based on the discussion you have with the customer. It is the agile release planning. In the predictive environment, what happens is, you will be releasing at once, right, the final product or the final delivery. But here you have the release planning, based on the requirement, those things will be releasing it. So so the final process in the schedule management is the control schedule. So the control schedule, what are the key inputs here we are talking about? Your schedule baseline, your scope baseline, your performance measurement baseline. Performance measurement baseline you'll have. And then project documents like your lessons learned register, project calendars, your schedule, your resource calendar, and work performance data is be always an input in the control process. Then what are the tool techniques you have? And when you have the input in the work performance data, what output you get your work performance information? Because the work performance data goes through the control, monitoring and control, and you will get the work performance information. What are the tools and techniques here? Earned value analysis, which we discussed yesterday, in fact, earned value analysis. Again, in the cost, I will talk to you in detail about that. Iteration burnout chart, I'll show it to you in the following slide. Then performance review. You do the trend analysis, which we discussed. The various analysis is that against the plan, what is the actual performance it is happening? What if scenario analysis, in fact, putting up the multiple scenarios and you arrive at the what if scenario analysis. The critical path method, which we just discussed, it is the longest duration and the shortest path, which we just discussed about it. In fact, shortest time and the longest duration. Most important thing to remember is the critical path is your float. Total float is always 0. Then project management PMI's information system, which we discussed. Resource optimization. You will have the leads and lags and schedule compression, in fact. So these are all some of the tools and techniques that you have in the control scheduling. What output you get here is the work performance information is an output from the work performance data. Then you will have your schedule forecast, in fact, whether like a project from 270 days, it has gone up to 500 odd days, in fact. So you would have arrived at after monitoring and controlling, after looking at the various analysis. That's how you arrive at this schedule forecast. Then your change request is another output, and your project management plan and all these things, gets updated in the process in the control schedule. So this is the burn down chart. This is a very simple one, straightforward and easy to understand. This chart tracks the work that remains to be completed in the iteration backlog. Here, for example, the actual remaining work to be completed is mentioned here. This is the actual remaining work after making the analysis. The actual, this is the actual remaining work, and this is the ideal remaining work. As per the plan, this should have been your ideal remaining work. Actually, you should have done so much, but your actual remaining work is this much, in fact. So when you do the forecast remaining work, based on this actual remaining work and actual forecast work, you look at this will be your new forecast to complete this work, in fact. That means the iteration days here, instead of 10 days, it is going up to 12 days, in fact. So there is an increase of two days by looking into the trend, in fact. This is called the iteration burn down chart. Anytime have you used this, Steve, in your projects, burn down charts?
No.
Yeah, not used it. Okay. Probably some of these techniques will help to analyze or represent your delay. For example, you can put your 507 days also like this, in fact. You can prepare a chart like this. So as a pictorial presentation, this is the actual remaining work. And this is how it should have been your ideal remaining work should have been completed. So your forecast probably here, because since it's getting doubled, let's say this is 270 days and this is 275, 570 days, probably you need a bigger chart to show that, in fact, correct? It's like that. You're getting what I'm talking about that? That's right, yeah. Right.
Did you change the last thing I see on the computer is the basic estimation.
Basic estimate. Yeah. This burnout chart, you are not seeing this? Have you seen this? No.
No, I'm not seeing the burn down chart.
Oh, one second. I'll just show. Yeah. Sorry, yeah, that's right. Yeah. Can you see that now? Yeah, that's all.
Yeah. Yep.
Okay, great. This is what I was trying to explain. This is the iteration burn down chart. For example, here, this is the ideal days, ideal actual remaining work. This should have been the your ideal remaining work. And because of the scheduling is go haywire, you are putting in the dots, the forecast to complete it, in fact. Burn chart. So in your project, let's say, in fact, your work remaining so much, you can mention the number of days here. And what should have been the ideal will come in 270 days, but your 570 days, that means, your chart will be really big one, in fact. Correct?
Yeah, sure.
This is another your pictorial presentation of your schedule, iteration burn down chart. So very easy to understand and what's happening about that, actually. So remaining work left side and the iteration days in the bottom, horizontal and vertical. So this will also help you to understand the likely variance of iteration and completion and take appropriate action during the course of iteration. This one, very important.
Okay.
And again, all these things are available, templates, you can download it and anytime it's those things. Okay. So work performance information, and we discussed work performance information includes, are you seeing the new slide now? Did I move it on?
Yeah, I am.
Okay, great. Okay, work performance information includes information on how the project work is performing compared to the schedule baseline. That's what the data from the work performance data, you analyze it, you variance at the start and finish dates and the duration can be calculated. We will go to this schedule variance and schedule performance index in the cost management. I will explain to you in detail about that. Schedule forecast is updated and estimates of prediction of conditions or events in the project future based on the information, knowledge available at the time of the forecast. So once you do the variance analysis, then you will know the schedule forecast of that. Now let's come to any questions so far on the schedule management, Steve?
No, I just I'm going to have to do the reading and make sure that I'm comfortable with the terms and definitions.
Correctly. Well, yeah, that's right. I'm sure it should be easy. It should be possible. No problem. Right. Okay. Let's go through a few questions so that we'll understand. A project manager is informed midway through the project planning, and she was given the inaccurate data regarding new regulations affecting the required end date of her project. She may need to make a few adjustments. She thinks she can still manage the project to complete it before the regulation take effect. She confirmed this by analyzing the sequence of activity with the least amount of schedule flexibility. So what technique is she using? Is it using the critical path method or the flow chart or precedence diagramming or work breakdown structure? New regulations affecting the required end date of her project. She may need to make few adjustments. She thinks she can still manage the project to complete it before the regulations take effect. She confirmed this by analyzing the sequence of activity with the list. I think you should be able to answer this.
Yeah, critical path.
Critical path, okay. The second question is, a design engineer is helping to ensure the dependencies with their area of expertise, they properly defined on the project. The design of several deliverables must be complete before manufacturing can begin. This is an example of what type of dependency. Is it discretionary, is it external, mandatory, or scope dependency?
Engineer. Well, that's a mandatory dependency.
It's a mandatory dependency. It has to be okay. We'll just look at that. The third question is, your sponsor and stakeholders have made it clear they wish to be kept informed on the project status. There are many aspects of the project on which you will report, and you want to choose the most appropriate tool to use in each case. Which of the following are generally illustrated better by bar charts than network diagram? Is it logical relationship, critical path, resource, or progress or status? Which one you will be using here, in fact?
Which you report and want to choose the most appropriate tool for use, which of the following are generally illustrated better by bar charts. I'd say critical path.
Logical thing. Which are the following? Yeah. Say charts, you can network diagram. Let's look at the answers. The first one, of course, we said critical path method. You're absolutely right. The critical path method is the right answer for the questions. Second one is no mention is made to the dependency, so it has to be mandatory. You are absolutely right. That answer is also right. The third one is the progress or the status reports that can be clearly mentioned in these things. In fact, tool to use in each case. In fact, here the question, Steve. There are many aspects of the project on which you will report, and you want to choose the most appropriate tool to use each case. So probably one of the tool that here use generally is transferred better by bar charts than network diagrams. So the progress or the status reports probably is the one will be the right answer. In fact, here. Okay. That is the rationale. In fact. Project status reports they want. So there are many aspects of the project you will report, and you want to choose the most appropriate tool. So the progress reports or the status report is the one that you need to select. That's only the rationale behind that answer. So the first two, you are absolutely right. It has to be the critical path. It cannot be precedence diagramming or workbook and such. So between these two, the critical path is the right answer. And this has to be mandatory dependency, because unless you do this, you cannot start manufacturing. So it has to be mandatory dependency. Few more questions. A new project manager is walking you through the schedule she has created for her project. She asks you about the duration of a particular milestone, so she knows how to properly schedule it. What will you tell her about a milestone duration? We just discussed about it, the most important point about the milestone.
Milestones don't have duration.
No duration, absolutely right. You hit on it must be right. Which of the following best describe the relationship between standard deviation and risk? There is no relationship. Standard deviation tells you if the estimation is accurate. Standard deviation tells you how uncertain the estimate is. And the standard deviation tells you if the estimate includes a pad. The pad is called a buffer, in fact. That means, you are assuming certain extra period. That's what is pad is. What do you think is which of the following best describes the relationship between the standard deviation and the risk factor?
D.
The standard deviation tells you the estimate. Okay, we'll look at it includes a part. The final one is the float of an activity is determined by performing Monte Carlo, determining the waiting time, determining the lag, determining the length time of the activity can be delayed without delaying the critical path. The float of an activity is determined by performing D. Okay. Let's look at the answers. I think the first answer is absolutely right. The second answer is an estimate can have wide range of still accurate if the item estimated includes. So identify risk, there is no such thing in a PAD in proper project management. So that's the only thing. In fact, the PAD probably this is the right answer. Standard deviation tells you how uncertain is the estimate is. In fact, that will be, there is no relationship is not the answer. Standard deviation tells you if the estimate is accurate, but standard deviation tells you how uncertain the estimate is. In fact, when you look at the standard deviation path, the formula for that is pessimistic minus optimistic divided by 6. That's how you calculate, and standard deviation tells you that how uncertain is the estimate is. And here you're absolutely right. The length of the time can be delayed without delaying the critical path. That's the absolutely right answer, in fact. So that concludes the schedule management. Any thoughts or any feedback or any queries, questions, Steve?
No. I just need to spend some time with the book.
Book it, yeah, that's right, yeah. And the slides also, what I would request you is, of course, tomorrow, once we complete the next 2 days sessions, I think your slides, you can already download it. I think it's available in the Ismart portal. It's available. If it's not there, we can, I will ask them to send it. Some of the slides which I have included, that I will request them to send it across. So these slides, if you go through 2-3 times and then go through the book parallelly or simultaneously, if you are working on that, that will give you some more clarity and easy to understand these concepts. Correct?
Okay.
And that's right. Because so much of material available today on the project management, sometimes what happens if you start going through too many things, you may get confused also. Correct. So stick to some of these resources. I think it's pretty good. And go through these slides 2-3 times and go through the book, PMBOK book. And mock test is the most important thing. At least about 7 to 8 mock tests if you take and score about 75% consistently, you can go through that examination. I'm sure You got so much of knowledge already, practical experience. I'm sure it should be easy one for you to pass this examination.
Okay.
Okay. Okay, great. So we completed. Can we have, because this subject is becoming a little heavy, am I right, compared to yesterday? You agree with me?
What's that?
The subject, the concepts are becoming little heavy. Uh, am I right? So many
Yeah.
concepts, so many formulas, correct? I'm right.
Right.
That's right. But as you said, you need to practice it. That's all. But if you go through, I'm sure, you should be able to. And start applying in your work experience, in fact, or working place. It will be easy for you to understand and remember the concepts also. Like analogous estimation or a parametric estimation or 3-point estimation. If you start applying those formula for your present projects, it will be easy to remember. That's even the critical path that of course, you're already very, very familiar with that. Precedence diagram and start to start, finish to start, those relationships. These are all the common questions. Hello? Hello? Yeah.
Hello?
Yeah, are you back? Yeah, great. Okay, that's fine.
I'm back.
Okay, good. Okay. You want to have a cup of coffee or tea or some snacks?
Yeah. Got a banana.
Oh, great.
A little bit of coffee.
That's
Good to
nice. Good to go, in fact. That's right. Let me adjust the screen. 1 second. Steve, you have a pen and a pencil or paper because you'll have to write down certain formulas.
I do.
Yeah, you do have? Okay, great. I think this is going to be a very interesting session. I'm sure you'll enjoy this session because we'll be doing some mathematical calculations to understand certain concepts of the formulas and other things. Okay, that's fine. So the next knowledge area is the cost management. One of the most important in any project, schedule, scope, and cost, the part of the triple constraints. Because whatever the project success, ultimately, if the cost goes out of control, that project can be a failure. Am I right? You will agree with me on that with your rich experience. Correct?
Oh, yeah. Sure.
So the cost management is the most critical factor in the project management environment. So let's try to understand this knowledge area. In the coming to the formula that you have, the 10-digit number, if you look at it, there are 4 processes here in the cost management, 7664. Can you see the screen, Steve? Hope you're able to see the screen.
Yes.
Yeah.
Yes.
Yeah. Okay. Okay, great. So there are 4 processes here. One is the plan cost management, then estimate cost and determine budget, and control cost. These are the 4 processes in the cost management knowledge area. Let's go one by one. The first and foremost is the consideration of the agile and adaptive environments. As we have been talking about in the beginning of every knowledge area, the projects with high degrees of uncertainty are those where the scope is not very fully defined, may not benefit from a detailed cost calculation due to frequent changes. So when the scope is not clear, there is no point in having a very detailed cost estimation. So in the agile and the lightweight estimation method, the cost, you keep it as a recurring, you keep it as an ongoing thing, and you try to adjust, in fact, the project labor cost, which can be easily adjusted to changes arises, in fact. So as per the changes, it happens, you keep estimating or you are revising the cost estimate. That is the development in an agile or adaptive environment. Unlike in a predictive life cycles, where you have all the details of the exact cost numbers, exact schedule, and all those things, you will have that. But in an adaptive or an iterative environment, adaptive environment, is all flexible, in fact, and will be adjusting according to the changes which arises. So detailed estimates are reserved for short-term planning horizons or just-in-time fashion. I'm sure you must be doing this in your projects also, am I right, Steve? Adaptive adjustments in your budgets?
Yeah, sure.
Yeah, sure. Okay, great. That's right. There are three important things in the process here. The first one is the process involved planning, estimating, and budgeting and control. In fact, these are the four project cost management. First, you estimate the cost, then you budget the cost, then you control the cost, in fact. So developing an estimate of cost, the resources needed to complete the project. So budgeting is allocating the overall cost estimate to individual work. There is always some confusion between cost estimating and cost budgeting. In fact, many people they get confused with the estimation cost and the cost budgeting. Estimation of cost is developing an estimate of cost for each of the required resources or the activities, whereas the budgeting is allocating the overall cost estimate to the individual for the cost baseline. That is the cost budgeting. And how do you control the cost? Controlling change to the project budget, in fact. This is how, whatever the cost baseline is there, you will be releasing the funds according to the cost baseline. That's how you control the cost, in fact. This is what we need to understand in the cost management. So while estimating the project time, WBS is created and break down into project, the smaller deliverables. So the deliverables in the WS, the work breakdown structure will have the work package 1, work package 2, and work package 3. And you will have the activities here, in fact, to complete these work packages, in fact. And you will also have another deliverable is the controlling activity, control account. Now, for each of these work packages, you will have a different control accounts. Particularly in the larger projects, Steve, for example, let's say, in fact, for the infrastructure, the materials could be one cost of control. All resources, human resources may come under another control accounts. All your equipments, for example, you are buying or you're outsourcing could be another control of account. All your travel expenses could be your another control of account. So it's easy for them to monitor and audit those things. So you will have different control accounts, in fact. This is how the deliverables and the work packages and the activity or estimate the cost from this. So if the activities are planned well, it becomes easier to achieve the compliance with the overall cost and budget of the project. So the plan cost management is a process of defining how the project cost will be estimating, how it will be budgeted, managed, monitored, and controlled. This is what you do in like any other planning activity. Here also in the cost management, you plan, you define how the project cost will be estimated, how it will be budgeted, managed, monitored, and controlled. So the first process in the plan cost management is the planning, in fact. So here, what you require the project charter, which gives you broad lines of the cost estimation. That's where you get that information. Then, as I told you, in fact, in the performance measurement, the cost, you need to always have the schedule, in fact. Without schedule, without a number of estimation or the activity estimation or the resource estimation, you cannot arrive at the cost, am I right? So you need to have this schedule management plan to determine the plan cost. Then you will also have the risk management plan. This is another very important input, because every areas, you will have the risk. So you need to have the risk management plan. Then you have two other common inputs like enterprise environmental factors and the organization process assets. So the common tools and technique is the subject matter experts, the expert judgment. Then you do the data analysis. What has been planned and what is the actual that is happening. That is what the data analysis you do. You do the variance analysis. You need to the cost benefit analysis. All those things will be part of your data analysis. Then you have meetings, regular meetings. Then you get a detailed cost management plan as an output from this, in fact. So your inputs are project charter and schedule management plan and the risk management plan, and you get the cost management plan. Just to understand, in your company projects, who you have a accounts manager or a finance manager who handles this cost, Steve?
Yes.
You have, yeah, they have a dedicated team for that to manage this cost. Correct. Okay, that's great.
Correct.
And you coordinate with them. They reports to you, or what is the structure you have? They report to you directly?
Yes, they are. Yeah, they're an equal.
Oh, great.
Equal group.
Okay. Equal group. Okay, that's fine. Great. So the next process is, after planning, you estimate the cost. In the process of developing an approximation of the cost of resources needed to complete the project. In fact, a very simple, straightforward. That's how you estimate. You put all the activity, you put all the resources, and you estimate the cost for each of those activity. Sum it up, then you will get the total cost for the project. So what are the tools and technique here? You need to have the cost management plan. Then you also need to have a quality management plan, your scope baseline. These are the three important from the project management plan. Then you have various documents like lessons learned register, the project schedule, how long it will take. Based on that only you'll be able to estimate the cost. Resource requirements, your human resources, your physical resources, the equipments, all those things, you will put the cost. Then your various risk register and the enterprise environmental and organization process assets. So what are the tools and technique you have? The expert judgment or the subject matter experts. In your company, you have your finance manager. He's an expert who determines that. Then the 4 estimation techniques: analogous, parametric, bottom-up, and 3-point estimating. Should I go through once again these things, or you're familiar with these techniques now, Steve?
No, I'm familiar with them.
No need to repeat, or should I repeat?
Yeah, let's review them as far as costs go.
Sorry, I didn't get you. Should I go through once again these techniques, or no?
Sure, yeah.
Okay, fine. So analogous is based on that, like I explained. I'll just go through once again now, so that you will not miss out anything. Yeah. Analogous is the estimating using this similar project estimate for the duration of your current project. Then 100 days it has taken in the previous project, the same 100 days it will take for this project also. This is how you arrive at that. Parametric is using a mathematical calculation for that. For example, 10 resources were used for 8 hours a day for 100 days, and that's how you develop the website. So the parametric is more authentic or much better technique than analogous. So analogous is considered top driven and is less accurate than parametric. And analogous estimation uses an analogy comparing to the past similar project of your current project. Parametric is always more accurate because you are using a rationale behind this calculation, in fact. Okay, these are the 2 techniques. Then the third one is the 3-point estimating, where you use the optimistic, pessimistic, and most likely scenario. In fact, these are the 3 options, 3 scenarios you look at it. For example, in your case, let's say assume that to reach from home to office, you take about 30 days in most of the time. If there is no traffic, probably you may go within 20 minutes. But if there is too much of traffic, there is a pessimistic estimation of 45 minutes. Then if you add up optimistic, most likely, plus pessimistic, divided by 3, you get 31.7 minutes as a 3-point estimating. It's also called triangular distribution technique. The next one is the PERT formula. Again, it's a 3-point estimating, but here, instead of the most likely, if you take only once, probably it can be skewed. So you are taking the average of it by 4 times. So here you use the formula of optimistic, pessimistic plus 4 times most likely divided by 6. And PERT stands for Program Evaluation and Review Technique. Here, if you calculate the same information by using this PERT, you get 20 plus 4 times most likely of 30 minutes plus 45 minutes divided by 6 gives you much more accurate duration for this. In fact, the same thing applies for the cost also. In fact, so 30.8 days. Probably, if you change these numbers into the cost for this travel incurred, then you will get the cost estimate. In fact, so these are the 4 technique that you need to: analogous, parametric, 3-point triangular distribution, and the PERT formula. Is it clear, Steve? How?
Yeah. I just didn't know if they apply the same to cost as it did to schedule.
Same thing applies. Only thing is that unit changes. Instead of duration here, you put the cost. That's all in fact.
Okay.
But the same formula, the same analogy applies here also. The same techniques. That's right. Okay. Data analysis, it is you have the alternative analysis, make or buy decisions, or you can look at those things. Then the reserve analysis, which I explained you very clearly, that known unknown factor or unknown factors. Known unknown factors are your contingency reserve. Unknown factors are your management reserve. Then you have the cost of quality. We'll go in detail in the quality management so that you can understand in the following knowledge area. Then you will have the project management information system and the decision making, whether you're voting or you're taking the multi-criteria decision, or you're looking at autocratic decision or what that. Then you get the cost estimates and the basis of estimates. How did you arrive at the cost? In fact, what is the rationale for each of this activity that you have arrived at? Because you have a rationale for that. So you'll have the basis of estimates. Then your documents gets updated is your project documents, your assumptions log, your lessons learned and risk register. All those things gets updated in the processing. So after estimation, this is another important thing, talking about the project schedule. When you determine the project schedule, let me enlarge this so that many times I think you must be doing is projects, that you also use that the availability of the resources. Sometimes, the resources becomes very scary if they're not available. Then what happens, the cost of those resources will go up. It could be raw material, it could be even the people. Let's say during December, suppose you need to do certain project work. You see, December is your holiday season, am I right? Many of the people goes on leave. So at that time, if you want a particular resources, probably you may have to pay more, am I right, Steve, to get that resources?
Yep.
Correct,
Sure.
Yeah. So your project schedule, you keep those factors in mind while developing the schedule, in fact. That is the first. The second is you need to have a time phase spending plan to monitor and control project expenditure. That means, this is a demand and supply situation. So accordingly that, you will plan. And another example of cost human resources may be impacted by their availability. If a lower period resource is not available, you may have to pay more for a higher priced one. So you look at all those things, while developing your project schedule. I was telling you about the construction project in Bangalore. About 7 to 8 years back, there's a lot of scarcity about the sand availability. So can you believe it cost went up almost by 50 to 60% what they were paying. So the most of the construction project got halted because of that. And next time when they made the schedule, they kept those factors into mind and worked out the revised schedule. Because if they bought at that price, the project would not have been viable at all, in fact, by paying the expensive price on the sand. So you need to keep those factors while developing the project schedule. I'm sure you must be doing it in your projects also in this side. So
yeah,
the
correct.
types of, sorry, you were about to say something?
No. Yeah, we do monitor things like that, right?
Yeah, you do monitor, exactly. This is one very important thing, the types of cost estimates. One is the rough order of magnitude. It's called a ROM. It is particularly for a longer project, 3 to 5 years before project completion. It provides a very high rough estimate. It's minus 25% to plus 75%. It's called ROM, rough estimate, in fact. The budgetary estimate within a short period, within a 1 year, 2 years, then probably it puts a dollar in the budget plan. It is minus 10% to plus 25%. Definitive plan, when you're about to take up the project, then you make a definitive estimation. It provides a detail for purchases, estimate actual costs. It's a minus 5% to plus 10%. This is the definitive budget plan. You can take a picture of this because this is very important from the examination perspective also. So ROM is always minus 25 to plus 75%. Budgetary is minus 10 to 25% and minus 5 plus 10% is your definitive budget. You have some idea that what type of estimates that you do in your projects?
We actually do mostly definitive.
Mostly definitive? Okay. Great.
Yeah.
Okay.
Because we just, when we enter into a contract,
yeah,
we don't have the flexibility, so we've got to be very drilled down with our estimate.
I stopped there. Oh, okay. So it has to be a definitive estimation. In fact, that's right.
Right.
That's
our
right.
business requires us to be very definitive.
Yeah, correct. You don't have the luxury of correct estimations. Correct.
No.
Probably if you do the rough order, you may not get the business, right? ROM, if they do minus 25%, 75%, yeah. You may lose the contract itself. Correct. That can happen.
Right.
But this is important from the larger, the principles. For example, the organization is making a projects, an internal projects, and they prepare with a horizon of 3 to 5 years. They make a rough order estimate because why in that long term, 3 to 5 years, this range is important because we don't know after 5 years what can happen, right? There are many things, which beyond your control, in fact. Correct. Whereas 6 months project or a 9 months project like you have, like for example 270 days. 270 days is around 7 months old project. So you'll be able to have a definitive budget because things may not change in the 6-7 months. But if it is 3 to 5 years, definitely inflation cost, the cost of money can go up, the cost of resources can go up. So they will have a ROM is called the rough order of magnitude. That's the rationale why you should have this impact, just to understand those things. So the methods of cost, for example, here the expected accuracy of estimate, the order of magnitude is here, while completion. For example, yours is very definitive because it's always near to your completion within the 6 months or 7 months of horizon. So it has to be a definitive budgets, in fact. This is the methods of estimating. From the examination perspective, kindly do remember, ROM is minus 25% to plus 75%. Your budgetary is minus 10 to plus 25%, and definitive is minus 5% to plus 10%. So here the estimating methods, of course, I have explained you. This is again a pictorial presentation. Analogous is a previous similar project is equal to the new project. Your parametric is use the rational approach for the new project. Bottom-up estimating is estimating from the bottom of work packages. You calculate, it's very accurate. The only disadvantage in bottom-up estimating is that time consuming. It will take a lot of time to estimate each work package's cost and make it, apply that. Then 3-point estimates, which I explained you, there are two. One is the triangular distribution, where is the optimistic, most likely plus pessimistic divided by 3. And the PERT, the program evaluation review technique, it will have 4 times most likely in order to make much more accurate estimation. So you will have optimistic plus pessimistic plus 4 times most likely divided by 6. You will get the estimation, in fact. So these are all some of the estimating methods. Both are common for schedule as well as the cost management as well. Any question on this, Steve? Because I hope it's the concepts are
No,
clear. Yeah, great. Yeah.
sure. No, got the concept down. Sure.
Okay, great. Okay, that's fine. So once you estimate, then you need to determine the budget. This is very important. Determining the budget is the process of aggregating the estimated cost, individual activity, and work packages. So you have estimated the cost for each of those activity. Now you need to aggregate it and individual activity or work packages to establish an authorized cost baseline. So your authorized cost baseline is aggregating of all the cost activities cost, and the total of it will become your cost baseline. So the project cost performance is measured against the cost baseline, and the cost baseline include the authorized budgets but excludes the management reserve. This is a very, very important point to note. So your authorized budget includes your contingency reserve but excludes the management reserve, in fact. Probably I have a slide, I'll show it to you. Yeah, if you look at it here, let's say, in fact, this is your activity estimate. Can you see the slide, Steve? I hope you're able to see that.
Sure.
Yeah, so this is the activity estimates, you are arriving at it. This is the work package 1, work package 2, work package 3, and you will have, as I explained you, each one of them will have a control account estimates. Under each of these, you'll have a control account. Then it will give you the project estimates, $1,250, for example. Here, this plus contingency reserve, $105, is your cost baseline. So this does not include the management reserve of a certain percentage, that is for unknown factor. But if you ask your management what is the total cost budget for the project, it will be include your management reserve. Only difference is your cost baseline does not include the management reserve, whereas the total cost budget includes the management reserve. This is what you need to remember it. I hope it's very clear, straightforward. Correct? Am I right?
Yeah.
Yeah. Okay, great. So once you estimate, you define budget, you need to have determine the budget. Here you will have the basis of cost estimates, and you'll have cost estimates and the project schedule, because only on the project schedule you'll be arrive at the cost estimates, because your resources, the duration of the resources you need to take in mind, and you arrive at it. Then you will have your risk register, your business documents like business case. Yesterday we discussed in detail the need of the business, why you are taking it up. Is it because of the technology? Is it because of the social need? Is it because of the competition? All those things, needs are clearly explained. And I also explained to you about the benefit management plan, how we are going to measure the success of the project, how you are going to pass on the benefits, in fact, or how we are going to review, in fact, transferring roles and responsibility, who will be responsible, what is the time horizon, all those things, a document that will be part of the benefit management plan. Then you will have the various agreements. We'll discuss regarding agreements in the procurement management plan in detail. Then you will have the enterprise environmental factors and OPA are the two common inputs we'll look at it. So the tools and technique, expert judgment, the cost aggregation, which I just showed you this slide. This is the cost aggregation. You are aggregating the cost from the activity estimate. You are aggregating it. This is the tools and technique that you use. Then you will also look at the data analysis, the reserve analysis of known unknown factor and unknown factors, the contingency reserve and the management reserve. Historical information review for the similar project which has been done in the past. You also compare whether this cost, what we are arriving at, is it similar to that or is it any changes to that? In fact, what are the factors? You also look at the historical information, in fact, so that that will give us some idea whether you are in the right way of doing it. Then your funding limit reconciliation is nothing but as the project progresses, the management keep releasing the funds, in fact, based on the requirement. So they will have that limit reconciliation at a particular stage. For example, you have done 30% of the project progressed, they will release 30% of the fund allocated for that. That is a reconciliation. They will be doing it on a periodic basis. Then the financing, whether it is a management decision, whether they internally they want to finance or they will go for the outside financing, and at what cost they can borrow the capital, in fact, and they will do the cost benefit analysis. All those factors will be taken into consideration while financing the budget or financing this project, in fact. So these are all some of the tools and techniques that we'll be using while determining the budget. Suppose if the cost of the borrowed capital is very high, then your break even or for the return on the investment may not be controlled. So you need to look at all those factors, the cost of financing, while determining the budget. Then the outputs. In India there are certain projects they do fail because the cost of capital is very, very high, Steve, in fact. So when you calculate the cost benefit analysis, if the funding is, the cost is very high, naturally it will have a lot of impact on your project outcome. So you need to be very careful that what is the finance cost for every project. You agree with me on that point? I'm sure you have experience, I think, those areas.
Yeah, we run into that a lot.
Okay, that's right. Then you will have the cost baseline. Cost baseline, you take into consideration all these factors. Then project funding requirement is another output you get. Because you are using this technique of funding limit reconciliation, then you will get the funding requirements, that at what stage, how much fund you require for your projects. Then project documents updates, your cost estimates gets updated, your project schedule gets updated, and your risk register also gets updated. These are all the important outputs from the determined cost. Okay, now this is an important thing to understand. You see, if you look at it here, this is your time zone for your project. This is your cost baseline. You see, this is cost baseline. This is also called as a S curve. It is in the form of an S, in fact. That's why it's called the cost baseline is represented in a form of S curve. Now, this is your BAC. You are familiar with the term BAC, Steve?
No.
BAC is your budget at completion, BAC. That means for your project, you said $2.5 million was your initial estimate, am I right? Initial budget, correct?
Right.
So that is your BAC. $2.5 million is your budget at completion. If you don't mind, you can just make a note of this. BAC is a budget at completion, in fact. That is your planned budget for the project. Now, your expenditure, for example, this is how you are spending your expenditure. This is how it's going. Now, your funding requirements, let's say, you have spent up to here. So your management will release this much of expenses. This stage they will release, this stage they will release it. So if it goes, now here what is happening is your expenditure is exceeding your BAC. This is your budget at completion, but this is your estimation of expenses, correct? Am I right? So you need to get some management reserve to complete your project, in fact. So this is the project budget, which is inclusive of the management reserve. So here, since the project is going out of beyond your budget at completion, you are trying to utilize the management reserve, or this is the forecast that you need so much of extra money to complete the project. So this is the cumulative values. This is the time horizon. As the project progresses, you know that you need some extra money to complete the project. This curve, this is known as a S curve. S curve is the cost baseline curve. And initially the cost will be less. As the project progresses, you will be requiring more and more funds. And by the time of you complete the project, you would have exhausted all your funds, or you would have exceeded the project funds. You got some idea, Steve, now? I think. Yes.
No, actually, with the when we do submit a cost-loaded schedule, we've got to run an S-curve graph.
S-curve graph. Okay, great. Okay.
Yeah.
Okay, great. It's almost similar to this. What you do? Am I right? You must be doing that.
Yeah. Actually, it's exactly like this.
It's exactly like this. It's called as known as a S-curve. Correct. Great. That's nice.
Right.
Yeah. So the final process in the cost management is the control cost. So the control cost is the process of monitoring the status of the project to update the project cost and managing changes to the cost baseline. So if the cost is going up, if it's going beyond thing, then you need to monitor and control it. So the typical activity for the control cost process are ensure that the cost expenditure does not exceeding the authorized budget. But this is easier than said and done, am I right? Correct, Steve, you agree with me? Ensure that cost expenditure does not exceed the authorizing budget. It's very easy to say, but most of the time, the cost exceeds your budget, in fact. So that's a big challenge the project manager always have in every project. Out of 20 projects which I handle in my organization, I still remember at least 10 to 12 projects, went beyond the schedule, went beyond the cost estimated, in fact, because of various reasons. One is, however best planning you do, sometimes the resources, the cost of the resources goes up. Sometimes, the availability, all such issues, that the cost will go up, in fact. But most important thing in the control cost is the how you control your budget, the authorized funding. They monitor the cost performance to understand the variance and monitor the work performance against the funds expended. This is what we basically do in the control cost. So what are the inputs here for controlling the cost? You need to have a cost baseline. Then you will have a performance measurement baseline. Performance measurement baseline, as I explained you yesterday, you will have a cost baseline, you will have a schedule baseline, and you will have a scope baseline. All these three put together, you will explain as the performance measurement baseline. Then you will have the project documents, lessons learned register, your project funding requirements, and in all the monitoring and control process, you will have the work performance data as one of the key input, and the output is always the work performance information. In the monitoring and control process of all the knowledge area, you will have the work performance information as the output. And you will have the OPA, organization process assets, as one of the important input. So what are the tools and technique here we talk about? Your expert judgment, your earned value analysis, which we are going to discuss in detail. Variance analysis is the comparison between the planned versus actuals, in fact. What has been planned and what is the actuals, you do the analysis. Then your trend analysis of the previous projects, you also look at how the trend has been, you try to compare with that. Your reserve analysis is nothing but, as I told you, that management reserve and the contingency reserve. Just to repeat once again, contingency reserve is up to the cost baseline. It includes, that is, the known unknown factors, and management reserve is the beyond the cost baseline, but it is including the total budget for the project, and it will have the unknown factors. To complete performance index, TCPI, it's called. I will discuss you with in that formula in detail so that you will understand what is the work remaining and what is the fund remaining. In fact, that is the TCPI, remaining work and remaining funds available. So that is the TCPI, to complete performance index. Then you will have the project management information system where you generate ideal data to compare all these things. So what is the output here you get? You get the work performance information. This is the output of the work performance data. Then you will have cost forecast, because based on the information available, the variance analysis you do, you will get the cost forecast. Then change for request and the project management updates, all these things gets updated in the process. Now let's come to the most important part of the cost management, earned value management. It is called EVM. So what is EVM? It's a measurement project performance against the project baselines. What are the three cost baselines? You will have the cost baseline, you will have the schedule baseline, and the scope baseline. But here you basically use only two baselines, the schedule baseline and the cost baseline. You need to remember that. You take the schedule baseline and the cost baseline. Result from the earned value analysis indicate potential deviation of the project from the cost and schedule baselines. So the schedule baseline is the first approved project schedule along with the approved changes. This is very important. Unless the change has been accepted or approved, it cannot become the schedule baseline. Similar way, even the cost baseline has to go through the performs integrated change control and gets approved, then it will become the cost baseline. This part is clear, Steve, I hope. Earned value management?
Yeah,
great. Yep. Okay, that's good. So now let's come to some of the terms. Probably I request you to memorize these things. That's the only way you can remember. The best way is to write every day at least 5 to 6 times, so that you will remember these terminologies or also these formulas. The first one is PV. It's called planned value. Planned value is your authorized budget assigned to schedule work. Let's say, in fact, Steve, you have got $2.5 million is your BAC. That is a budget at completion. Okay, let's take that. You kindly write it down. $2.5 million is your BAC. That is your authorized budget or budget at completion. Now, planned value is, for example, you are evaluating the performance. You said how many days project it is? 270 days project. Am I right?
Yeah,
correct?
Sure.
Let's take, in fact, let's take approximately it is a 7 months project. Okay, 7 months in terms of months together. So let's say at the end of 3 months, okay, at the end of 90 days, what should have been your budget assigned to that project? So at the end of 90 days, 270 days is your project. 90 days, that means 30% is your authorized budget at the end of 90 days. Am I right? Correct? You agree with me on that?
Yeah.
So your authorized budget assigned at the end of 90 days is your planned value. Okay, so how much it comes? 30% of $2.5 million?
30%.
Of 2.75 of 2.5 million. Is 0.75 million or how much is that?
0.7, yeah. $750,000.
Yeah.
Right.
So that is your planned value for your project at the end of 90 days, at the end of given period. Okay. Now the earned value is, it is work performed in terms of budget authorized for that work. Now let's say at the end of 90 days, you should have your planned value is 30%. Let us say you have spent, you have earned or you have completed only 20% of the work. Okay, you should have done at the end of 90 days, you should have done 30% of the work. But at the end of 90 days, you have done only 20% of the work. So what is your earned value for the project?
Well, you said 20%?
Yeah, you have done 20% of the work at the end of 90 days.
On $2.5 million.
20%? Is
$500,000, 500,000.
$500,000. That is your earned value of the project at the end of 90 days. You got it?
Okay.
That is the work performed in terms of budget authorized for that work. Okay.
Right. Okay.
Now I will take you to the one of the project which for you to easy to understand these terminologies. So I have made a thing. Okay, let me take that so that I can understand better. You can understand better. Just 1 second. Give me a minute. Here is a scenario just to understand. Can you see this, Steve? Can you see this? Okay.
Sure. Yeah.
Yeah. So let's try to understand the planned value, earned value, cost variance, actual cost, and schedule variance. So I made a project. Here is a project. The scope is 4 walls to be constructed. This is a scope. Schedule 4 weeks and 1 site per week. This is one week, $1,000. Second week, $1,000. Third week, $1,000. And fourth week, $1,000. That is the schedule. Cost per side is $1,000. So your total BAC, that is the budget at completion, is $4,000. Now, we are reviewing this project at the end of third week. At the end of third week, 2 walls has been constructed and you have actually spent $3,000. You got it, Steve, this information? Easy to understand.
Sure.
So there are 4 weeks and budget is $4,000. Third week, you are analyzing it. You have spent 3,000 actually, and 2 walls have been constructed. Now let's try to understand. I explained you about the planned value. I also explained you about the earned value, in fact. Correct? Am I right? So let us try to put this number in this project. Now, the planned value, the authorized budget assigned to schedule work. Now here, the planned value, are you seeing the screen? Hope you are able to see this.
Sure, yeah.
Yeah. Okay, if you look at it, at the end of third week, 2 walls have been constructed. Okay. So your planned value at the end of third week, you should have done 75% of the work. So $3,000 is your planned value. Correct? Am I right? You got it? This is your planned value. Now your earned value is the work performed in terms of budget authorized for the work. Now only 2 walls have been constructed at the end of 3 weeks. So your earned value is 50%. That is $2,000 is your earned value. These two you got it, because these two are very important because all the calculations are based on this understanding. In fact, your planned value and earned value. You got this, Steve?
Yeah.
Okay.
Yeah.
Now the actual cost incurred is a straightforward $3,000 you have spent. This is your actual cost. This is what you have spent. Now cost variance, the formula is cost variance, earned value minus actual cost is your cost variance. Please remember this formula. Earned value minus actual cost is your cost variance. So in this project, your earned value is $2,000. Your actual cost is $3,000 you have spent. So your cost variance is minus $1,000. Got it?
Yeah.
Okay. And schedule variance is earned value is known as SV, is your known as earned value minus planned value. That means that is your schedule variance. So $2,000 minus $3,000 is your minus 1,000. This is your schedule variance. Now, this is the variance. You also need to have the indexes. the CPI, there is a cost performance index, is earned value divided by actual cost. Here, variance, you are minusing it, but for the index, you are dividing it in fact. So $2,000 divided by $3,000, your cost performance index is 0.67. And similar way, your schedule performance index is also 0.67 in fact. So what is the inference? How do you, what's your analysis about this project?
According to the index, it's not making the money it should be right now. It's behind.
Correct. And it is, the project is behind the schedule and above the cost, correct?
And it's above cost, right?
So this is the inference, or this is the analysis you make from this project, in fact, correct? Why I made this, if you understand this simple thing, then the following things, it's easy to understand, in fact. So you have a planned value, just to repeat once again, is the authorized budget assigned to a scheduled work. So here it is a 75% of the work should have been completed. So assigned value is $3,000. Your earned value is the work performed in terms of budget authorized for the work is a 50% of the work has been completed. So $2,000. And cost variance, this is the formula. I request you to memorize it or mug it up. Cost variance is earned value minus actual cost. Schedule variance is earned value minus planned value. Then index is you are dividing it in cost. It is earned value divided by actual cost, and schedule performance index is earned value divided by planned value. Hope it's clear, Steve. So far?
Yeah, it is. It is, sure.
Okay. Yeah. Okay, great. Now, we'll go to the few more formulas later. First, let's come back to that, the slide. So so far we have covered these things. Slide show. Okay, take it from here. Actual cost is the actual incurred in the work performed. BAC, budget at completion, budget of the amount of the total work. Now EAC is the estimate at completion. Now is the a formula for that. Now for your project, you are selling that, it's a $2.5 million is the project BAC. How much it is going to cost, Steve, has been estimated?
My EAC on it? Yeah, if it was, yeah. If it's
BAC
$2.5 million, we're going to add another, yeah, it's going to cost another $300,000 for extended general conditions, overhead.
So, okay, so your EAC is now a $300,000, correct? Earlier it was $2.5 million. Right. So what will be your estimated completion now? Total estimation at completion? You're planning, you're estimating?
2,800,000.
2 million?
2,800,000.
So it's going up by another $30,000, correct? Or $300,000, sorry. So that makes, that is, yeah. So that is your EAC now, correct? So, estimate to complete ETC is the expected cost to finish all the remaining work. So there is a formula for that. Then variance at completion is the project budget surplus or deficit, in fact. So what are those formulas? Let's look at it. So this I explained you. BAC is the budget at completion, and PV is the BAC multiplied by planned percentage of complete. So that is your planned value. Now for this existing thing, $2.5 million is your BAC. 30% of the work has been completed. So 30% of the BAC is your planned value. And your EV is the earned value is your BAC multiplied by the actual percentage of complete. So in your case, Example, you are taking your BSc as a $2.5 million multiplied by you have done 20% of the work at a given period. So that will become your earned value, in fact. So earned value is BSc multiplied by actual percentage of complete. Planned value is BSc multiplied by the planned percentage of complete. Have you made a note of this, Steve, somewhere? You remember that? Oh.
Yeah, sure.
Sure. Okay. Okay, great. So the earned value management, this is again revisiting that to some extent. Here, the due date, for example, data date you have, here is your cumulative cost. So your BAC is this one. This is your BAC. And your earned value is the percentage of actual completed at a given period. Your actual cost, you know. From here, you calculate the estimate to complete. Estimate to complete is going beyond your budgeted completion. So this will become your EAC. Okay. This is the management reserve. This is again, you know, you take it as a S curve and you work on that. This is the earned value management. Now let's look at this formula a little more in detail. So earned value management, this is the period. The red one is your actual cost. This is your planned value and this is your earned value. In fact, this is how it's going up. That means your expenditure is going more than your project allocated budget. So now this is another very, very important slide. We'll spend a couple of minutes. So the cost variance, CV, I just now explained you, it is earned value minus the actual cost. Sorry. The negative is over budget and positive is under budget. Very common sense, easy to understand that. Schedule variance is earned value minus planned value, which I just explained. So negative is behind schedule, positive is ahead of schedule. Cost performance index, earned value divided by the actual cost. So the worth of work got out every $1 you spent. Greater than 1 is will be always better, because that means your budget is under control, but less than 1 will be always negative. Similarly, it applies to the schedule performance index, EV by PV, percentage progress made against the planned rate. Now, there are 4 formulas for the estimation at completion. It's very important to understand, Steve. Now, one formula is your budget at completion divided by cost performance index. That means the project is going work performed at the current CPI. Whatever the current CPI, the project you're doing, you need to use the formula. Now, if the project is going at the budget, rest of the project will go at the budgeted rate. Now it has been exceeded, but rest of the project go at the budgeted rate. You need to use the formula actual cost plus budgeted completion minus earned value. So this is the formula you need to use for the rest of the project at budgeted rate. Now, suppose the future, you need to factor both CPI and SPI. You need to use the formula actual cost plus budget at completion minus earned value divided by CPI multiplied by SPI. That is a factoring both CPI and SPI. The last one in the AAC is that suppose if the project is really going out of control, then you need to use actual cost plus estimate to complete. This is reevaluated based on the forecast of ETC. So these are the 4 formula you need to remember while calculating the estimate at completion. Now, estimate to complete, the formula ETC is EAC. One of these EAC formula you need to take according to the context, according to the scenario, minus the actual cost. That is amount that project would cost from the current size to the end of the project. Variance allowance VAC is your BAC minus EAC. That is budget at completion minus your estimated at completion. That is the formula you need to take. To complete the performance index, as I told you that you have to take two formula. One is managing as per the budget. It is a BAC minus earned value divided by BAC minus actual cost. And for managing to the specified earned value, instead of BAC, you'll be taking it the EAC minus AC. Seems to be tough or easy to digest?
No, it's pretty straightforward.
Pretty straightforward,
the EAC reports, reports I'm accustomed to doing are EC plus ETC.
Yeah.
The performance index, we really didn't get. I've never really gotten into it, and it's kind of intriguing.
Okay.
To work with it, to be able to derive the value of it.
Absolutely
and then
right.
Using the performance indexes as multipliers. It's once again it's an intriguing thought, like the BAC divided by CPI.
Correct.
I like that. I like that. That's a rough idea of your EAC.
Absolutely right. Yeah, that's right.
Particularly, I would see the value of that when the project becomes a little bit more mature, maybe.
Matured in fact, absolutely right. Correct. Yeah, that's right.
Hey, no. This is all good stuff. This is right down my alley.
Yeah, it's very interesting. And as you are absolutely right. If you apply these numbers to your current going on projects, you will have a lot more clarity. And tomorrow when you talk to your finance guy in these terms, this is my BAC, this is my estimation, and this is going to be the earned value or the planned value, they'll feel very happy about it. Am I right? That you are on the same page of your finance guy.
Yeah.
That's right. Now let's try to understand with some practical things so that it's clear. So now, okay, this is again a repetition of that. EAC is your actual cost plus bottom up minus ATC, different scenarios. We'll revisit it once again. Now, here is one for calculation. Let's do this, in fact, okay. Your current project is $800,000, okay. And the two teams of programs that will work for 6 months, a total of 10,000 hours. According to your project schedule, your team should be done with 38% of the work, and you find that your project is currently 40% complete. You have spent 50% of the budget so far, so calculate these numbers. What's your BAC? What's your actual cost? What's the schedule variance? What is the planned value, earned value, and cost variance? And what is the CPI and what is your SPI? And based on that, can you determine whether the project is ahead schedule or behind schedule or over budget or under budget? Can we just do this, Steve? So what's your BAC number?
$800,000.
$800,000. Great. What is your AC, actual cost?
$400,000.
Excellent. Great. And what is your schedule variance? What is the PV and EV? What is the PV value?
The PV is 304.
304. And EV? Yeah, EV?
Yeah, 320,000.
Excellent. Great. And so what is SV and CV?
Your CV is minus 800,000.
Yeah. And SV?
Your SV is plus 16,000.
Yeah. Earned value minus, it is SV is earned value minus planned value. Great. So what is SPI coming? Earned value, earned value divided by planned value.
Your SPI is 1.053.
Okay, great. And cost performance CPI?
0.8.
Oh, great. So what is your inference? The project is what? Is it ahead of schedule or?
It's ahead of schedule. Project is ahead of schedule. You would consider it's a pretty slow, I think it's a pretty narrow indicator.
It's over budget, is it? 0.8?
Yeah. I don't know if it would be worth crashing or not for.
But is it over budget or under budget?
It's over budget.
Over budget. So you should find whether consider crashing schedule or you should find a way to cut cost. One of that, you need to take a decision. Okay. Now let's look at the correct numbers, whether it's right. So you're absolutely right. Is $800,000, $400,000. So 16,000 your schedule variance. Planned value is 304 and earned value is 320. So this is 80,000 your minus cost variance. So your CPI is 0.8 and 1.05 is your SPI. So it's actually is ahead of schedule and the project is over the budget. So you should consider the schedule. One of these you need to take. Since CPI is below 1 and negative, the project is over budget. And cost cutting is definitely a good idea because your schedule you have no issues. Only reason is your cost, you are spending more than that. So the best thing is to not crashing the schedule because you are already ahead of the schedule. But since you are overspending, you need to cut the cost in fact. Congratulations, Steve. You have done so well. Very good. I really appreciate. You got it first time itself.
No, this is the fun stuff.
Yeah.
Stuff that
you do it.
I like the analysis and reasoning.
Were you familiar with these terminologies? Cost, PV, EV. Were you familiar earlier?
Just on the margins. I've never really worked with much, but I can definitely see the value of it.
Okay, great. In fact, I think you got some idea. I think the same thing you can apply for your present project also. Am I right?
Sure.
So Tuesday, when you go for the meeting, you have these numbers and go. You will have a lot more ideas to convince them. I think. Right.
Sure.
Yeah, that's great. I'm happy. Congratulations, because I've seen that many of my sessions. These things they take a lot of time. I've seen students. And second thing, they make many mistakes also while calculating. So we had to do it 2-3 times. I'm so happy that very first attempt, you got it through because, of course, you have a lot of rich experience and you have the management skills. I think that must have really helped you to calculate these numbers. My sincere appreciation once again, Mr. Steve, for this. Very nice. Great. That's really great. Yeah, that's really great. So this is one probably you can take this discuss probably after the break you can do it and we can discuss after lunch probably.
Sure.
Can you take a shot of this? Is it possible? Is it visible? Sorry. These numbers. Sorry. You are a project manager working on a large project. I want to do this in the break time probably so that we can finish it and after break, you can do when you get some time.
Sure.
So if you can take the picture of this, you can work it out if you want. So project manager working on a project schedule for the last 2 years, you have got 6 different teams working on the 5 major functional areas. Some teams are ahead of schedule and others are falling behind. That means that you have got cost overruns in some areas, but you have saved cost in others. And that is making it very hard to get an intuitive grasp on whether your project is over or under budget. It is 9 months into your project. The total budget for your project is this number, 4 followed by $200,000. And you have spent 1,650 1,650,000 so far, and you have got a CPI of 0.875. Use the earned value management formulas from forecasting to figure out where this thing stands. What is the EAC, estimated at completion? What is the ETC and variance allowances, variance at completion? Will the project be over or under budget when it's completed? The project will be over budget or project will be within the budget, and how much will be the project over or under budget? We take this figure, we'll do it during break. We'll take some extra time and try to complete it. No problem.
Sure, no problem.
You got the details, Steve? You have all the information now? Okay, great.
I do.
Okay, we'll move on then. So this is okay. This is another thing you will try to do now, in fact. Here's an example. A software development project has 4 phases. Each phase takes a month to complete, and it is estimated a cost of $10,000 per phase. The phases are planned to be completed one after the other. Given the project status at the end of 3 months, calculate CV, SV, CPI, and SPI. So this is the project, 4 phases you have, and $10,000 per phase. The first month, this is the thing, complete spend $10,000. Second month, if you look at it, is a complete spend $12,000. Third month, it is 50% done, and the fourth one is yet to start. So this is the status at the end of 3 months. Can you please calculate what is the cost variance, schedule variance, cost performance index, and schedule performance index? It will take some couple of minutes, and you can just prepare this.
Okay.
Yeah, great. Done?
Yeah.
Okay. Yeah. So what's your planned value is how much?
Planned value is 30,000.
30,000. Great. And your earned value?
25,000.
25,000. Yeah, because 2 months and 0.5% you are taken, correct? Just compare it.
Right.
So this is what it is. So your planned value is $30,000, right? Your earned value is $25,000, correct? And what's your actual
Correct.
cost? You are taken 31,000.
30,000, right?
Yeah, and cost variance is right. Once you have these number, rest all will be right, correct?
Yeah.
This is the tricky part of it. In fact, if you know how to get these 2 numbers right, rest all numbers will fall into that, correct? So your actual cost is 31,000. How did you arrive at it? Is 31,000 is 10, 12 plus 9. You just add up these 3. This is your actual cost. Then your cost variance is 25,000 minus 31,000 is minus 6. Correct? You have the numbers. And your SV is minus 5,000. So the project is behind schedule and it is over the budget. So your CPI 0.8 says that what is get out of the dollar spent and schedule index is 0.83. That means the project is progressing at 83% of the original planned value. You got it right, Steve. Congratulations once again. Very nice, in fact. Okay. I'm sure now you have a hang on these formulas. I think you can calculate any numbers by using this technique. Correct? Am I right?
I mean, it's. I'll do some more practicing to get proficient at it.
Absolutely right.
But yeah, sure.
Yeah, sure. That's right. Now, if you have this much of knowledge, I think you can crack any formulas. In fact, I'm right. These are all the basic things. So okay. The point I'm trying, you just try to memorize these formulas, and once you know this formula, you can 5 seconds, 10 seconds, you'll be able to answer the questions. Am I right? You agree with me? Correct?
Sure. Sure.
So this will help you. Yesterday I was explaining to you. Sorry. Yesterday I was explaining you in the scenario-based questions or the case-based questions, where to read the question itself, it will take a lot of time. But this type of questions, it's in a jiffy, you can read and answer if you know the formula correctly, in fact. So you can save as much time as possible in answering these mathematical based or straightforward questions. That's what I want to do. Actually, when you go for the examination, Steve, you'll have 4 hours. Now it's called brain dumping. You must have heard about that. Means they will give a page, a piece of paper, and also a pen, and they will also give a calculator. When you can request them for a calculator. Of course, the computers will have the calculator, but suppose you want to have some external calculator also, they will provide. First 5 to 6 minutes, what you should do is you should write down all these formulas and few other things which I'll explain to you in the next session. You write it down on a piece of paper and keep it in front of you. Okay, this is an examination tip I want to give you. So that once you have these formulas in front of you, you don't know which question will come when. It could be a 5th question, it could be a 10th question, or it could be 100th question. But once you have these formulas in front of you, it is easy to answer those questions. That's what you should do. What I did, I started practicing 1 month, every day I used to write down these formulas, and near to the exam, I was able to write down all these formula without looking at in about 5 to 6 minutes, around 20 formulas. In fact, I could write that. So I want you to practice it like that, and you have in front of a system so that, when this question comes, it will be easy to answer those questions. That's what you should practice.
Okay.
Yeah. And so that, you're 100% sure of scoring the marks. And by doing this, at least around 20 questions you can expect from these formulas and a few other things where, in a jiffy you can answer and you are sure of answering these questions. That's what I want you to do when you do the mock test as well as when you appear for the examination.
Okay.
Got it. And so far, I'm so happy about that. You were able to get both these two, because many of the students I have seen, they really struggle to answer this in the first attempt or the second attempt. But you got it very first attempt right, in fact. So you have that skill and absolutely. I'm so happy about that. It's good.
Me too.
Yeah, it's great. Yeah, that's right. So let's get into some of the questions in the cost management. The finance department requires that you keep them updated of the cost being spent on the capital project you are leading. You are required to submit a funding plan, and monthly forecasts are necessary so that any changes to the funding plan can be requested in advance and evaluated. Exceeding the budget limit is unacceptable as it will impact the stock value. You have successfully implemented the processes and practices to anticipate funding changes, and you evaluate them to minimize the problems and increase the efficient use of funds. You have employed a variety of reporting and analysis techniques to meet the finance department requirement. One of them is the earned estimated at completion EAC, which is the periodic evaluation of the cost work completed, the value of the work performed, the anticipated total cost at project completion, and what it will cost to finish the project. It's a long question, but a very short answer.
Yeah, it would be C, wouldn't it?
Absolutely. Yeah, absolutely. It's the estimate at completion, of course. But they're given a long, just to confuse you, they're given so many things, in fact, I'm right. To mislead you sometimes, to scare you, such a long question. But it's a very simple and straightforward. Estimation at completion, EAC, is the periodic evaluation of anticipated. Okay, that's what is right. Now, if the earned value is 350, actual cost is AC, and planned value is 325, what is the cost variance, CV?
Earned value and actual cost. D, minus 50.
Sorry?
D, minus 50.
It's EB minus AC, correct? Am I right? Yeah, minus 50 is the right answer. That should be the right answer, correct? So you're right. You look at the earned value, means, it is EAC, means the estimated completion, what will cost to finish the project, ETC, the cost to complete it. So that is the answer. And this also you're right. It is minus 50 is the right answer. Factor in this calculation. Since you know this formula, you are able to answer in about 10 seconds, am I right? Correct.
Yep.
So this is how the questions will be there in the examination. What is CV, what is EAC, what is SV or CPI or SPI, like that they will ask you, and it will be straightforward and you will be able to answer the question. Only the EAC based questions sometimes in the scenario, which one to take, that might only little confusing, but if you know the concepts well, when to use the BAC by CPA formula or when to use the other three, you will be able to answer those questions. Now here, during which management process group or budget forecasts are created? Is it doing monitoring and controlling? Is it planning or the initiating or the executing? Budget forecasts are created.
B, planning.
Budget forecasts. Are you sure? Planning.
It's either that or A, because there is no C or E.
It cannot be either C or A. Okay. When do you, for example, you do the forecast, only after analyzing you do the various analysis, I'm right, that's where, control the cost, that's where you do that, I'm right.
Okay, yeah, it would be the controlling part of it.
Yeah, let's look at it in fact. Which type of cost is a team training? Is it a direct cost or is it indirect cost or the fixed cost? Team training cost.
That would be an indirect cost.
Indirect cost, okay. And the project setup cost are an example of what? Is it a variable cost or a fixed cost, overhead cost, or opportunity cost? Project setup cost. Project setup cost. You said fixed cost, is that you said?
Yeah, that would be a fixed cost.
Okay. Let's look at it. The quality efforts of the project have gone through some changes during the first 4 months of project work. Two processes in particular have undergone extensive change. The customer is happy with the work to date, but has heard that the competition is working on a similar product. The team has been asked to analyze and create options for the customer. Value analysis is performed to get more value from the cost, or a management to buy into the project, or the team to buy into the project, or a less costly of doing the same work. You need to apply your management skills for this answer actually. What is the best answer?
First, I would say more value for the cost analysis, from the cost analysis.
So the B and C can rule out, am I right? The team to buy into the project may not be the right answer, or the management to buy into the project may not be the right answer. The team has been asked to analyze and create options for the customer. If you revisit the question once again, the quality efforts on the project have gone through some changes during the first 4 months of the project work. two processes in particular have undergone extensive change. The customer is happy with the workout date, but this is the catch point, has heard that the competition is working on a similar product. So that's the catch actually, in fact. More value from the cost analysis and a less costly way of doing the same work. Let's look at it, then probably we can debate on that, okay? So the first answer, you are right, it's a control cost is always, the budget forecast are created during the monitoring and controlling process, because the controlling is when you do the various analysis. In fact, am I right? You compare with the planned versus actual, and that's where you can do this. If you want to revisit that control chart just to understand a little more detail, see here, control cost, you do the earned value analysis and you also do the various analysis. In fact, this is what you do, and when you do the cost forecast, this is the output, correct? So that's the reason, in fact, you do the estimation or the future cost from the control cost. Whereas in the other process, when you do, you don't have this. In fact, you don't do any cost baseline only, you'll fix it. Project funding requirement, you fix it. And your estimation cost, of course, again, you don't do that. Here is only the estimation you do, but you use the technique, but you don't do the variance analysis here, in fact, correct? You're not looking at. So in the monitoring and controlling only, you do the work performance information and the cost forecast. So it's important to remember this. So which type of cost is team training? Again, it is actually, it is a direct cost. Team training is always under a direct cost. Then setup costs do not change. So it is actually the fixed cost. You are absolutely right. You said congratulations for that. And here the last one is a bit tricky question. Value analysis seeks to decrease the cost while maintaining the same scope, because of this reason that the customer has heard that competition is working on a similar product. So what he looks at the value analysis is to get the less costly way of doing the same work, so that he can be competitive in the market. That is the rationale for selecting this. This also closely more value from the cost analysis, but what exactly you need to do is that a less costly way of doing the same work, in fact, so that he can be very competitive in the marketplace. That is the rationale for that answer.
Okay.
Got it, right? Right. Okay. So that concludes the cost management. Any questions so far on this?
No. I just like the other sections, I've got to make sure that I read through the book and I'm able to.
Yeah. That's very important.
Exactly where. Right.
Yeah. These formulas are pretty straightforward. Only thing is, I would humbly request you to practice it and memorize it. There is no other go into this, in fact, because unless you memorize this formula, I don't expect you to memorize any other things. But these formulas and these few things, you need to mug it up or memorize it. In fact, from the examination perspective, it is very important. Of course, in your project management day-to-day function, then probably when you start interacting with your other functional heads, for example, with your finance head with these formulas, you will try to remember those things. Like that, for example, when you talk to your IT head or other things, other concepts, HR, for example, when you're interacting with your HR person, you start interacting about the HR management. So it's easy to remember those concepts. But from the examination perspective, you need to mug it up. You need to memorize it. And you should have this formula in your fingertips. As I told you, if you can write down this formula in about 5 to 6 minutes, that will be a great thing, in fact. so that you can answer these 15 to 18 or 20 questions, depending upon your luck. Sometimes you may get even around 20 questions, sometimes at least around 15, 16 questions will be there on the formula-based questions. Because out of 200 questions, if you can answer about 10 questions or 20 questions in about less than 15 seconds or 20 seconds, see the amount of time you utilize, you can save to answer some of the scenario or some little confusing questions like situation based or other questions. Yeah, that's right. Any thoughts on this so far? Today's sessions, we completed schedule, we completed the cost.
No, I think I'm good.
Pretty interesting, am I right? That's right, yeah.
Oh yeah, I like it.
Yeah, you like it,
I like it.
Perhaps. Yeah, that's right. So I would request you, for example, today after the session, tomorrow onwards, whenever you get some time, start practicing this formula. So on Saturday, and we meet again next Saturday, probably you should be able to tell me that I could write in about 5 to 7 minutes time. That will be a great thing.
Sure.
Yeah, that's right. That's right. And when are you planning to file the application for the examination? Send the application, Steve.
I'd like to get my application done in the next week or two.
Oh, very good, great.
And then,
that's great. Yeah.
And take it as soon as I can. While it's still fresh.
Yeah, that's right. Absolutely. Now, once you, since I know I could make out that you're pretty comfortable with these skills and the management, and also you're pretty comfortable with these formulas. So I think handling around 78 mock test and scoring at least 75%, you keep that as a benchmark. 75% you should score first attempt in those mock tests. If you do it consecutively for about 4 to 5 mock tests, I think you are ready to take the examination. So that's you can easily take, crack the exam. I'm sure about it. Okay.
Good.
Yeah, great. So this one, just you try to do in the break period. No, probably you can take if you want extra 15 minutes, or so that when we come back, we will address this question also. So that I want, I will know that how exactly is there any issues to solve this problem. That's right.
Sure.
Okay. So shall we have a break now? If you look at it, Steve, just to revisit. In case if you have any confusion, let's clarify that if required. You see here it says that some teams are ahead of schedule and others are falling behind. That means you have cost overruns in some areas, but you have saved costs in others. So probably you can presume that it means it is going as per the budget here, in fact. Okay. So if so, the formula that probably you need to use here is BAC divided by CPI, because it's going as per the correct. You are done, no? So you will get BAC divided by CPI. You will get EAC. That number you must be getting it correct.
4,800,000.
Yeah. So that's what you get. This is the BAC 4200.330 3 zeros and divided by 0.875 you get. Now the ETC formula, which is the formula you're using for ETC? ETC is what? And you have the actual cost spent here. You have spent, this is the actual cost, 1650 followed by 3+0, you have this formula in fact. So the formula for ETC here, you can take the formula. EAC minus AC is your ETC formula, correct? So you will get this EAC, you minus, this is the actual formula, 1650,000. So that will give you your ETC. Once you have this ETC, then you need to have the VAC, variate as completion. For that, you will be using the formula BAC minus EAC, correct? So BAC minus EAC you'd give to VAC. So then you can arrive at whether it is the project will be over budget or project will be within the budget. That's the approach you need to take.
Hello. I've dropped off for a minute.
Hello.
I don't know what happened. I dropped off. But I'm back.
Yeah, sure.
Okay. The EAC, I got 4,800,000.
Yeah.
The ETC, the estimate to complete, I got 3,150,000.
Yeah. You've taken that EAC minus EAC, correct? Okay. EAC minus EAC.
Yep.
Yeah. And VAC is variant at completion.
1,650,000.
It's minus,
no,
right?
Wait. Yeah.
Yeah. So VAC formula is what? EAC minus.
No. I'm sorry.
What is the formula?
BAC would be the EAC is the BAC minus the EAC.
Yeah. Correct.
So yeah, minus 600,000.
So the project will be under the budget, am I right? Or over the budget? It is over the budget.
It's over the budget.
Correct. Okay. So how much will be the over the budget? You have the number minus 600,000. What's the value?
600,000.
Yeah, that's so. That is the inference you need to give it back. So in the examination, probably they will not ask you to do so many calculations. Probably one or two variants they will give you. In fact, probably at best they may ask you that what is the EAC for that, or what is the VAC for this? The project will be over budget or under budget, like that. Some options will be there. That's great. Is it fine? You got it correctly, I think.
Yeah, no, I think I'm good with it. I understand the concept of it.
Excellent. So only thing is that, as you said, you need to practice a number of questions like this, and you get this opportunity when you do it for your mock test. Okay, when you do the mock test, you will have multiple questions like this, and you will also get the answer immediately at the end of the test. In fact, so you know whether you answered correctly or wrongly. In case if done a mistake, you can correct it and so answer it again in the following test. In fact.
Okay.
So, any questions so far, Steve?
No.
Perfect. Okay, that's great. So both this knowledge area, I think schedule and cost, I think you have fair amount of knowledge now. I'm sure about it. That's right. Great. So if you don't have any question, we'll move on to the next knowledge area, quality management. Okay. In your company, you have a quality person, right? He's heading the quality control department, or what capacity is working?
Each of the projects is required to have a quality control manager.
Oh, great. Okay.
On site.
They're dedicated to the projects, totally dedicated.
Yeah.
Oh, okay, great. Mm-hmm. In fact, they formulate the quality policies and procedures, or you have a corporate quality policies you have?
We've pretty much got a corporate quality control management plan.
Oh, okay. You follow that.
That is a template, but it's adjusted according to each individual project.
Projects. So the metrics. Okay, the metrics and KPIs according to the project, you change it. Am I right? That's what you do. Interesting.
Yes. Yeah.
Oh, that's and your quality control manager handles that. That's great.
Yeah, jointly. Myself, I get involved in it too.
You are involved in that. Okay, that's right.
Yes.
Yeah, naturally, but since you are heading the project, everything has to be under your control and with your knowledge only. That's great. Have you gone any quality training, quality management training anytime? No.
What's that?
Any quality training you have undertaken? Have quality management training?
Yeah. Yes, I have.
Yeah.
Actually, there's a 3-day certificate program that we have to get when we do Army Corps of Engineers projects.
Oh,
and
very
I've
nice.
carried one of those for the last 15 years or
so. Okay.
But it's just a pretty rudimentary certificate.
Yeah, correct.
Until you start getting into quality control management, some of the concepts can be pretty obtuse and difficult to understand. So
is it? Oh, it's so strict and so it's like that, is it? Oh, okay.
But I've been a quality control manager on quite a few projects.
Oh, excellent, great. What are the new challenges you have in quality areas?
Probably subject matter specialists, getting them on board and understanding what subject matter is, depending on the complexity of the project. Making sure that we've got the right people to certify and do the testing oversight for those items. In hospitals, there's a lot of med gas, stuff like that. And that, some of the hospital stuff tends to be a little bit more difficult. Air balance, commissioning, that tends to be a problem when you get into hospital work. Not a problem, but it becomes laborious. It becomes a big part of quality control management, and it ends up affecting cost, scheduling, pretty much all aspects of project management. You still with me? Hello?
Can you hear me? Yeah. Hello?
I can hear you now.
Yeah. Okay. I think some network issues, I think.
Yeah, I can hear you fine.
Okay, great.
I don't know if you've moved anything on the computer yet.
Yeah, that's right. Okay. 1 second. Let me open the that's right. Can you see the screen or?
Right now, I see lesson 8.
Yeah, lesson 8. Okay, this is the one. Okay, you can see that, no? Okay, that's right.
Yeah.
Yeah. Okay, great. So coming to the quality management, there are, if you look at here, there are basically we are talking about 3 processes. One is the plan quality, manage quality, and control quality. You are a quality expert, so of course, so probably it will be pretty easy for you to understand these concepts. In fact, actually, so in fact, I can learn from you many of these things. In fact, okay.
Oh.
Yeah, the screen is coming. Is no problem, no issues. Yeah.
Right now it's still on lesson 8.
Oh, I see. Okay, one second. Let's see. Why this is not coming? One second. There's some technical issue. Yeah. I hope it's fine now. That's right. So there are three processes in quality management. One is your plan quality, manage quality, and control quality. These are the three processes. And from the 10-digit number, if you look at 7 is the project integration management, 6 processes in scope, 6 processes in schedule, and 4 processes here you have in cost, and 3 processes. So 7, 6, 6, 4. We are getting to the number 3 processes in project quality management. So just to remind that 10-digit number and 3 processes in quality management. So the first thing that we look at is the direct and manage project work. If you look at it here, of course, previously also we visited this slide. You look at the deliverables, and it goes through the control quality. And once it goes through the control quality, it will become verified deliverables. And verified deliverables goes through the validate scope, and it will become the accepted deliverables. And that's where the close project or phase. If for example, if it is not approved here, in fact, if you look at it, if it is not accepted deliverables from this process, again, it will go back to the change request process and performance integrated change control. And here it will become the approved change request. And again, it will go back to the direct and manage work. So this is the overlapping, or this is the iterative process that happens during the project environment. This is a very important slide just to understand. This is the monitoring and control execution process. This is the monitoring and control. This is the control scope here, in fact, validate scope. And it goes through that, and it will become the accepted deliverables by the customer and the final product. This is the sequence. I'm sure in your projects also you must be following the same setup. Am I right? If you put it the flow chart, I think this is how it flows in fact in your organization. Am I right, Steve? You agree with me?
Actually, I'm trying to get the screen back. I dropped off now.
Oh, is it? Okay, okay. I'll wait for a second. No problem. Yeah, just. Once you got it, yeah, just tell me so that we can.
Okay. Okay, looks like it popped back up.
Yeah, you got it in front? Okay, that's right. Okay.
Yeah.
So this is the process. This is the flow chart for example. The direct and managed project work is the execution process that you do. Then once it goes through that, the deliverables, it goes through the control quality, is a monitoring and control process. Then it goes to the validate scope, one more scope, the verified deliverables. After going through that validate scope, it will become accepted deliverables, and then you close the project. During the validation, in case if it is not accepted, then it goes back to the change request, and it will go through the perform integrated change control system, and it will become the approved change request, and that again will go back to the direct and managed project work. This is the overlapping, or this is the flow chart you can have for the quality thing. And the close project phase, as we discussed yesterday, it will become the final product of the service or result or the transition to the customer. Okay. So the first process, project quality management, is a planned. There are three things here. If you look at it here, project quality management includes the process for incorporating the organization quality policy. You were just mentioning that you have a corporate policy. Again, that is fine-tuned according to the project requirement in terms of KPIs, in terms of metrics, according to a project requirement. Again, it is get fine-tuned. So regarding the planning, managing, and controlling the project and product quality requirements in order to meet the stakeholders' objectives. That is the most important thing. And quality management also supports the continuous process improvement activity. In fact. So there are three process areas here, three processes. One is the plan quality management, manage quality, and control quality. Let's go through one by one. The plan quality management is a process concerned with the quality that work needs to be had. Manage quality is concerned with the manage the quality processes throughout the project. During manage quality process, quality requirements identified during the plan quality management process are done. What is important to remember is this is a PDCA, Plan, Do, Check, Act. You must have heard about Edward Deming since you are from the quality circle. I think that name is very familiar to you. Edward Deming, that plan, do, check, act. This is even our the PMP principle, the 5 process groups. Also, if you look at it, plan, execute, monitor, control, monitoring and control, and then close the project. Am I right? This is almost the similar way you do the planning. Then you do it, then you check it, and you act on that. The similar, almost same thing. The plan, do, check, act in far from Edward Deming. So are met by the project. Control quality is concerned with the comparing the work results with the quality requirements to ensure the result is acceptable. This is the important aspect in the control quality. So we also discussed about verification and validation. I hope yesterday, you remember that, Mr. Steve, verification and validation?
Yes.
Yeah. So just to recap, can I just, what is verification and what is validation?
Verification is confirming that you've got the correct things in place, and validation is confirming that you've got the right guidelines.
Yeah, validation is whether those specifications are meeting the customer satisfaction. That is, you validate, according to that. Verification is whether what you have done meets the certain specifications. And the validation is those specification meets the customer's requirement. That is, you are validating that according to the customer's satisfaction. That's one important things to understand in this quality circle. These are the 4 important things. Of course, this is a customer satisfaction is the conformance to requirements and fitness for use. And you know the difference between a grade and quality, Steve? Grade and quality?
Yeah, great. I mean, yeah. Grade is an assessment of the level of quality in a product.
Okay. Assessment of, can you just come back on that? Assessment of,
I'm sorry, what was that?
Can you just repeat what you said, if you don't mind? That's a grade and quality.
A grade is a level of quality in an item. It can be
a low grade. Yeah, it can be a low grade or a high grade. In fact, am I right? It's like that.
Right. It's but generally measured on scale.
Yeah, you're absolutely right. The quality cannot be a low quality or a high quality. In fact, a grade can be of different characteristics. Correct? Am I right? You take eggs. In fact, in the market, you see the eggs. The functional property of all eggs. You can make a boiled egg or a scrambled egg or the omelette. You can make. but it may have different grades of eggs. It can be a low quality egg or a high quality egg, in fact, am I right? But
Right.
it based on the technical characteristics. Some of them will be low grade, some of them will be high grade. But quality cannot be a low quality or a high quality. In fact, quality has to meet certain specifications. The customer satisfaction, that's very important. So you can accept a low grade product, but you cannot accept a low quality product. You agree with me, correct? Am I right?
Yes, sure.
So that's very important. Again, in the examination, there might be a question on this. Low grade or high grade or low quality or high quality, which is acceptable. You can accept a low quality or a high grade product, low grade or high product, but you cannot accept a low quality or a high product. It's like that. So that's the class. So grade is basically on the classification based on the technical characteristics. Even a stainless steel tube you take, it may have a low grade or a high grade, in fact. But quality, it will meet the functional requirement, but may have a different grades. But quality has to always meet the customer satisfaction, customer requirement. That's important. On the precision and accuracy, I'm sure you must be very familiar with this also. Accuracy and precision, in fact. Accuracy is the correctness being done to the desired value, being close to the desired value. Just to give an example, I am, let's say, I weigh around 90, I weigh around 90 kilos, in fact, okay, it's about 200 odd pounds. So let's say that when I stand in a weighing mission, if the results is showing me that 89.5 or 89.8, then it is showing the accurate, in fact. That means it is close to the real value of that. Whereas the precision, it is a granularity of measurement, how fine the outcome. Here, for example, in the bullseye, this is the accuracy we're talking about. Precision could be, for example, all the 4 arrows comes here, it can be precise, in fact. So a precision need not be accurate, but at the same time, the precision, the consistency, granularity of measurement, how fine the outcome can be measured. This is the difference between accuracy and precision. Again, I'm sure you have got far more experience to understand these things. I hope it's clear, in fact, the customer satisfaction.
It is, sure.
Yeah, great. Thanks. So in the quality management concepts, these are the total quality management and integrated management philosophy around the quality of the continuous improvement. This is the TQM. I think most of them are Japanese concepts, am I right? Since you are from the quality, you understand, am I right? Most of these quality concepts are inherited from Japan, probably, right? Because they are the one, they started working on the quality during 70s and 80s. They gave so much of importance on the quality management. So I still remember when I was in Chennai, in fact, there are a lot of companies, executives, managers used to get trained from Japanese firms on the quality management, in fact, because they were pioneers in the quality management. Am I right, Steve? You agree with me on that?
Yeah. Mm-hmm.
Yeah, that's right. Okay.
I'm not familiar with Kaizen or Deming.
Deming is the Plan, Do, Check Act, Check Act. I just explained you that, this is the concept. First you plan, you do it, then check and act. In fact, this is the quality they follow always, in fact. This is a framework of process and improvement. Kaizen is a change for better, in fact. That looks for small and continuous improvement. That means they don't look at that, you improve the quality only at the end. It's not like that. You make incremental changes, incremental improvements, in fact. Philosophy that looks small and continuous improvements. If you take care of that, then at the end, the total quality objective would have achieved, in fact. That is what the Kaizen, the Kanban is a just-in-time concept. There's a one you started. Particularly inventory management, the Kanban principles are used very widely, particularly the manufacturing and the inventory management. That means whenever you require the material, you get it and right on time. Earlier, what used to happen, we used to stock up the material, raw materials for months together. In fact, it used to be available always in our storing warehouse. Then whenever you want the manufacturing, you take that. But the Kanban concept, suppose today you are taking up the production, now the availability of certain material is so good. You want to start your production today, just the previous day you get those products on your manufacturing line. That is more than enough. That is just in concept. That really helped to reduce the cost of inventory management, because earlier the companies used to spend a lot of money on the inventory. In fact, you need to have the raw material inventory, then you'll have the, for example, finished goods inventory and all those things. But just in time concept, it came today. You want to start something, you get it previous day or just 2 days before, so that will reduce your inventory cost. These are all some of the, and also you will get the fresh stocks. The quality will be good. Sometimes, the older the product, the quality gets deteriorated. So you follow the Kanban concept. These are all some of the quality management concepts that today, it's prevailing in the industry.
Okay. Okay.
Yeah. Deming cycle is again in the plan, do, check, act. It's almost similar to our 5 process groups of you plan, you execute, monitor, control, and you close the project. It's like that. Some of these concepts. Again, it is applicable in not necessarily in all the industry and all those things, but these are all some of the basic concepts that in the quality management area it's being followed very widely nowadays. So the first one is the plan quality management. Here the inputs we are talking about the project charter. Number of times we have discussed about it. Then your project management plan. The 3 important management plans here. You require your requirement management plan, risk management plan, and stakeholders engagement plan, and the scope baseline. These are all the certain key important inputs. Then you will have your documents like assumption log, your requirement documentation, then requirement traceability metrics, and the stakeholder register. These are all some of the key important inputs for this process. Then tools and techniques. Here we talk about data gathering. We discussed yesterday about the benchmarking. Benchmarking is you benchmark your process, benchmark your product to the best industry thing. Then brainstorming, again, we discussed is collecting the ideas. In fact, probably you brainstorm with them and get this thing. Interviews is a one-to-one. Then data analysis, cost benefit analysis. This is also very important to understand because on a cost benefit analysis, let's say your Tesla car, today it costs around $100,000, the best Tesla car. Am I right, Steve?
Right.
Yeah. Now, on $100,000 car, for example, the company must be spending at least around $20,000 on the quality itself. Am I right? Some percentage or very high percentage of spent on the quality. In fact, that's the reason they are able to sell at that premium price. Now, let's understand that for a 20,000, suppose if the MRP, the maximum price you can sell a car at $20,000, do you think the company can spend so much on quality? Not, am I right? Proportionately, it will get reduced, isn't it? So it is a cost benefit analysis. That means at what price you sell your product and how much money you can spend on your quality cost, in fact. So the always, this cost benefit analysis is done. It is directly, proportional to the maximum price the company or the revenue the company generates, in fact. Based on that, you do the analysis. Otherwise, there is no point in spending too much of money on the quality alone, and you are not able to generate that incremental revenue for that, in fact. So that's a cost benefit analysis. That is, I'm spending so much money on the cost and the quality, and this is the amount that I'm going to generate. You do that. The cost of quality in the following slide, I will explain to you after 2 slides. What of cost of quality, what quality involves is very important from the examination perspective also. Then let me go through that. Yeah, if you see here, cost of quality, there are 2 things. One is the cost of conformance and cost of non-conformance. What are the cost of conformance? Your preventive cost. Preventive cost is, it is basically to build a quality product. How will you build a quality product? You spend training, you give a training to your people, you will have proper equipments, You will have a document process, the right documents. You will have the good equipments, latest equipments, and time to do it right. In fact, when exactly has to be done, you will do it. In fact, these are all the preventive cost. In fact, and what are the appraisal cost? Appraisal cost is the assessing the quality of the product. That means the testing, the money you spend on testing. Destructive testing loss, in fact, is there any loss, for the destruction? In fact, that also it's an appraisal cost. Then the inspections, yesterday we were discussing about, you go and inspect. These are all the appraisal cost, in fact. So the training and inspection and testing, these are all the preventive cost, in fact. Now, what are cost of non-conformance? Non-conformance, there are two things. One is the internal failure cost, and another one is the external failure cost. You see, the internal failure cost is within your premises, within your factory premises or a manufacturing or your working environment, you found by the internal team, in fact. So when you find it, what you do, you normally you rework on that, you scrap it, you take a cost, you take a call on that. External failure cost is when it goes out of your factory premises, when it goes out to the customer, when they find, it will become the liabilities, warranty work, and the lost business. So these are the two important, these are the cost of quality. One is the cost of conformance and cost of non-conformance. Can you recollect recently, particularly in US, the external failure cost, it created the problems? One or two instances, can you recollect? Hello?
I'm sorry, there you are.
Are you with me?
Cost. Yeah. Cost of non-conformance.
Yeah.
Yeah, we've had instances on projects where we've had to take stuff out and do rework. We've had to do warranty work. We haven't had any liability issues.
You didn't have any liability. Okay.
Right. And preventative cost, most of our testing is we don't lose much material.
Oh, good, great.
We don't do. Okay. We really don't do any destructive testing. Most of our testing is in place and non-destructive in nature.
Non-destructive.
But there is the cost of testing and the laboratory work that goes along with it.
Okay. Great, in fact. So this external failure cost, I remember a few years back when I was traveling to US, these emission test failure, you must have heard about that. Volkswagen and few other cars, it came to the market. They had a lot of issues on the emissions. You remember that emission test?
Volkswagen.
Yeah, Volkswagen. They had to recall 10,000s of cars and thousands of cars back to the from the market, and the company lost reputation. Am I right? You remember?
Yes. Yeah.
They're all the external failure costs, in fact. Even a few other cars also, they got into this problem, I think, including General Motors, some of the brands. I think they also had, or I'm not sure about that. But Volkswagen just definitely, yes, in fact, they had a lot of issues. Even in our company, once it so happened that, the product went to the market, probably by oversight of the quality control manager, in fact, and we had to recall a lot of stocks from the market, and we had to destroy it actually once. So it will sometimes, if you don't act fast, it can affect your company, their reputation, and lost business also. Am I right? I'm sure Volkswagen would have lost a good amount of business because of that issue. Correct? Am I right?
Oh yeah, absolutely. They did, sure.
Yeah, that's right. So these are all the external failure cost, that is basically money spent during and after the project because of failures, money spent during the project and avoid failures, in fact. So it's a pretty straightforward. The cost of quality comes under two heads: cost of conformance and cost of non-conformance, in fact. I'm sure you should be able to answer this pretty straightforward this time. So we discussed about the cost benefit analysis. I told you that how much money you can spend on the quality, in fact. So you need to manage that cost-benefit analysis. Then you have the decision making, like multi-criteria decision analysis. You look at the various scenarios and you look at it. Then data representation, we discussed about the flow charts. Of course, in the quality, we'll discuss about that. The logical data model, in fact, where the logic or the rationale is put into that. The metrics diagrams and the mind mapping. Yesterday, I explained to you about the mind mapping. And the test and inspection planning. This is also very important, particularly for the stainless steel, the products and the construction material. Am I right? I think in the construction industry, they do this test and inspection planning. Am I right? Over the years, it gets deteriorated, and a timely check of that is very important. It so happened in Mumbai about 2-3 months back, there was a major disaster happened because one of the railway bridge, which was, for the customers to, move around, and that bridge collapsed. In fact, about more than 100 people died because at a time, there will be more than 15 to 20,000 people will be walking on the bridge, and that bridge was there for so many years, and probably I still remember the test and inspection planning. They gave a report, but unfortunately that report was corrupted in the sense, somebody must have bribed it and they gave a false report, and probably an action was not taken, and because of that there was a major eventuality. So particularly in the construction and the bridges and the very stainless steel material or the concretes are used, the regular the test and inspection planning is very critical and important as a quality thing. I'm sure you'll agree with me on that. That's right.
Yeah, absolutely. Absolutely.
Yeah, that's right. That's right. So these are all some of the tools and techniques that you have. Then what output you get is the quality management plan and the quality metrics. As we discussed, in fact, I'm sure that based on the required project, these metrics and KPIs are determined according to the requirement of the project. So then you will get the project management plan updates and the risk management plan, your scope baseline, all gets updated, including your lessons learned register, requirement traceability matrix, and risk. If you look at it, this lessons learned register, in most of the process, it gets updated because basically it will become a future reference for the projects, in fact. So the PMI, the project management, gives so much of importance from the lessons we learn from each of the product. So that's one of the reasons, it's one of the key output in many processes that it gets updated in. So plan quality management is basically identifying the quality requirements or standards for the product and its deliverables. In fact, this comes under the planning process. At what stage you do the planning, Steve, for the quality in your projects? You sit with your project, the quality manager. At what stage you'll be doing it? In the beginning itself, or it's a regular, periodically you'll do?
Generally, I'm involved in the beginning.
Beginning, okay.
Yeah. Generally involved in the beginning to develop the quality control management plan.
Excellent.
And then I'm certainly there during the closeout process.
Yeah.
Where
you compare with that plan and actuals.
Right, making sure that the plan has been followed, and that we've got all the closeout information. Those are the biggest areas of my work. The day-to-day management after it's developed is more on the shoulders of the on-site quality control manager.
Oh, okay. Okay. And you have an audit team to check the quality regularly? You have an internal audit team or external audit team?
An internal audit team.
Okay. They do the regular checkings and things.
Yeah, and then also there's an external auditing, which is generally we refer to it as the QA, quality assurance.
Quality assurance department. Okay.
It's generally a third party employed by the owner.
Okay. That's right. And particularly, they are all recognized by the government, am I right? Because they need to approve those things. Correct.
Right.
Yeah. That's how it's being done, I think. Great. So the test and inspection planning, during the planning phase, the project PM and the project team determine how to test or inspect the project, deliverable or service to meet the stakeholders' needs. Three important things, here, for example, the alpha and beta test for software projects, strengthened test for the construction projects, which I'm just telling, and for the inspection, the manufacturing and field test, non-destructive test for engineering, in fact. I'm sure you are familiar with all these three things, alpha and beta test, and strength test, inspection for manufacturing. It's very important. So the quality metrics, again, of course, they specifically describe the product attribute and how the quality process will vary. Some examples of quality metrics include the percentage of tasks completed on time, cost performance measured by the CPI. This is also a quality metrics. In fact, when you do the cost benefit analysis, it's also very important. In fact, and third thing is the failure rate, the number of defects identified per day, total downtime per month. These are all some of the metrics that we normally, in the quality concepts, you follow. I still remember ours was basically an FMCG company, and we had a factory. So the manufacturing downtime, in fact, we used to analyze almost on a monthly basis. During our ISO meetings, we had our company was on the ISO standards we used to maintain. So the downtime per month also we used to analyze. But then we used to arrive at that, that used to be some quality issues if the downtime is very, very high during the month. That means, there are some problem. That is the reason, the production has not come up to that extent, in fact. So errors found by two customer satisfaction scores. These are all the various metrics that we have in the quality, in fact. I'm sure in your company also, you must be having some of these metrics. Your failure rate or the number of defects identified per day. You will have it according to your project requirement. You can customize it, am I right? Those metrics.
Yeah, that's correct. Right.
That's right. Okay, great. So once you plan the quality, then you need to manage the quality. That's also an equally important process. So here, managing the quality, the key benefits of this process are that it increases the probability of meeting the quality objectives, as well as identifying the ineffective processes and causes of poor quality. That's how you manage. You try to find out what's working out well and what are the issues and how you can minimize it, in fact. The data and results from the control quality process to reflect the overall quality status. Here the inputs we are talking about, basically the quality management plan is one of the important input, which is an output of the previous process. Then you have the lessons learned register and the quality control measurements and the quality matrix, which we just visited in the previous slide. And you will also have the risk report and the OPA, or some of the common inputs. Here in managing quality, you have data gathering, the checklist, and that also you will have a checklist from what all you need to check, in fact, in quality process. Then you look at the alternative analysis and the document analysis, various documents you have, all those things, the process you do. Then the process analysis, whether you're following the right process, in fact, and so that to achieve the required objective of the quality. You also look at the root cause analysis. If there are issues, in fact, then you try to find out why it is happening, what are the root causes for that. You look at that. Then the decision making, you will look at the multi-criteria decision analysis, the data representation, affinity diagram, which I showed you that. Cause and effect diagrams, again, it is, of course, we'll be doing one of the 7 basic quality of the project, that Ishikawa diagram or a cause and effect diagram. Then the flow charts, histograms, matrix diagram, and scatter diagram. These are all some of the data representation. We'll be visiting that. These are also part of the quality tools. I'm sure you must be familiar with most of these things. Am I right, Steve? Affinity, the flow charts or the histograms or the matrix diagrams, scatter diagrams. You are familiar of these, some of these concepts?
Oh, yeah, sure.
Yeah, anyhow, these are all some of the quality tools also we'll discuss in detail. Design for X is the design for excellence. That means you develop such a product that that whatever you do, that's the best, that's the fit to use. Could be one of the design for excellence. Reduce the cost and improve the the value of the product. That could be another design for excellence. So that means you are designing a product to that extent, it is an excellent in all aspects. Again, it is a very, very big subject, a design for excellence. But in quality, from the quality perspective, if you look at it, you design a product in such a way that the consumer or the user or get into that without any issues. In what happens many times, the compatibility will be a major issue. In fact, I'm sure you will agree with me that software, you see some of the software, it works in, let's say in Windows 10, may not work in iPod or and other things. Am I right? You agree with me, am I right?
Mm-hmm.
It is designed for a particular use. But here we are looking at, design for multi-purpose use, in fact, multivariate purpose. So that's what you all keep those factors in mind when you do the design for excellence. Then problem solving is nothing but you analyze, you first define the problem, then you make a root cause analysis of the problem, then work out the best solution for that and implement the best solution. Various options you look at it and implement the best solution for that. These are all some of the tools and techniques that we have. Then we'll discuss in detail about some of the 7 basic quality tools in the following slide so that we can understand much better those things. So what the output here you get the quality reports. Again, with these quality reports, you need to send to the right people, probably your sponsor, your quality control manager. Then the test and evaluation documents is also very important and very critical, particularly in the construction industry, if you are there, or a few other industries. Then change request, the project management plan, and all these things gets updated here. Quality management plan, scope baseline, schedule baseline, cost baseline, all are gets updated here, in fact, because once it passes through these tools and techniques. The project managed quality sometimes is also called quality assurance. You are just mentioning about you have a QA department, am I right? Correct? Quality assurance department. Yeah. Although managed quality, sorry.
Generally, that's part of the owner. That's generally a third party outside of what we do, which is quality assurance.
Because you want to have get an independent opinion, am I right? So it will not be any biased, correct? Yeah. So they'll look at it from a totally independent point of view. That's right.
Correct.
So many organizations, even though you have your own quality department, but still, you invite outside agencies to come and check. So that's very important, actually. That will also help you for your prevention of quality before going to your customer. You are making sure that nothing goes wrong. In fact, correct. So the cost of conformance, it's like that. That's very important.
Sure. Yep.
So although the managed quality has a broader definition than quality assurance, it is used to non-project work. In project management, the focus of quality assurance is on the process used in the project. So what's important to remember here is the quality assurance is about using the project processes effectively. So first thing what they do is whether are you following the right process. That's the quality assurance, or that's what the audit team they say that. Am I right? Most of the time it's not that you have come out with the right product, but first question they ask is, are you following the right process which has been defined in your quality management policy? Because there itself, they will find so many mistakes sometimes, because you are not following the quality framework, you're not following the right procedure, you are getting into the problems. Most of the time it happens like that. So that is what the quality assurance does. Whether the process that has been planned, is it being implemented effectively? It involves flowing and meeting the standards to assure stakeholders that the final product will meet the needs, expectation, and requirements. So the managed quality includes all the quality assurance activity and also concerned with the product design and aspects and process improvements. So the managed quality work will fall under the circumstance of conformance work category in the cost of quality framework. Cost of conformance it will come out. So what are the key important documents here? We look at it. One is the lessons learned register. Lessons learned earlier in the project with regard to the managing quality can be applied to later phases of the project to improve the efficiency and effectiveness, in fact. Because it is a continuous process, the total quality management or continuous improvement plan, that's what we discussed in the one of the slides. You remember that here, the Kaizen in our philosophy that small and continuous improvements in process. So what lessons we learn here, probably even on the later phases of the quality that needs to be applied. Quality control measurements here, quality control measure can also compare the processes used to create a measurements and validate actual measurements to determine the level of correctness. Then quality metrics is metrics that are verified as part of the control quality process. The managed quality process uses these quality metrics as a basis for the development of test scenarios for the project that deliverable as a basis of improvement initiatives. In fact, the quality metrics also helps to improve many of these things. Of course, the risk report gets generated by using the managed quality process to identify the sources of overall project risk and most important drivers of overall risk exposure that can impact the quality objectives of the project. Now, here comes the most important from the quality perspective. I'm sure you must be very familiar with some of these quality tools. Managed quality process leverages a number of tools to assess the quality control. Most of the tools are based on the leaders like Edward Deming, this PDCA, which I was talking to you, plan, do, check, and act. In fact, he's the one is the founder or the inventor of that concept. In fact, Edward Deming. These tools can be used effectively by the majority of the workers to manage and control quality, in fact. One is the control charts, scatter diagram, check sheets, Pareto diagram, histogram, flow charts, and cause and effect diagram. These are all the 7 basic quality tools very widely used across the industry in most of the scenarios, in fact. Not all of them might be used, at least few of them are generally used in many companies or many projects environment. Which are the one you use, Mrs. T, the concept or the tools?
Control charts, check sheets.
Control charts use it, okay.
Cause and effect diagrams.
Cause and effect, great. Paretogram you use, that is the 80-20 ratio that the 20% of the problem causes 80% of the, in fact, or 80% of the problems are because of the 20% of the issues. Pareto diagram.
No, I've never used that.
You never used it, okay. Flow chart, you must be using it, I think. Flow chart is a very common one, of course, yes, flow chart. But let's quickly go through one by one so that we'll understand. Cause and effect diagrams. This is the, for example, your cause and effect diagram. This is also called as a Ishikawa diagram. You must be in the insight. Root cause analysis or the cause and effect diagram or the root cause analysis or the Ishikawa diagram. All the 3 names are called for this. Here, for example, you try to understand the product. Let's say, in fact, here is an issue, the product quality not matching the requirements. Okay, this is the issue. So you need to find out what are the causes for this issue. Is it the people? Is it process? Is it equipment? Is it management? Is it environment? Is it the material? It's also called the fishbone analysis, Steve. In fact, you must have heard about that. It's basically in the form of a fish body. So it's also called fishbone analysis or Ishikawa diagram or cause and effect diagram. There are 3 names for this, in fact. So let's say under
Okay.
people, whether is it because the people, workers have got a fatigue? Do they have lack of training, lack of motivation? So what are the reasons for that? In fact, under people, you do that. Then under the process, if it is a process is a problem, is it because of not enough of research and development is happening in this company? Is a non-optional manufacturing methods, in fact, is it being followed? Whether the right process is it in place? In fact, this is what your quality assurance department tries to find out by using this Ishikawa diagram or the root cause analysis. And is it due to equipments? Do you have a low maintenance? Whether the old technology is it being followed? Or improper handling, in fact, of the equipments. If the right skilled people are not there, are they probably not handling those equipments properly? In fact, that also could be the reason. Then material, is it your low quality of the material? Are you using it? Or is it the delay in arrival? Sometimes what happens, in fact, the material is about to come. You are not tested the material and you are straight away put into your online, in fact, or you are straight away put it in your assembly line. That also can create problems, in fact. So that's one of the reason in quality, they say that every raw material or every input material has to be tested, and before it goes to your assembly line, or before it goes to your production line, or before the gas. So this is also a very important thing. Then you will have the bad working conditions, whether the hygiene could be a problem or you don't have all these things. Then the management. Are the management really serious about the quality commitment? So that's one of the reasons, Steve, you must be knowing that in most of the companies, the managing director or the owner of the company takes the quality under his direct control. In our company also, the quality manager, of course, used to directly report to the sponsor or the owner of the company. Of course, ultimately, they are responsible for the project manager heads, but subsequently, the stakeholder, the sponsor also has to have a direct interest on the quality, in fact. In your company, how do they? Of course, they directly reports to you, am I right? Because they work along with you, correct?
Yeah, that's correct.
Yeah,
right.
That's right. But it's also the management commitment towards the policy, but that's also very important, actually. So this is a root cause analysis of, for example, a product quality not matching the requirement. Like similar way, you take any causes in your own company, for example, if you can put an issue and try to analyze it like this, what are the various reasons? I think you'll get a right answer for that. And you will be able to take the corrective measures. If it is an equipment, you can address that. If it is a process, suppose here, process is right, people are right, then equipment could be a problem. You can rule out these two options, then probably you can address this option, in fact. Is it possible to put one of your issues like this and analyze it, Steve? Do you think it's possible?
It's possible to do what?
Yeah, for example, I'm just asking you that any of the quality issues that you are facing in your company, suppose if you have faced it, do you think you can analyze it like this? Is it because of
Yeah,
what?
sure.
I can do
Sure.
that, am I right? That's what common factors? Yeah. Now, what common factors can come here? In fact, for example, these headlines. Can you just highlight one issue and try to put that here? Is it because of people or the process, environment? What options you can put here?
Generally, we see an issue with quality. It's either a material quality,
Material,
low quality
okay.
material.
Oh, okay. This is the issue there.
Okay. The people installing it don't follow the correct procedures.
They don't follow the right process and check it properly and all this,
right.
Correct?
Right.
Okay. Otherwise, your process is in place and your environment is a good environment. Your management must be pretty serious.
Generally,
And
the process, the process, the environment, sometimes equipment, but then it's not. We can generally take management out of it
Okay. Yeah,
because
that's right. Okay.
quality, yeah, quality. We're like I said, we're in charge of quality control, but
Yeah.
the
Okay.
owner has quality assurance. So we've got another level of oversight over top of us. And whenever we're doing government work, quality will never be compromised.
Okay. That's great. So this will help you, this type of analysis can help you to take the corrective measures and address the problem. Actually, this root cause analysis is very widely used across the industry, across even in personal life. We can make use of it. Actually, if something is going wrong, look forward. In fact, what could be the reason why it's not happening? Even I gave this example to some of my friends, and that one of their children is not studying properly. They're not getting the good grade marks. So they put that here and try to put the reasons here. Is he not interested in the subject, or the teaching is not proper here? For example, his friend circle, is there any issue? In fact, then are the parents giving sufficient time? Like that, when you put all those reasons for that, or the causes, you will be able to analyze what exactly the problem and come out of the best solution for that. I'm sure you'll agree with me on that, correct? No?
Sure. Yeah.
Yeah. So this is a pretty useful even in professional life and even in personal life. This type of analysis throws out a lot of things. In fact, yeah. Even in career, for example, sometimes you are not progressing well. You can just try to put that, here. In fact, why are we not progressing well? You try to understand whether we got into some wrong companies, or the interest probably was lacking in that company, or the support I was not getting it. So all those, it will help you to take right corrective measures. This is a pretty useful concept, but in many ways. Okay, so that is the, so there are three names to that. Just to sum up on this, Ishikawa diagram, then root cause analysis, and also called the fishbone analysis. These are three names here. Now, what do you normally call? You call the root cause analysis in your company?
Yeah. Yes. Yeah.
Okay, that's right. That's fine. Great. So the next one is the control charts. This is, I think, you are using it very widely. So here it determines the upper and lower control limits. And just to give an example, I normally give, say, this is, let's say, 16.3 is your mean. So your upper limit is 16.5, 16.6 is your upper limit, and the lower limit is this one. Now here, let's say, in fact, you are very familiar with the burgers, am I right? McDonald's burgers, correct? Am I right?
Sure. Yeah.
Yeah. Just to give that as an example, let us say every McDonald's burger, it takes about 50 seconds to come out from the oven. In fact, if it takes 50 seconds, is the standard process they have set in. So they have an upper limit of, let us say, 70 seconds. And the lower limit of, let's say, 30 seconds, in fact. So that is the upper limit and that is the lower limit. So anything, it comes within this upper limit, 70 seconds, it is under control. The process is controlled, in fact. So 50 seconds, this is the mean. This is the 20 seconds here, 70 seconds, and this is 30 seconds. So anything between this 30 seconds, the process is under control. The moment the burger exceeds more than 70 seconds, it has crosses the upper control limit. That means your process is not under control. In fact. So you need to relook at that process. In fact, consistently it comes. So similar way, if it goes less than 30 seconds, for example, again the process is under, it's not under control. In fact. So the control charts will have an upper control limit and a lower control limit. Based on that, you decide about. One more important thing, even within the control limit, if the 7 consecutive data, let's say, in fact, we said 50 seconds, 70 seconds, within 70 seconds, let us say that you got a consecutive 7 data of 65, 66, 66, 65, like that 7 consecutive data within the upper limit. Also, the process is out of control. In fact, you need to remember this. In fact, 7 consecutive data within the upper limit or within the lower limit, even then there is the process needs to be checked, in fact. Investigate 7 data points concurring in a row either above or below the mean if condition known as a run is identified. This is very important to remember, in fact. So the control charts, you will have an upper limit and a lower limit. If it exceeds the upper limit or lower limit, that means the process is out of control. But even within the upper limit or the lower limit, if the 7 consecutive data are made, then again the process is out of control. In fact, you need to relook at the process. You got it, Steve? This is one important thing in control charts. Correct.
Yep.
How often you use this control chart? Very frequently in your company, in your projects?
We do, but generally, the upper limit is not. I'm trying to think of a control chart that would use, and it would probably be strength. And usually for the lower limit not to be exceeded. And the upper limit is generally not as much of a consideration, but the lower limit is. And I would think that maybe if we were getting into testing any electric, there would be upper and lower limits to it if we were going to be doing any megger testing.
Yeah. Correct.
Any,
right. That's right.
Yeah, characteristics of grounding. We'd be looking for upper and lower limits. That would be a place where we would be using a control chart.
Control charts, yeah. Okay. Again, of course, it depends upon the project and the product that you're trying to do. And again, you customize it and you put your metrics accordingly for what is required for that thing. That's right. This burger example I gave is basically too easy to understand that they have an upper limit and a lower limit. Sometimes, you would have seen that some burgers are overbaked. You can see that black mark. That means it has overheated, in fact. Of course, McDonald's do take such prevention, but there are many other companies I've seen. Some products are, will have some overbaked or underbaked if they don't follow the quality policy strictly. In fact, you can see such products also in the market. That means, the quality standards, they are not maintained. That's right. It's like that. I'm sure you must have also experienced it in the marketplace, am I right? Many times.
Yeah, we have, sure.
Yeah, that's right. So that's about the control charts. I think you got both these clearly now. That's right. The third one is the flow chart. Here it's a SIPOC model. That means supplier, input, process, output, and customer. In fact, here for anything, here, for example, they represent the process and help to analyze where the problem occurs. We are discussing, you were mentioning about sometimes, when you do the root cause analysis, the material could be a problem, right? That's one of the reasons why sometimes you get into quality issues, correct? So here, when the flow chart, you will come to know that who was the supplier, for example, and that material have used in that process, and the output, you have a problem there actually. So immediately you will know that which material supplier has got into this problem, in fact, or brought that problem, in fact. So it's a requirement and feedback loop and requirement and feedback. So you give the input, in fact, here, the process and the output, then you get the back. So the flowcharts are graphical representation that how a show process or a system flows from beginning to end and how the elements can interrelate, in fact. So it's also called as the flowchart is also known as SIPOC, that is supplier, input, process, output, and customer, SIPOC. Just try to remember this also in first SIPOC, SIPOC model. It's also flowchart. Basically, they are used to identify the redundancies in the bottlenecks. Because if you get too many quality problems, in fact, for in the process, then you try to analyze it at, who was the supplier, in fact, the material you are getting, and what is the process you followed so that, you can take some corrective measures there. The third one is the fourth one is the histogram. Of course, histogram is basically like a bar chart. Here is a particular bar chart showing the frequency of occurrence in a particular variable. You feed the data to the computer, and you will get these counts. In fact, the number of counts and bins. Then you know that histogram with a normal distribution outlet curve. The height of each column represents the relative frequency of that variable. If there is any quality issues, that that in this particular batch or the particular process, that so many times this is based on this, you'll be able to take a decision on that. In fact, this will also it's like a vertical bar chart showing the frequency of occurrence. In fact, the maximum number of times it occurs, then definitely there is a quality problem. The Pareto diagram, which I was talking to you about, that this is the 80-20 ratios. Diagrams are vertical bar charts that identify a few critical issues from the uncritical many. In fact, this is how the Pareto chart is based on the 80-20 rule. This is very common, Steve. In fact, even in any company, the people do say that the 20% of the people contributes 80% of the performance. Am I right? You must have heard about that. Very common, correct? All right.
Sure.
Yeah, 20% of probably the population contributes 80% of the revenue or economic generation. That's what they say. So it's a 80-20 rule. It is spread across all the industries, spread across in all the working environment. In fact, even in the organization, you know that the 20% of the people normally contributes the maximum or 80% what the company is achieving. It's not that others are not contributing, but probably the contribution from some few critical mass is much more than all others put together. Am I right? You agree with me on that? Correct?
Yeah.
Yeah. So it's a very widely used concept, a Pareto diagram. But again, it depends upon the industry and other things. In fact, probably in your company, you are not using this. In fact, so it's based on a 80-20 rule. 80% of the problems are caused by 20%. This also other way, if you look at it, if you handle this 20% of the problems, it will solve 80% of the issues. In fact, that's the other way of looking at. In fact, if you address those 20% of the issues. So, for example, here, if you look at it, the holes and the poor mix, for example, they contributes almost 80% of the problem. So in the quality circle, if you can address these two, your majority of the problems is solved. Correct? Am I right?
Yeah.
So this is another important tool for the quality, to improve the quality in any organization. It prioritizes the potential causes of the problem. You have never used it even in earlier companies, the Pareto diagram?
No, we don't use this.
You don't use this, probably in your industry and other things. Okay. Particularly in the manufacturing, I know I've seen many of those companies, they do use it, in fact, in the quality. So identify the issues and addressing those issues. Scatter diagram is basically comparing the two variables, the relationship. Let's say, in fact, you would have seen in the doctor's clinic, the health chart you would have seen for a height and weight. Suppose you are 6 feet, is the height. Your weight should be ideally around 80 pounds or 75 pounds. If your height is 5 feet, you know that your weight should be around 60 pounds, like that. You would have seen such charts, Steve, in some doctor's clinic. You would have seen, or you noticed it, in fact. So here, basically comparing the two variables and whether those two variables have got any relation to do, in fact. Another example I can give you this ice cream sales during temperature. When the summer, the ice cream sales goes up, am I right? The soft drinks sales, ice cream sales goes up during summer. So if you plot that here, the sales here and the temperature, both will have a lot of relationship to each other. When the temperature goes up, your sales of ice cream also goes up, in fact, correct? So that means it has got some relationship, co-relationship with the two. In fact, that's what you need to compare, in fact. So similarly, for example, during winter, during a freezing time, your sale of this woolen clothes sales goes up. Am I right? Lot of sweaters are sold, lot of warm clothes are sold during winter season. Am I right? When the temperature comes down, that will have a direct proportion on the sales of the warm clothes also. Correct? You agree with me on that? So that means there are some relation between the two variables. Similar way, in the quality circle, how you can compare, if the quality of the material is good, the input material is good, then you will have less defects also. In fact, if the material quality is not good, the input quality material is not good, then probably you will have more of quality issues also. So if two variables are related, scatter diagrams are used to observe the changes in one variable to a change in the other, in fact. That is called scatter diagram, where the two variables needs to be compared. This is another important quality tool. I don't know whether you are using this also in your company. You're not using that, I think, scatter diagrams.
No. Most of what our stuff is we don't generally track deficiencies. It's a pass or fail issue.
Oh, it's only you do that. Okay. You don't check. Okay.
Yeah.
That's right. Okay. I got it. That's right. Design for X, which I was just explaining to you, that is a set of technical guidelines that may be applied during the design of a product for the optimization of a specific aspect of the design. DFX can control, even improve the product's final characteristics. It's basically reliability, deployment, assembly, manufacturing at various places. The design for excellence is used. May result in cost reduction, quality improvement, better performance, and customer satisfaction. That means whatever you are designing, you design it for excellence. In fact, that's what you keep that in mind. So that is one of the important the quality aspect. What you are trying to do it best, in fact, so that it can reduce the cost, it can improve the better performance of the project. Some of the car manufacturing, they do follow this design for excellence. In fact, where they improve the safety of the vehicle. Some of the brands like ITTO and all those things, they are very good. Am I right? They are all built for excellence. In fact, that's one of the reasons they're able to enjoy the brand reputation and the market value in this restaurant.
That's correct. Yeah.
Correct. You agree with me, no, right? There are, we can give several examples, in fact. Why the brand succeeds is because they all built for design for excellence, in fact. Then only you can survive in this competitive world, am I right? Otherwise, I don't think you can survive today if it is not designed for excellence. Manage quality outputs. You will have the quality reports, then you will have the test and evaluation documents that we discussed.
Hello, you there?
Yeah, I'm there. Can you hear me? Hello? Hello? Are you there? Hello? 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 Hello, Steve? Hello? Hello?
Hello?
Hello? Can you hear me? Yeah. Hello?
Yeah.
Yeah. Okay.
My phone
I don't know. Suddenly something dropped out, I think. Okay. Can you hear me now? Can you?
I got you now.
Oh, okay. What could be the issue? That's some network issues, probably.
What's that? Yeah, it might be something with the network.
Network input. I don't know. So here also, there's a lot of fluctuations. I don't know. Sometimes it goes harvested. Okay. Sorry about that. Of course, I don't think there's a problem. So we are covering about the design for excellence. Hope that's fine. Test and evaluation documents. After that, once you manage the quality, you need to do the control the quality. Okay, control quality is basically, as we discussed, is a process determines if the project outputs do what they were intended to do. In fact, this is where you are validating the quality. In fact, intent to do what they're supposed to do. These outputs needs to comply with the applicable standards, requirements, regulations, and specification. This process is performed throughout the project. So you can ask you, do you follow ISO system, ISO procedure or guidelines, standards?
No, we don't. We don't.
You don't follow that. In fact. Okay. This ISO stands for what? Are you familiar with that, ISO?
I'm not even familiar with it. What does it stand for?
It is actually, it's an international organization for standardization. They have a set of rules. It's ISO. Actually, many people do mistake. It's an international standard organization. It's not like that. International Organization for Standardization. It's called ISO. It's actually, they have some set of rules which many companies do follow as a quality policy, and they benchmark it, in fact. Very many companies, they advertise that we are ISO standard 9000, 2001, 2015, like that. In fact, it's basically a frame of quality. In fact, they are standardized. In fact, and many companies do follow that. And the companies' products get recognized if they follow this ISO 9000 ISO form. It's again a quality standard. You just need to remember that. But of course, many companies, many organizations do follow it, but I don't, in your organization, probably you have a different quality policies. Okay. So the inputs here, we're talking about the project PMP, project management plan, and your quality management plans, the lessons learned, quality metrics, test and evaluation documents, which we just discussed in the previous slide. Then you have the approved change request and deliverables. This is very important, because the approved change request, only it is approved, then probably it will become the verified deliverables. In fact, this is what we discussed at length. So the verified deliverables, again, it will go through that monitoring and control and the other process, then it will become the approved, the deliverables. So here the other few things is your work performance data, which is very common in all the monitoring and control process. If you look at the work performance data will be there, and you will have the work performance information. And the checklist we discussed, the check sheets, check sheets is, where you clearly document all the aspects of the quality. In fact, what all you're supposed to do, it's all mentioned in that. Then statistical sampling. Are you familiar with the statistical sampling, Steve?
Yeah, most of our work is statistical sampling.
Sampling, you do it in it. Okay. That means you check a few and ensure that the rest all remains same, right? It's like that, correct?
Right.
Yeah. Okay. Okay. That's one important tools and technique, particularly for the mass production and other things, that will also helps, in fact. So test a few, in fact, that, then you assume that rest all fall into the quality policies. The question and surveys, I'm sure you are very familiar with that. Then the data analysis, your performance reviews, root cause analysis, which we just discussed, inspection and testing the product and evaluating that. That's also we discussed. And the data representation, cause and effect diagrams, that is the Ishikawa diagram or the root cause analysis, the control charts and the histogram, the scatter diagram. What is important to remember is that both these tools and techniques are used both in managed quality as well as the control quality. In fact, you need to remember that where it's applied both here as well as in the other things. So here, if you look at it, even in the managed quality, some of the same tools and techniques are used, and even in control quality, also the same tools and techniques are used here. Then what outputs you get is the quality control measurements and verified deliverables, the work performance information and your change request, the project management plan updates, and various other things gets updated in the control quality. So these are the example of check sheets. Check sheets are also known as the tally sheets and are used to organize the facts in a manner that will facilitate the effective collection of the useful data. For example, these are the data, small scratch, these are the dates you are mentioning. In fact, how many of these defects are appearing in these data? So that will also help you that which particular day, you have maximum problems, so that, you can analyze what was the reason for that, the data one, in fact, whether the process was right, whether the people involved were right, in fact, all those things, it will help you to take some decisions on that. This is called the check sheets, or also called tally sheets. Do you use such sheets in your company, Steve?
Yeah, sure.
You are using it, in fact. I think it's a pretty useful document. I think very simple, straightforward, and the frequency, basically to understand the frequencies or the consequences of defects collected, in fact. So you can go back and do the root cause analysis from this, whether the inputs were proper or the people were handling, or was there any equipment issues on that particular day, and all those things, you will know from this check sheets. So approved change request as a part of the perform integrated change control process. A change log update indicates that some changes are approved and some are not. Only the approved change request may include the modifications such as a defect repair or revised or work methods and revised schedules. The partial change completion may result in inconsistencies and later delays due to incomplete steps. So the implementation of approved change request should be verified, confirmed for completeness, retested and certified as correct. This is a very, very important thing. And normally your quality control manager has to really take a lot of initiative in this regard. So the deliverable is any unique product or a verified product, result of a capability of the performed service, and deliverables that are outputs from the direct and managed project work process are inspected and compared to the acceptance criteria. So the deliverable is almost a final product, and once it is validated according to the customer requirement, then it will become the final product, in fact. So again, to revisiting this, the project management plan, you will have the direct and managed project. This is the execution process. The deliverables will go through this. Then this will become the monitoring and control process. After this, the deliverables will become validated deliverables. Then it will become accepted deliverables. Once it is accepted, once it is validated, that means it is meeting the customer's satisfaction. Then it becomes accepted deliverables, and it is a closed project or phase. In fact, I'm sure this has come 4 to 5 times in this process. Basically, to just to how important this process steps are. That's one of the reason it gets repeated. In fact, you understand, I hope, Mr. Steve, on that. It is so important. Actually. Okay. Any questions, Steve, on quality so far?
I don't think so.
You don't think so? Because basically you're from the quality, I'm sure you know that it should further help you to, I'm right? That's right. Though some of the concepts you are following in your company, some may not be useful in your projects. So that must be the reason that you are not following those concepts, probably, or those tools, I would say that.
Yeah, that's correct. I mean, some of the concepts we do use in our industry, and some of them we don't.
Right.
You don't. More applicable to manufacturing.
Yeah, correct. Absolutely. Yes. That's what the tailoring of. You are absolutely right. That's why they say that keep tailoring of these concepts where it is required. Only should be used. In fact, that's why it is where it is required only should be used. That's right. So let's see some questions on quality management. When a product or a service completely meets customer requirements, that means The quality is achieved, the cost of quality is high, the cost of quality is low, the customer pays the minimum price. What could be the right answer? When a product or a service completely meets the customer's requirement.
Quality is achieved.
Quality is achieved. I think that must be a straightforward answer. Right. To what does the following definition refer? A type of analysis focused on finding the point at which the benefits or revenue to be received from improving the quality equals the incremental cost to achieve the quality. To what does the following definition refer? A type of analysis focused on finding the point at which the benefits or revenue to be received from improving the quality equals to the incremental cost to achieve the quantity. Is it quality control analysis? Is it marginal analysis, standard quality analysis, or the conformance analysis? We are talking about the benefits or revenue to be received. That is the catch point there, I think.
Benefit of revenue to be received from improved quality equals the incremental cost to achieve the quality. This is the full definition for types of analysis. So, point. Benefit of revenue. Conformance analysis?
We're talking about the benefits or revenue. We look at it, I think it cannot be quality control analysis or standard quality analysis. Don't you think it's a marginal analysis? Because you're talking about the benefits or revenue, am I right?
Okay.
That should be the right answer, I think, marginal analysis. Because we are talking about the benefits or revenue to be received from improving quality equals the incremental cost to achieve the quality. So basically, It will become, I think, marginal analysis.
Okay.
Yeah. Who is ultimately responsible for quality management of the project?
Project
Very
manager.
important. Yeah. Project manager?
Yeah.
That must be the right answer, because ultimately, although each person working on the project should check on the work, manager ultimately has a responsibility of quality of the project as a whole, in fact. That's why when I asked you that question, you have a quality control manager. He might be independently working, or sometimes he might report to the quality at the corporate level. But in the project environment, ultimately, you as a project manager will be responsible for the quality impact. So, because you are the captain of the ship, am I right? You're right, Steve?
You're absolutely right.
So, you had to sail the ship. Ultimately, whatever happens to the ship, ultimately, you are the captain. So, you are responsible for it. It's like that. You are in the middle of a major facility construction project. The structural steel is already in place, and the heating are being put into place, where a senior manager informs you that he's worried the project will not meet the quality standards. So what should you do in the situation? Assure a senior management that during the planned quality management process, it was determined that the project would meet the quality standards. Analogously, estimate future results, involve the quality team, and check the results from the last quality management plan. I think the first and the last one you can straight away reject between even B. Just look at it. What's your take on this? Little tricky question, but
yeah, it is. I mean, it's pretty open-ended on a few levels.
Yeah.
I checked the results from the last quality management plan.
Mm-hmm.
See if there was any issues with the structural steel that was already put in place.
The structural steel is already in place, and the heating conduits are being put into place when a senior manager informs you that he is worried the project will not meet the quality standards. Don't you think that involving the quality team at that time will be a better option? I'm just debating it, but I'm still saying. Because ultimately they are also equally responsible for the quality, am I right?
Okay, yeah, involve the quality team, sure.
Yeah, probably to find out and analyze the reason why it's not, what's the problem. So the best thing is to probably, we'll look at that answer in fact. You're asked to select tools and techniques to supplement existing quality controls activities, which are the following would not be appropriate for this purpose. Is it performance reviews? Is it statistical sampling? Is it Pareto diagrams? Or is it focus groups? Tools and techniques.
Focus groups.
Sorry?
Focus groups.
Focus group? I think so, yeah. Because, you know, the statistical sampling, the Pareto diagrams, and the performance reviews are all the quality control activities that you do. The new software installation project is in progress. The project manager is working with the quality department to improve the stakeholders' confidence that the project will satisfy the quality standard. Which of the following must they have before they start the process? The new software installation project is in progress. The project manager is working with the quality department to improve the stakeholders' confidence. Sorry. Is it quality problems? Is it quality improvement, or the quality control measurements, or the rework?
Quality control measurements.
Will satisfy the quality standards, which are the following must they have before the things. Let's look at it. You're absolutely right. Quality control measurements is the right answer for that. So even though the quality problems may lead to quality improvement efforts, they are not a prerequisite for quality improvements. Hence, quality improvement is the result of managing quality and control quality, not an input. So rework, it's not can be an output of the control quality that leaves the only quality control measurements which are inputs to the managed quality process. You are absolutely right. And the focus group, again, answered it correctly. And the first answer, for example, why did we debate on involve the quality team? The rationale is that assuring management that it was determined in planning the project is not a productive, since it does not solve the problem. An analogous estimate also history of the project. This would not be appropriate to determine how the current project is going on. The quality management plan does not provide the results. So the only thing is that the best answer is the quality team could help to determine whether the team is following the correct process to satisfy the relevant quality. That is the rationale for selecting this answer. In fact, correct? You agree with me, Steve, on that? I'm sure that's right.
I do now. Yeah.
Yeah. So that's the rationale. In fact, in that context, the best thing is to involve the quality term. Of course, these are very straightforward. You answered it correctly. But that's the only reason. So, any questions on quality thing? What you can expect from the quality knowledge area? 2-3 questions at least. One is you need to memorize the 7 quality tools, Steve. In fact, they will ask you that what are the 7 quality tools. So what they will do is they will give 4 options. In that, sometimes, instead of scatter diagram, they will mention something else. Spotter diagram, like that, they will mention. Instead of check sheets, they will probably, they will mention the CHUCK sheets, like that, they will mention in the questions. Or cause and effect, they will put something else here and give that. So all the 4 answers looks very similar, except the spelling of some of these things, in fact. So you need to really select the right answer. And if you remember that, that's why if you memorize these things, that will really help you. That is one type of question may come. Of course, the second questions, in fact, which is the tools and technique that you use in this particular scenario, whether you use the root cause analysis or you do the Pareto analysis, like that, there might be some situational questions also that it will. And the third one is, for example, this PDCA, who invented that? Who was the founder of PDCA? Plan, Do, Check, Act. Probably there might be some questions on that also. It's like that. So I would request you to memorize these 7 quality tools. It is almost like you are that earned value management formula. You need to by heart these things.
Okay.
Is it possible? I'm sure it's possible. Am I right?
Oh yeah, sure.
Yeah. So just take a picture of this, or when you go through your book, kindly mark it in red so that you always remember these things. And you can expect at least 2 to 3 questions will be there in the quality management. And sometimes they do ask what design for X stands for, design for excellence. And that's what mostly from the quality management, the questions can come in. And another important thing is this one, cost of conformance and the cost of non-conformance. What are the failure cost? What are the prevention cost? Just kindly try to remember these things, in fact. Internal failure cost and the external failure cost. Is it a prevention cost? Is it an appraisal cost? Like that, they might ask you certain questions on these things. One thing in the questions, if you look at it, there will not be any straightforward questions except mathematical questions, formula-based questions. Many of them, when they ask you, in the examination, it will be the twist and turn will be there. So sometimes, that's where, your management skills, that's where your experience of handling the various projects should help you to answer those questions. But so far, the way you are going, I'm sure you can really do well. Absolutely, there is no thing. Another question could be on the grade and quality, in fact. Whether the low grade or high grade is acceptable or low quality is acceptable, such questions will be there. Or could be your accuracy and precision. That could be another type of questions. Otherwise, it's a straightforward subject. And since you have a lot of experience in quality management, I'm sure you should be able to crack those questions in the examination. Okay. So far, any questions or any clarification, Steve? Sorry, I keep asking you about that just to reconfirm that both of us are on the same page. Same page. Yeah. Comfortable. Very good, in fact. Okay. So we will try to touch about one thing, something slightly different from this knowledge area, but it's equally important. How do you select the projects? In fact, that's another important things to understand. On what parameters? Oh, sorry. Okay, can you see that share? Okay.
The only thing I see the knowledge areas.
I'm just opening. There's another one. Okay, 1 second. Yeah, can you see the screen? Oh, no, it's right. Okay.
I see process groups and knowledge areas.
The project selection methods. Can you see this? Yeah. Hello.
No.
Project selection methods. Are you able to see this?
No, I see the the table for the process groups.
You're not seeing this screen. An organization can take.
I see the screen. I mean, can you move your cursor and see if it's...
Project selection methods, can you see that?
No.
You're not seeing that?
Must have lost the screen.
You are still seeing this, is it? No. You're seeing this?
No, I'm gonna have to re-sign in.
Yeah, probably yes. Yeah. Project selection methods, that's what I want to see that. You're relogging, is it, Steve? Oh.
Yeah, I'm trying to.
Yeah, okay.
Okay, project selection methods.
Oh, excellent. Okay, you got it. That's right. So what are the methods that how you select a project? It's also very important to understand. Okay, so an organization can undertake a project as a contract or a driven by the business needs. We discussed at length the business needs, am I right? So there should be a formal process for selecting the projects to ensure that the limited corporate resources are optimal. There are two ways of selecting a project. One is the benefit measurement method. Another is the constraint optimization method. Okay, so do not too much worry about this constraint optimization method techniques, because basically these are all requires a lot of mathematical calculations. And in the examination, you will not have time to do any much mathematical calculation, because this requires lot and lots of calculation. But let's try to understand the basic thing. How do you select? So there are two types of selecting the projects. One is the benefit measurement method. Another is the constraint optimization method. So what are those benefit measurement methods? Some of the examples are motherboard, peer review, scoring models, economic models, and benefit compared to cost. Let's try to understand motherboard. You have heard about it any time by any chance? Motherboard terminology, Steve?
No, that's a new one for me.
It's a new. Okay. Motherboard is basically taken from the US Army. In fact, earlier, once upon a time in the US Army, for any projects or anything to be done, suppose if a captain wants to take some initiative, they used to ask all negative questions. In fact, how this can be done, can you prove that it is impossible to do? So all the negative questions, that means virtually they used to, demotivate that guy, in fact, to such a level that, he has to really find it very difficult to convince, in fact. In the similar way, the motherboard, it has been taken from that, the perception that in the project environment, suppose you go with to your senior management or anything, they will ask you all negative questions about the project, in fact. And if you're able to convince them, then only they will approve the project, in fact. That's one example. The second one is the peer review. Peer review is, of course, your colleagues, in fact, they review the project, and they will sometimes, they will also approve the project. The third one is the scoring model. You've heard about the scoring model. Let me try to take an example for that. One second, just. Okay, I'll share. Scoring model is comparing the various benefits and advantages of different projects. That's how, there's another scoring model you do that. which, for example, it could be your reputation, it could be the benefits that you are going to get out of the projects. So you will measure the various things. That is a scoring model. Then the economic models and the benefit compared to cost, I will explain to you in the following slides. In fact, economic models and the benefit compared to cost. Now, the linear programming and goal programming, integer programming is all constraint optimization methods. Now, in the examination, they will ask you like this: what type of project a selection technique is it peer review, or a peer review is the benefit measurement method? This is how we need a questions might come, in fact. What type of project selection technique is peer review? So same way they might ask you, what type of selection method is linear programming or a goal programming or an integer programming? In fact, that's how the questions are asked. So if it is there, you need to understand that which are all the benefit measurement methods and which are all the constraint optimization methods. You need to just understand this from the examination perspective. But if you want to really understand that, then probably we need to have some separate classes for this, because this will take a lot of time to work out and understand those concepts. So from the examination perspective, you need to just know about these things: the motherboard, peer review, scoring models, economic models, benefit compared to cost. These are all benefit measurement methods, and constraint optimization methods or linear goal programming, integer and programming. If you Google it, you will know that there is a lot of calculations required for this type of calculations. Now the third one is sorry. Let's understand the planned value. Of course, this planned value is slightly different from what we discussed the earlier. The present value is the current value of the future cash flow. The amount of money received today is worth more than the amount in the future. So a discount factor has to be applied to reflect the future cash flows in the present value. Let's try to understand a sum of $250 being spent right now will be more valuable than the $250 being paid after 3 years. Am I right? It's a more of a commonsensical. Am I right, Steve? You agree with me on that?
Sure, yeah.
So the present value is always more important that. So any project which gives the immediate returns is far more beneficial than the later returns. So you always look at the present value compared to the future value. Suppose any project which is giving you benefits in 3 years compared to another project which is giving you a benefit after 5 years, if you compare that, you will always prefer a project which gives you within 3 years. In fact, that is the present value calculation. Now, the net present value, that is another NPV, it is called. NPV is the difference between the value of the total benefits income or revenue and the cost over a period of time. So here the present value different times combined gives the NPV. So let's say project X will take 2 years and the project 1 has got an NPV of $35,000. Project Y will take 5 years to complete and has an NPV of $95,000. So which project would you select? So you please remember that whichever the project has got higher NPV, you select that as a project. In fact, higher the NPV is always better, in fact, because this number of years has been taken into consideration already while calculating this. So you just select the project which gives you higher returns. Higher NPV is always better. So don't look at the number of years. You just select the answer which has got a higher NPV. Please do remember that. I will, if possible, I'll show you how this is calculating in one of the slides. Let me try to explain that. But for the time being, you need to understand that NPV, whichever is higher, is always the better one. The third one is the internal rate of return. Again, internal of rate of return, it requires a lot of calculations. So here it is also called as a IRR, the rate of discounting used to reduce the future cash flows to their present value. So at which the present value of the cost match the present value of the benefits. So again, it is a permutation combination. You keep working on that. Then one particular year, for example, the present value of the cost will meet the present value of the benefits. So that will be the internal rate of return. So let's say a project A has got an IRR of 25% and the B has got an IRR of 15%. Which project would you choose? Please remember, like NPV, the project which has got a higher IRR will be the one you need to select. In fact, the project with the higher IRR is always better. So both for NPV and IRR, whichever is the higher, you need to select it. I'm sure in your company, your finance guy must be working on all these things. Am I right, Steve? Correct?
I hope so.
Yeah. Anytime were you involved in this type of discussions about the IRR and NPVs? Anytime?
Not with the present company, no. But
Not in the present.
But I have. I have in the
even
past.
in the previous company also. Any opportunity you had to interact with the finance guys? No. No. But as a project manager, as I told you that sometimes we are like jack of all and master of none. We need to have some basic understanding of these things. In fact, what is NPV? What is internal rate of return? Yeah, just a basic things. In fact, as I told you that you always have the subject matter experts to help you out to take the decisions. But at the same time, when we discuss with our customers or with your external thing, you need to know a little bit of what is internal rate of return and what is NPV and what is the PV. So that will help to understand those concepts clearly. The fourth one is the payback period. Of course, this is very commonsensical. The payback period is the number of time periods it takes to recover the investment from the project before the profit starts accumulating. Here, the project A has got a 5 months and project B has a period of 12 months. So which project would you select? So naturally, you select the project which gives you in a lesser period. In fact, am I right? It has to be a lesser payback period. So the project with the lesser payback period is always better. In fact, correct? It is a very common sense thing. In fact. The fourth one is the benefit cost ratio, BCR, which we were discussing several times. So here a question may come like this: compare the present value of benefits to the present value of cost. A benefit cost ratio of more than 1 means that the benefits are greater than the cost. In fact, that means your benefit will be above, the cost will be less, and if you divide it, you will get. So which project would you select if the BCR of a project is 2.5 and a BCR of project B is 1.5? Naturally, you will select project A because your benefits compared to the cost in the A is higher, in fact, 2.5, and here it is 1.5. Correct? Am I right?
Yes.
Steve? Sometimes they twist and ask you if it is a cost benefit ratio. No, benefit cost ratio is 2.5. Suppose they give you cost benefit ratio, then you need to select the lower number. Correct? It's very common sense. That means your cost should be always less than the benefit. Am I right? So if the cost benefit ratio, they ask, the smaller the number you should select. You need to keep that point in mind. Benefit cost ratio, it is a higher, cost benefit ratio, probably it will be opposite. So accept a project BCR greater than 1, the project with a higher BCR is always better. What is opportunity cost? Have you heard about it, Steve? Anytime? Opportunity cost?
Sure.
Yeah, opportunity cost is the one which you don't select. Correct? Am I right? That is the opportunity cost that you would have lost. For example, here there are 2 projects cost related to the next best choice available after choosing from among the several mutually exclusive choices. What is the opportunity cost for selecting project B if the project A has an NPV of $55,000 and project B has an NPV of $85,000? So what do you think is the right answer?
I'm missing the screen again. Can you say that again, please?
You're not able to see the screen?
Yeah, it quit on me again.
Oh, I see. It's not showing the opportunity cost. Okay. Opportunity cost is basically what you don't select. There are 2 options are available. Let's say one project gives you $55,000. Another project gives you, let's say, $30,000. Okay. Suppose by any reason that you select a project which gives you $55,000. So what is the opportunity cost in that? The project which you don't select, that will become the opportunity cost for any reason or for many reasons. In fact, you got it, Steve?
Yep.
So that means you're losing an opportunity for whatever reason by not selecting the another project. That is the opportunity cost.
Okay.
You got it?
Yeah, I've got the concept of opportunity cost. I'm trying to get signed back in so I can see the screen.
Okay, just try whether you can get that. You got it back or no?
No, not yet.
Not it. Oh, you just try it. Okay.
Yeah. I mean, you can keep going ahead. I'll catch up.
Okay. So that is the opportunity cost, that you lose. So these are all the few important things. Let me get one more slide if possible, so that I can understand.
It's not wanting to join.
Pardon me. Sorry.
It's not wanting to join the meeting.
Why is like that? But I'm able to hear the sound very clearly.
Yeah, I'm called in on my phone.
Uh-huh. Oh, okay.
Because I've been having problems with this ever since yesterday.
Oh, is it? Okay. Oh, that's the reason you're connecting. You're connecting over mobile, I think, probably.
Yeah, that's why I'm calling on my phone.
Okay. I understand, in fact. Okay. Because this is, to explain this, it's better you look at the screen so that you can understand better. So I'm just thinking like that.
Sure.
Because some calculations are involved, so it's easy to understand that. Just try a couple of minutes, then otherwise, we'll take a call. What should be done by next Saturday? Probably you can get it right. And
okay, there we go.
Here you go.
Yeah.
Got it. Great. Okay. So PV is NPV. I was just trying to explain now. This one. You remember that slides? Let's see. The first one.
Right.
The present value, remember that this is what I was trying to explain. The sum of $250 being paid right now will be more valuable than the 3 years now. So for that formula, how do you calculate the present value is the future value divided by 1 plus R. R is the rate of interest or the rate of the expected rate of interest multiplied by the N. This is the formula that I use. This just for information. In the examination perspective, I just want to understand these concepts very clearly. Where PV is the present value to be calculated, FE is the expected future cash flow, and R is the rate of return input, expected rate of return. That's how you calculate the present value. Now, if you apply the same thing for the net present value, so here is an example. I thought net present value, as I explained, it is the present value of every year with the future value with the present value of the formula. So here PV1 is the present value of the first year, present value of the second year, present value of the third year, like this, of the minus invested amount. You total up all the future values minus the invested amount. Just to explain, I have made a calculation. Let's say for a project, you have invested $500,000 today. Okay, this is a $500 you've expected. The cash flow for first year is, let's say, $200,000. Second year, it is, let's say, $300,000. The cash flow during the third year is the $100,000. Just for example, just to understand the concepts of this, of NPV. So here, the rate of interest is 5% per annum. Okay, rate of interest is so far with me. Is it clear, Steve? Your investment is $500,000. First year you are going to generate $200,000. Second year you are going to generate $300,000, and the third year you are going to generate $100,000, and the rate of interest is 5%. Now, how do you calculate the NPV? If you look at here, so NPV is present value first year, second year, third year, n year, then minus investment. So the first year you apply the same formula, the future value divided by 1 plus R. So the first year is $200,000 divided by 1 plus 0.05% is the rate of interest. 0.5 you take it as a 0.5%. Second year, $300,000 divided by 1 plus 0.5 multiple square root of 2. Third year, you take $100,000, 1 plus 0.5, 3. So you will get first year $1,90,000. Second year, you get $2,72,000. Third year, you get $86,383. Now, the total NPV, you have invested $500,000. If you add up all these three numbers, you will get an NPV of 5,48,000. Now, according to this formula, NPV for the project is the total NPV for 3 years minus original investment. That means your original investment is $500,000 and you are going to get 5.548968. So if you do minus this 548 minus the investment, you get 48,968. So that means when your NPV is positive, you can select that project. You got it, Steve?
I do.
Yeah, I do. Okay. I'll be sending the slide afterwards so that you can go through once again so that you can understand in case if there is any confusion. So remember that any NPV, if they give you 3 options, 3 years or 4 years, different NPVs, you need to remember whichever the project higher the NPV, you need to select the project. Like your internal rate of return, positive NPV means the combined PV of all cash flows exceeds the cash outflow. Hence, the project is acceptable, in fact. Similar way, the internal rate of return, I told you that whichever the higher the internal rate of return, you need to select the project. Payback period is whichever the lower the period, it's opposite to your NPV. It is very commonsensical, right? Any product which gives you returns much earlier, much before that, that's the one you need to select. Benefit cost ratio, I explained you that whichever the benefits are higher, you need to select those projects. And opportunity cost, can you see the screen now? Are you able to see? At that time, you are not able to see that.
No, it went out again.
Opportunity cost, you can't see this?
No.
Oh, the previous slides you were able to see, am I right? NPV, you were able to see this?
I got the NPV slide, right.
Yeah, but how come you are not able to see that screen? There is some issue there, I think you must be having it. Can you see this screen? Any chance? No. NPV is higher the better, internal rate of return higher the better, benefit cost ratio higher the better, payback period less than the period, and return on investment higher the better. Are you able to see this screen? No. Or
nope.
Oh, I think there it's coming and going, I think, for you, I think, screen.
It is. It's coming and going.
Yeah, coming and going, yes, right. I don't know. It cannot be due to network because your audio is so clear. I think you have some system issues there, I think. System issues, probably.
Well, I'm able to, I've got high-speed internet and a relatively new computer.
Oh, I see. New computer, okay.
And I'm able to, I'm able to go to the Zoom, their website immediately. It's just when I sign into the meeting, so I suspect it might be something going on with Zoom.
Zoom, in fact, is it? No. I see. But I'm surprising your audio is so clear and so good. It is. What could be the reason? I'm not understand.
Yeah, I don't, and I'm not signed on through the computer for the audio.
Oh, okay. Oh, it's not synchronizing, is it? That's what's happening?
Well, I called in on my phone.
Yeah, okay.
The audio.
Oh, okay.
So I'm not using
you're not
my
using
computer to.
Okay.
Right.
You feel by next Saturday you'll be able to set it right? You can use both computer and the audio together.
I don't know. I don't know that it's an issue on my side, to be honest with you.
Pardon me? Sorry, I don't.
I don't know that it's an issue on my side.
Oh, the issue is okay.
Might be something to do with Zoom.
Zoom in, but otherwise, I will tell our people also that there are some issues that not with the screen. I will tell Ismart guys, in fact, okay, how they can rectify that. Let's see. But this one, a few slides earlier, you were able to see that NPV calculation, but the later on you could not see them, right? That's what's surprising to me, in fact.
Correct. Yeah.
Yeah, that's right. That means it's coming and going there, in fact.
Yeah.
But here I can see very clearly that, I'm sharing the screen and seeing it. But
I get it. And it worked fine most of the morning.
Yeah, yeah, it worked so far, in fact, till now. I'm right. Till I think 20 minutes back, it was working out well. Correct?
Yeah.
And you are able to read all the questions and answers and all those things.
Yeah. Yeah.
Okay. I feel probably it cannot be a network or system issues. There is something strange. I'm not able to make out what exactly is that. Even now, it's not coming. Am I right, Steve? The screen is not coming up here.
No.
Is it coming? No, it's not coming.
Oh, there we go. Came back up now this time.
Came back?
Yeah, we'll see how long it lasts this time.
Okay. Are you seeing now the screens? That's right. Okay.
I am. I can see you're scrolling on the left-hand side.
Okay, then I will reopen that one, which is very important.
There we go.
I thought. Yeah. So this, you have seen this slide, am I right? NPVs, this
Right.
formula, you are able to, yeah. Great, which I explained to you very clearly. So this one, did you see this screen? You see this?
I did. We went over that one.
Okay, great, in fact. And I think this one, you could not see this, am I right? Yeah.
I couldn't. No.
Yeah. So this is the summary of these selection methods. From the exam tip, I prepared this, from the examining perspective also. So NPV, whichever is higher, kindly select that. Internal rate of return, higher the better, you should select it. Then benefit cost ratio, higher the better. Payback period, lesser the better. This is what you need to remember. And return on investment is the higher the better, in fact. You need to just kindly remember some of these things. So again, from the examination perspective, at least 2 or 3 questions will be there on some of these things. It's pretty easy to answer if you are clear about these concepts. Again, probably you need to memorize it or mug it up. And most of the time, it is very commonsensical also, in fact. Higher the net return, higher the internal rate of return and benefit cost ratio is always better. This is just an example, I prepared so that, you can understand how to calculate the net present value. So net present value, just once again, for your knowledge sake, just in fact, you take the present value of all the future cash flows and you minus it from the invested amount, you get the net present value and we will have a rate of interest for that. You need to just remember that.
Okay.
Now, this is the sample of weighted scoring model I said. And coming back to this, please do remember these things: murder board, peer review, scoring models, which I just explained. Economic models is what I just explained, that NPV, IRR, and all those things. So which are the benefit measurement methods and the constraint optimization method? You just remember, since you have missed this slide, I thought let me say that. So they will ask you that which is the linear programming method in the examination. If they ask you, then it's easy to answer that it is a constraint optimization method, where you require, if you Google it, you will know that there is a lot of calculations involved. I think your finance guy, subject matter experts, probably they will guide you in case it is required to understand those calculations.
Okay.
Okay, great. So, any questions on so far any of these things which you have covered today, Steve?
No.
I know today is a little heavier than yesterday. Am I right? The subject, correct?
No. I think today was a good session.
It's a good thing. Okay, great. I'm happy about that. That's right. I'm sure quality you should be able to answer all these questions. The schedule management and the cost management, many of the formulas are very similar. This anomalous estimation and parametric estimation, 3-point estimation, and PERT, program review, technological techniques, in fact, review, all those things are, if you remember the concepts, it should be easy to understand those questions very clearly. Final day, I will send you one PPT where, all the formulas will be in one page. Okay.
Okay.
So that, that will help you to just go through and memorize it because few more things, in the resource management, there will be a few formulas will be there. So I can add up those things and send to you so that, it will be easy as a guide for your examination preparation also. I will send it across to you on the next Sunday, probably once we complete the sessions.
Okay.
Because I wanted to be comfortable in all aspects and I wanted to take the examination with 200% of confidence. That's important. Okay. That's right.
Sure.
And I'll be too happy that the day you say that you got the certification.
So will I. So will I.
Yeah.
I think it's long overdue for me. Looking forward to getting it and being able to use it.
Yeah, sure. And anytime, it's not just these 4-day sessions. It's not like that. Anytime in future also that you need any reference or guidance or any help from our side, we'll be too happy to do that. In fact, okay. It's almost like a lifelong association that I would like to have with my colleagues or friends whom I get associated in my teaching the subject. That's important. Yeah.
Okay, great.
Yeah.
Great.
Right.
I'll have to get on and make sure that I get my contact information over to you.
Yeah, that's right. Yeah. So what's the plan for the weekend now? Sunday.
I think I'm going to dinner with my in-laws later on tonight.
Oh, is it? Okay, great.
Yeah.
In-laws.
Pretty
They
quiet.
stay nearby?
Yeah, they're only a few miles away.
Oh, a few miles away. Okay. So we'll have a family get together. In fact, they'll be too happy about that. That's great.
Yeah, well, like I said, my kids are in college, so it'll be myself, my wife, and my in-laws.
Oh, in-laws. Okay. Oh, that's right.
Yep.
Yeah, that's right. Ma'am, wife works. She also working or?
Yeah, she works. She's got her own company.
Oh, own company. Oh, excellent. Great. What do they do? With what line or what business they do?
Construction.
Oh, construction. Is it? Oh, I see.
Yeah.
Home projects
She's
or?
What's that?
Home projects. What do they do? Construction, buildings.
She's actually she's a minority set-aside contractor.
Oh, okay. Oh, great. That's right. Has she done project management, PMP?
I don't know if she's pushing anybody with her organization to do any of that or not.
Oh, okay. In your company, how many of PMP certified? Just for understanding.
In the present company I'm in?
No, yeah, present company. No. Not many.
Yeah, no.
Oh,
nobody.
Okay. Oh, I see. Oh, you're the first one to do it. That's right. Oh.
Yeah, when I was with the last company, there were probably 15 or 18 people that were certified, right?
Oh, okay. What I hear from my friend circle is that nowadays the organization, before giving any projects, they want to get the details that how many are PMP qualified in the organization. I think that's one criteria that many companies are trying to follow nowadays, I think. Before signing new projects, How many are PMP certified like that? Probably some companies have started, I'm told, but I don't know whether it's applicable in all these companies like that. Probably they feel that it will be comfortable to deal with people who have that required knowledge. I think. Am I right, Steve? I think that could be the reason.
Yeah. Like I said, I look at it more as understanding the language of construction, project management.
Correct. Absolutely. That's right.
And you have to have a common ground. To operate on, and quite frankly, in our business, not everybody's on that same common ground.
Yeah, correct, absolutely right. And you will have a lot of challenges because of that. Am I right? The wavelength, understanding, a lot of issues that you will have, I think, because of that.
That's correct. That's absolutely correct.
That is why even the choosing the partners sometimes, giving the projects, they should be. That's why the source selection criteria, which I was trying to explain yesterday, today, which I did explain, is these are all some of the factors, whether they are on the same page, whether you match the culture, whether the organization have the required capabilities. All those things are very, very paramount and critical for giving the projects. That's right. Have you done any projects in India, Steve?
No.
Not so far, in fact.
No, not so far.
But we don't know. In future, you may get a lot of opportunities because the India is booming and grooming well now, doing well. That's right.
Yeah, actually, we got a young man who's in our office. Is from Mumbai. I've heard you speak of it many times.
Oh, great.
Have you ever traveled to?
Have you ever traveled to India anytime?
No.
Not travel. Oh, okay. Yeah, that's right.
I've been to Europe a couple times.
Okay.
Never been to India.
But there also in Europe, also the project management concepts are very popular. That's right. Many European companies do have the PMP. They also have, I think, the Prince 2. That's another process they do follow. There is another skills they do follow it. Particularly the manufacturing companies, I think they do have that as well. Great. Well, now what is driving now US now economy?
Construction
is driving.
Yeah, I mean the economy in the United States is in a lot better shape.
Yeah, it's a lot better shape. It's doing very well nowadays. In fact, that's right. Your dollar price is skyrocketing. It's really getting appreciated. Yeah.
Yeah, the dollar's appreciated. We back in 2008 we had a pretty significant recession.
Yeah. Okay.
And for everybody in construction, it was a depression.
Yeah, that's right. That really affected.
2008 put a lot of people out of business.
Yeah, correct. That's right.
There were a lot of good companies that went under.
Yeah.
During 2008.
Correct. Your pharma industry is one of the leading. Of course, US is the #1 market for pharma industry and healthcare industry. I think that's must be doing pretty well now, am I right? Your pharma industries.
They are.
They are doing it. Yeah, that's right. Healthcare, particularly, it's a major project for the government also. The healthcare projects.
I don't know if it's for the government because there's still a lot of private
investment is happening. Private investment is happening. Right. Okay, that's right. That's great. Okay, then, Steve, if you have any questions or any clarifications, you can always make a note and can ask me the next session so that we can clarify. Yeah, do that. And I hope the 2 days has been pretty good, and it's a good interaction I had with you. I'm sure it was a very useful session for you.
It has been, yes.
Yeah, great. Okay. So we'll catch up the next Saturday. Okay, that's fine. Yeah.
Yes. Yeah, next Saturday at 9 a.m.
Yeah, 9 a.m. That's right. Yeah. So have a wonderful time with your in-laws. Have a great dinner, and have a great week also. In fact, you have meetings coming up on Saturday and Tuesday, right? All the best for your meeting.
Yeah, as a matter of fact, I'm traveling tomorrow, so.
Oh, tomorrow you need to travel. Okay. That's right.
Yeah, travel tomorrow and Wednesday night I'll be back.
Okay.
So yeah.
Oh, okay. So have a good time and yeah, that's right.
We'll speak next Saturday.
Yeah, okay. Next Saturday. Okay. All the best, Steve. Thanks a lot. Okay, bye.
You too. Thank you.
Yeah, great. Bye.
Bye.